Pretty exciting. I think like for a lot of you, I think it will be a pretty new experience. Interesting Wi-Fi names. So we have a Twitter handle and hashtag for the event. So please feel free to post about the event, and we have some cool goodies for people who do the most creative posts. Cool. So I have the hashtag here. It's hashtag GDG India DevFest 2022. Sorry, 22. Right. So do like as creative as possible, so that we can at the end of the event we can do some sort of review and then have a goodie out of that. So welcome to DevFest again. How are you all? Still the energy is very low. I think I need to bump it up soon. So how many of you know me earlier, like before this event? Very few. Yeah, I think for a lot of people it's first GDG event, right? Like not the DevFest, at least the first GDG event. So I've been with the community for 10 years now. Like 2012 was my first DevFest and first event. Like most of you, DevFest was my first event, and that's how the entire journey started. So basically, since it's a decade, I want to have a look back, what have happened. And cool, I think a few people from GDG Salem as well. Right, so I'll give you a glimpse of what is GDG on the whole, and what have we done, and what has my journey been, and why I feel like this is very important for you to attend conferences, right? So I'll probably share my journey. So that is DevFest 12. That's how the GDG's DevFest journey started. GDG Chennai's DevFest journey started. So back in the days, we used to have GTUG before GDG was done, and you can see a person right next to me, Karthik. He started this community. I think back in say 2010, I guess, like 12 years before. And so from there we did a lot of events. So that was my first event. I was sitting somewhere here back in 2012, and as a volunteer, as a attendee. And that is a group picture. So right from then, I felt that this community has a lot of things that I can take. Right, like it has been like a lot of things to me. Today I run a company with people who I found in GDG Chennai. So that is how the community has been for me. Right. So moving forward, after the DevFest, I started attending a lot of events. So we used to do this hackathon back in 2012. Hackathon done by a security community, right? So that was when I started volunteering for. When I was in college, that was my kind of an escape zone. So whenever I have the weekends, I used to go for the community and made a lot of friends. I think
we did the AR app. So usually we will get an GDG T-shirt, right? So on 2013, we did an AR app, which will show an Android bot on top of the T-shirt when you scan it. So this was way back when everyone was trying out AR.
This was way back before Snapchat was not even in picture. So that's how the community helped us, introduce, not say like introduce, but share things that we thought that could be game changing, right? So moving on, 2014 was a very important, this event especially, it was a very important moment for me because I was trying to get into this program. How many of you know Google Ambassador program, like Google Student Ambassador? Any student ambassadors? Cool. So I was trying to apply for it, and then I was parallelly volunteering for the GDG Chennai, and that's when I told Karthik saying that maybe I need to apply for ambassador, and then he told that we had other ideas for you. So that's when I actually was onboarded as an official organizer of GDG Chennai, and since things started to pan really well, a lot of events. Me and Somo did a lot of events. I think somewhere around 20 events in the next 2 years, I guess. Yeah. So fast forward, that was 2019. How many of you were there? 2019 DevFest. Yeah. Huge shout out. Nice. So that was, we didn't know that we're going to go for a deep lockdown during that period.
Yeah.
And that was like the biggest DevFest that we did. 2019, it was in Hilton, and we had speakers across India, and it was a pretty good event. And that's when actually we met. I don't know where is he, but Abhishek, right? So we didn't know who will be the successor of GDG Chennai, and then that's when we met Abhishek, right? And we brought him into the team, and then a lot of things happened. COVID happened. A lot of tough times. COVID happened, but many things changed. We had global lockdown, work from home, and remote jobs and stuff like that. But we didn't stop. So that's something that very important thing for GDG Chennai, right? Like we have this community of people, and we want to keep pushing something, to make people aware about the technology and stuff. So that's when we did Dev Sangamam. How many of you were part of it? Like, viewed it, isn't it?
Heard about it?
So I think Dev Sangamam was a good event because we brought it was much larger than DevFest, but online, where we brought in speakers from different part of the world. Since Dev Sangamam was the last biggest event we did, and then right now today we are here. So what are we taking up with these events, and why do we attend it? What do you guys think? Like, why do you attend events? Any points? I think. Sorry, networking,
Food,
yeah, food,
t-shirts.
swags, yeah, t-shirts, Domino's pizza, yeah, such a nightmare, man. So today we are not going to have Domino's pizzas. So.
You might miss Domino's today.
So what are the
monthly
things?
events for Domino's?
Yeah, we have a lot of monthly events. So we'll have a lot of news about it in the end. DevFest 2014, and I didn't know what is blockchain before DevFest 2016, I guess. And I didn't know what is cross-mobile platform before 2012 DevFest. And I didn't know a lot of things before GDG Chennai. Right, so GDG Chennai shaped a lot of, at least GDG, like on the whole, the program shaped a lot of things in my career. And I code programs because community events. So that's how the community was to me. I think the same for Soma as well.
Yeah. So I attended one event which was for Android. It happened at MIT College, and GDG was hosting it. That's the introduction of Android to me. So this was like gingerbread time, and that's when I knew there is something called Android. And then the Galaxy Y phones, Samsung Galaxy Y phones came in, and that's when I started doing Android development. And then throughout 10 years now, I'm doing that as my full-time job. So that's how GDG has impacted all of our lives.
So how many of you watched matches, the IPL matches in phones or TVs or anything? So his code is running on there. So he's working on the player part of Hotstar. So that's what we get out of the community, like the learning part. And the networking part, that's most crucial, I feel like, because we don't know who will you meet today, right? So I'm in one of the event, I met my next co-founder. I met my co-founder. I met friends like, Somu or Abhishek. I met in the events. And a lot of things happen. A lot of interesting stuff happens. You will never know. You might meet your next employer. You might meet your next co-founder. You might meet your next, peer programmer, colleague. We never know, right? So there could be people who are looking for hiring as well here, or people who could be, looking for starting a company. We have seen people start company from GDG Chennai, and a lot of stories we had. Right? And finally, sharing. That is very important again. Like, you know something, you share it with your people, and you take it forward and share it with the globe as well, right? So with that note, I would like to have this conference started. So just please feel free to promote the event. We'll have some fun activities as well in the middle. So we'll have some swags during that as well, and we could have some surprises as well. So just watch out for anything that is curious, and have fun for the day.
Yeah. So if you want, so both the tracks will happen parallelly. You can see the agenda on the website where you registered. Also, it is outside there. So you can feel free to switch tracks whenever you want between the talks. And Let's get started.
So first talk, we have Mani. How many of you use Google Cloud or any cloud for that? Right, then you're going to be having a good time with Mani's session because he is actually running the Google Cloud community Chennai. So he's actually from the GCP background, and if you want anything to be sorted on the cloud part, he's a go-to guy for you.
Ask for credits.
Yeah, ask for credits. Ask for credits. So thank you so much, guys. I'll leave the floor for Mani, and we'll get to start. We'll get the conference rolling. Bye bye.
Thank you.
How are you going to start? From your first year to start, right? Okay. Slideshow. Right. Offline. Lower. Okay. So go to close, and now you can say if you want, you can use this. Okay. And you're moving around, that mic won't be available. So
I'll use this. Both won't work.
it will throw sound into there. So better what I can do is I can connect to it.
Okay. Am I audible? Am I audible? Thank you so much for everybody being here. So, I'm Manikandan Krishnamurthy, who is a GCP architect from Tata Consultancy Services. I'm also the organizer of GDG Cloud Chennai. Right? So today we are going to look into about the multi-team platform of building the multi-team platform on the GKE. How many of here are the students? Right. How many of here are the professionals? Okay. So I pretty much see that 60-40 percentage, right? So let me give some brief about what we are going to discuss today. And if you like to catch me off it after the session, you can reach out to me, right? So as Varun has mentioned, I just like to share my path in the part of GDG. I've been one of the attendees on 2017, and where I started realizing that I have an opportunity to learn something, and I aspired to become the cloud computing. After that, I started my journey as a GCP, right? I've been with the industry of IT solution for around 13 years and practicing GCP for around 5 years, okay? So today we are going to look into about these three parts, and then we'll deep dive into the other things. Before we that, I just like to bring up some prerequisite, so I'll be so that it will get ready when we are in the talk. So I'm just doing a couple of pre-work so that I'll get the things done once I ready. So I was just trying to bring up the cluster. Meanwhile, I was doing the short introduction about that. It is a live demo. Yes, live demo is always challenging, but I want to give the sense of what we are trying to build, and let's hope the live demo is complete success. Right, set up some variables. I was kicking on trying to create a GKE cluster with the predefined configuration of machine types and about of 3 nodes. Right, so how to create GKE is not part of this discussion. Okay, so meanwhile let it creates. We'll move into what is move further. Okay? So anybody here want to describe what is Google Cloud? Anybody want to say? Right. So in general, Google Cloud is a cloud computing platform offered by Google, right? And how many of you know what are the content it's trying to solve? What are the business case it's trying to solve, or what different type of section inside our Google Cloud? Anybody want to? Right. What is that? Right. Next. Anybody else? Let's make it interactive, right? Because we are not. This is a session, and GDG is meant for that, right? So anybody else? Yes. Anybody else? Anybody else? Yes. Anything else? Right. Right. So we pretty much, if you see, like we discuss about some of the services, we pretty much discuss about the one part of the Google Cloud that is called the Google Cloud Platform, right? So let's try to see what is actually Google Cloud actually in. So Google Cloud actually have a different fleet which solves the different use case which is inside of Google Cloud, right? We have something called Google Workspace, which discuss about the workspace collaborations or collaboration tool as a suite. It is going to offer the collaboration suite for the enterprise. We have something called Google Map Platform. It is a map-based API services which is going to offer for the enterprise. With respect to Google Workspace, you probably see the Google Docs and everything is getting offered for the enterprise. With respect to Map Platform, example, if Ubers want to do some app, they want to know how to navigate. So there is something called the Navigation API, which is as a part of the Google Maps platform. And the Google Cloud Platform, as pretty much everybody covered, all these services are coming as a part of Google Cloud Platform, and there is something called Chrome Enterprise. If the enterprise want to manage the browsers or the Chrome OS of different fleet of the organization colleagues, they will be going for the Chrome Enterprise. And we have something called the Firebase. So this is a pretty much of all the verticals which is there, verticals or horizontal so-called. It is there on the Google Cloud, right? So each one have different type of services. Starts from the Google Docs, we have the map APIs or tracking APIs, and we have the computation services, networking services, and the Kubernetes services, and all those stuff which comes as a part of the Google Cloud Platform, and the Chrome and OS, and we have the Flex. There is something called the Chrome Flex, and that is something for the Chrome. And with respect to Firebase, it is a mobile backend as a service. Varun, who has been in the talk before, right? He is a Firebase GDG, right? So, how many of you know all these fleets in today? Anybody know all these fleets early? Right. So, this is something which I like to give a glimpse. It is not something about the computation or doing something the processing power. It's how the different fleet, right? So, let's try to deep dive into what is GKE is, right? So, what is GKE? Right. Where it's, if you, as a part of verticals, or you see in multiple verticals, right? Where the Google Kubernetes engine actually stands? What is that? Okay. So, the Google Cloud Platforms, right? So, under that we have something called compute. So what do you understood as a part of Google Kubernetes engine? What is that? Right. So what is meant by orchestration of containers? Right. So we have something called Kubernetes, right? Already, which is there as a fleet of it. And what is a Google Kubernetes engine trying to offer? What is trying to solve it? What is meant by fully managed service? Right. Yes. So pretty much all the answers which we got from our friends are something which is relevant to that, right? So if you pretty much see the Google Kubernetes engine, it is something like a managed service of Kubernetes. So anybody try to describe, as you already said, what is the differentiator between the Kubernetes and Google Kubernetes engine, right? Who actually owns the Kubernetes now? So just I want the complete name. Right. And so we have something called CNCF, and all the cloud providers like Google, Google, Azure, and AWS has started offering something like a managed service. What is the link between these two? So what is the link between the CNCF and all these providers? What these providers are actually doing with the Kubernetes, and what is meant of offering the services? What is the link between these two peoples? Right. So as you pretty much says, right? So we have something called, as we know that the Kubernetes is something like which has been put forward, the concept is put forward by the Google as part of their own experience. So what has happened is the Google and the Kubernetes, which has been solution which has been offered and been put forward by Google, it has been given to something called a Linux Foundation, and then the wrapper of the Cloud Native Compute Foundation was started, right? So what has happened now is, if you want to spin off something like a Google Kubernetes engine or managed services of Kubernetes, any of the vendors, whether it's going to be Azure, AWS, or anybody else, right? They need to be get certified by CNCF. You probably say that whenever you go to the website of Google, it will say like it is certified by the CNCF. When you try to go for Azure, you also see the same thing, which is a different version. What is get certified, and every version which gets pulled into the GKE, it is getting certified. It is adherence to the governance of CNCF. So is it clear? Is it clear? Am I clear with that? Right. So what it actually happening in the industry is, we have something called virtual machines very long back, and we have something called on-premises long back. And before that, we have on-premises virtual machines, and then we move to the app engine and all the kind of computation services. What is presently happening is, Kubernetes becomes a standard for infrastructure. So nowadays, the industries are moving towards something like they want infrastructure to be managed by Kubernetes. They want only to be concentrated on the workloads of the application. Right? Is it clear? Right. So if you are the student or if you are the professional who's trying to understand that what I should do, what is the next part of the career, right? I was in the similar time, I would say like 2017 or before that, right? I was in the similar situation, and when I try to understand, when I try to go into all the fleets, I was getting into the Google Cloud, but I started as a virtual machine implementations, and after I then moved to the app engine and all those stuffs. But if you want to try, if you're going to start something now, right, you can have two fleet of things. You can go for the flavored version of, or the managed version of Kubernetes, or in one of the cloud, or you can go for the administrator of the Kubernetes, which is offering by the CNCF. There is a two type of certification used to be there. One is if you go for the Google, we have something called a architect certification, and if you go for CNCF, there Kubernetes administration, right? If you're going to start as an infrastructure architect, I would say like you should consider of the Kubernetes, right? Is it clear? So any questions here? So could you please start? Anybody here just spell out some of the advantages of? Just let me check. Could you please spell out the advantages of the Google Kubernetes engine other than the managed services? Just put it technical this time. Right. Next. Okay. Next. Right. So you guys pretty much covered. So when you say as a managed Kubernetes and what is the difference between Kubernetes is, we have in the Kubernetes we have something called two type of thing. One, we have something called the master control plane and the node control plane. So node control plane where we usually run the nodes, run the node pools, and where we are going to run our workloads is going to run, right? And if you go for Kubernetes as an implementation, you should have to manage the master control plane as well as the node control plane. But when you try to go for the Google Kubernetes engine, the master control plane will be managed. Master control plane is managed with the Google, and the node control plane will be managed by our own projects. So is it clear? And you probably may try to understand how the version is going to maintain, because the Google is going to maintain the version of the master control plane. I will have something called 1.25 of the GKE, 1.25 version of the Kubernetes. And when you try to manage the node pool, I may have 1.23. Right? How the thing is going to be done? How it generally happens is Google is trying to push off the version which is not getting deprecated, which is not creating a conflict with the node control plane. If there is going to be any issue is going to happen, there is a conflict it is going to observe, they are going to put the alert to the respective administrators and says that there is a conflict, so we are not going to push it. But it is not going to be very wide fleet of time. You should be 2 to 3 weeks, you have to push it, right? Because of the security things. So I have just listed off few of the things. So some of them already said. The very easy clusters creation, and we have something called load balancing, and we have something called auto scaling and auto upgrades, which we have discussed, and auto repair logging and monitoring. So these are some of the advantages in going for Google Kubernetes engine. And if you probably notice, like the logging and monitoring, which is actually directly getting related, directly linking to the other services, which is as a part of GC. And if you want to see the logging monitoring, you can always push this into the Stack Driver monitoring or Google Cloud monitoring, and you can see the logs. So those are some of the things. So what is the problem here? What is the problem? You guys seen, right? So we have a good number of advantages here, and what would be the problem? It is making it easy and creating the Google Kubernetes engine, and we have the easy way of creating the Kubernetes cluster, right? What is the problem? Anybody like to? So we have seen the advantages, right? So what is the problem we observe in the enterprise? Right? It is not a problem with the GKE, right? So I would say like, there is not a problem with the GKE. What is the problem which you are seeing in the enterprise? Anybody like to take it? No. Let's, because of the advance, these are the advantages, right? We've seen that, right? So what is, do you feel like something else is Okay. So do you see that something is trying to create to the enterprise? What is the enterprise actually facing a problem? So other than the database and all those stuffs, so let's not discuss about the workload which is running on the GKE. Let's discuss about this computation as a source, right? So GKE is providing these sort of opportunity. What is the enterprise is actually facing a problem? What is that? So resource sharing, so might be, but I'm not pretty much clear. So how about that other? No, because it is making the auto upgrade, right? So then it's not going to be a bigger issue. Yes, you want a mic or something? What is that? So I'm not able to hear you. You're getting the mics.
So bloated logs, like there is too much logging, like everything is being logged.
Okay. So anybody else? No, it is already upgrading the auto upgrade, so there should not be any security things. That is why it is going for it. Anything
Infrastructure
else?
maintenance.
So who is that? Like, could you please elaborate what you refer as infrastructure maintenance as a part of GKE?
So if we have to maintain, like orchestrating Docker images in our end, in the sense we have to maintain the servers in our office, and if we have to host application in other parts of the country, then I have to maintain the server in that particular country. So all those things we can avoid if we use GKE. So GKE takes care of that.
No, that is a DKE's advantage, right? So again, you are referring to the DKE. I was trying to understand what is the problem, right? We should something have a problem statement to solve it, right? Okay. So what is a problem as an enterprise architect like, the platform architect like me, we are seeing in the production is this. Everybody started creating GKE. If you see, like we have 100 teams, each team is creating one GKE because it is easily able to create. How many of you agree with this point? So raise the hand. Right? Because it is providing an opportunity to easily create a GKE. Every team is creating their own GKE. Just consider that if we have around 50 teams, and each team is going to have around 10 node clusters. What would be the entire node time? We have approximately of 50 into 10, it's 500, right? You got a point, right? So the utilization of what will happen to the cost? Because as it is provided an opportunity to create a GKE or a Google managed version of the Kubernetes in Kubernetes, everybody has started creating. Every team wants to explore that, and they started creating it, right? So this creates a very high cost problem, because if you go for team 1, who will happen on the GKE 1.23? If you go for team N, they might have a GKE port 1.25. It is a problem, because CNC says that it has to be maintained at 1.25 for the future to be upgraded. So we have something called operational, because each and every Kubernetes engine has to be managed by the separate team. And we have something called the computation resources gets increased, and the high amount of cost is getting involved by the organization, and we have security implications. How many of you agree with this? Develop. You probably can realize how much cost is going to be involved in hundreds of K in USD. Right? It is very pretty high, right? So there is so to solve this, these are something else, right? So operation, as some of the people have said, we have cost incursion, and we have something called security, and we have something called connectivity, so which I have not touched it. What is connectivity, right? Example, you have on-premises network, and somebody wants to connect from the Kubernetes engine to the on-premises, because you are running some application on-premises, and we have something called Kubernetes which is running on the GCP. Just consider that 500 clusters is trying to connect the on-premises. What will happen to the on-premises? Right? You should have a dedicated interconnect between those two things, and all the routes is tries to go into it. Right? So, and you cannot put multiple interconnect because it's very costly, right? So we cannot do that. So these are some of the things, the problem which I noticed as a part of GKE implementation as an architect, and what is the solution for that, right? So there is something which we are going, this is a problem we are trying to address, and which is a problem we are trying to solve. Right? This is something called the multi-team governance, or multi-tenant governance, or multi-user governance, whatever the term you put, because the industry have different names for this. What is the solution for this particular challenge is, as a GKE and as an architect or cluster administrator or namespace administrator, let us control the GKE and the platform APIs and creates the tenant team's sandbox, and they have only have an operation to run the jobs. Right? Example, I am the cluster administrator who I am going to create one cluster of GKE, and I will declare what is the API version I want to do. Example, if I want to create a fast DNS, I will define what is the controller I supposed to have, and I will create a sandbox, or also known as high level we can say like it is a namespace, and I will give it to the respective team. They have only opportunity to deploy the jobs or the workloads for them into that particular namespace. Is it clear? we are going to differentiate, right? We have something called cluster administrator, who is going to ensure that cluster security, compliance, everything in track. And we have something called the team, who is going to just deploy the applications. Does it make sense? This is governance, right? So we have lots of principles, again, all those stuff, right? So let's not go into debate. Do you guys feel like I'm making sense somewhere? Right? This reduces the cost, and this is also going to reduce the security risk because I'm going to take care of the clusters. The job is going to take care of it, right? And this is something like a centralized way of handling it. So you can ask me whether the nodes cannot increase. Yes, the nodes will increase, but it's in a very controlled way. Because if you're going to create a cluster with the 5 nodes, and if you're not going to utilize it, by the default value of 5, you still have to pay for 5. Here the cluster will only expand only when the workloads gets increased. Is it fine? Is it clear? Right. So this is a very high level thing, which is have something called GKE, and we have something called multiple namespace, which offers for the multiple team. And I have something called the deployer, and I'm going to ensure that I'm going to deploy the namespaces, and which is have their own jobs, which is going to run. I'm going to have the external registry where I'm going to maintain the policies. Right? So this is a very simple architecture. So this is general architecture, right? So this is general architecture which I took. So what we are going to do as a demo is, we are trying to replace some of the components with some of the guys which we already know. There is something called Argo CD, which is a continuous deployment tool. And we have our friend always GitHub, where it's going to have the configuration. So let's see how we are going to implement. Can we go it? Right. So I just created a thing. So before this call, what happened? So before this call, I just tried to create this Kubernetes engine. Just created the Kubernetes engine based on the script. So this talk is not with respect to how to create a Kubernetes engine, right? So you have all the documents, right? So I created the Kubernetes engine, and now I'm going to. I have some simple repository where I have small repository where I was have something called the namespace configuration. Here I have 3 files, 1, 2, and 3, where if you go into that, I'm just putting some names for the namespaces, and I'm just enabling the resource quota for. So for this example, for this demonstration, I have 3 tenants. Says like tenant going to a tenant or the team going to use namespace 1, namespace 2, namespace 3, and probably the namespace 1 have one another configuration, which is something like a namespace 1, and there might be some other namespaces, which is all configurations already have some other namespaces like namespace 2. So we have 4 namespaces, and 1 namespace have resource quota. Is it clear what is the configuration is? So here let's not go into deep into quick time check, right? Let's not go deep into what is how to define this thing, right? So if you see, like, this is the this is the Cloud Shell IDE, which is coming as a part of the Kubernetes Google Cloud. So I was trying to authorize it, and just try to bring up my guys, right? So right. So right, I have 3 nodes cluster, and where I was trying to see what is the namespaces. So I have only 5 minutes looks like, so let me go into it. So I was just trying to see what is the namespaces I have, and it shows like, and then I was trying to create one namespace called service namespace for Argo CD, where this is deployed. So all these codes you will get it, so no issues. And if you try to go and try to see what is the namespaces, you probably have the something called the new guy which just comes into the Argo CD. So now I'm going to deploy the Argo CDs, right? So Argo CD is a continuous deployment tool, which just comes as a part of the CNCF, right? I was just trying to create deploy the Argo CD. Everything goes good. We'll get the Argo CD now. So let's see what is happening. So, and Argo CD, if you've not been, it is a declarative way of DevOps, continuous delivery model, and it is a CNCF product. I believe it is an incubation project, but you can very well use that, right? And it is creating some of the resource. That's okay. Let it comes, and I was trying to see if it is something comes off. Let me try to quickly patch to bring up the external IPs. Where's my uploads? So these are some of the things which is this gets deployed by Argo CD. So this is you can get this information or you can get this installer from this particular repo, and so this information will be given to you shortly, right? So I was trying to deploy the Argo CD, which is going to help us on managing it, and this is the external link which is created. So if everything goes good, we'll get the Argo CD up. But let's wait for time. And right, so I'm trying to find the passwords going into it. So this is the Argo CD which we deployed here. Come on. Which is running on this cluster. And just to give you the sense, so pretty much enterprises are using Argo CD. If you have an opportunity to work on Argo CD, you have very good DevOps implementation also, because Argo CD is getting used on DevOps, right? So it's a GitHub ways of working which is on the fleet. Right, so this is right. So we have created the clusters and we have implemented the deployment services like Argo CD, and we are trying to see how we are going to use this configuration to create the namespaces. So new application, and where is the repo? So I'm going for the repo. So I'm giving the repo which is publicly open, and should give the path. So namespace config. Right. And I'm giving that deploy on this cluster where it is running, and I'm asking to create the application. Right. So this is the application we just created. If you see that what it says is you provided me some declaration, but nothing is synced on the application. Nothing is synced on the GKE. Is it clear? Right. If you try to see, and if you try to go to the namespaces, you can probably see what are the namespaces available, and we don't have something called the tenant namespaces or the namespaces created for the team, right? So when I try to sync it, it will ask to give some heads up because it is going to be a cluster. This is how the administrator actually works. When I try to sync up, it takes time and it gets deployed, right? If you try to see, the previous output is this, and we doesn't have something called the namespace 1 and namespace 2 and namespace 3, but that is got deployed before 7 seconds, right? So if you see, like, by using this continuous delivery model, using Argo CD as one of the tool, by putting the configuration on the declarative way, we used to be able to create and manage the cluster administration, and we are going to be able to offer the GKE for multiple teams. Example, the team namespace 1 can be used by the one particular team 1 for HR purposes, and other things gets used. Is it clear? Right. And even if you try to do some So let me quickly. Yeah. So I think I'm running out of the time, and right. So even if you do some modification here, modification on the code, and the Argo series says that you are in out of sync, and you will get an opportunity to sync. So we have examples say like we have around 100 customers or 100 users. You can easily manage everything here. Is it clear? Right. So, and it is a declarative way, and you can read more about that. And so if you want to learn more about the Google Cloud, and you can have this this is one of the community which has been as a part of GDG, and we have another community which is something like a CNC for the cloud, CNCF. And CNCF is a very new community and pretty young, and so if you like to know more about the cloud native, you can come here. And these are some of the reference docs, and this will be helpful if you want to, if you have starts your career as GK administration. These are some of the reference which impressed me to
has not come this way before. Settings. Here, Chrome. This. Yeah, Anush's iPhone. Hotspot. It's not connecting. Is this switch down here? Password photo vechirukkiya? Password photo vechirukkiya? Wait, I'll just present offline. Hello everyone. So we are from Freshworks company, and I have with me Arumugaraja and Ritikesh, and I am Anush Arvind, and we are here to talk about how we have scaled our product from around 10k RPM, which is requests per minute, to around 150,000 requests per minute today. So back then were the good old days when we could actually send commits straight into master and do deployment right from my machine right away, and take code changes on easily, and that was like the startup phase that we had. But since then we've gone into a more mature, evolved product, and we are targeting enterprise customers, and we have too many types of requests coming in and too many new features coming into our product and so on. So it can't stay in that way. So what all have we done over the last 6-7 years to ensure that the performance and the availability of the product does not go down, and we continue to deliver the proper customer experience always. So I'm here to talk about some of those practices. And I'll give a brief introduction to our product. So we work for the Freshservice team, which is an IT service management product, and it has the common service management features like IT service management, asset management, operations management, service catalog, and so on. So let's take the journey of Freshservice. We always obviously want more revenue. We want our product to grow. We want to target more customers. We want to deploy more features and so on. That is obviously going to increase the scale at which our product operates in production, obviously, right? But does that also bring room for more issues? Yes. So we have to ensure that our product is able to scale properly and ensure that live production issues does not occur. And you can't put a complete lid on that. So even if you have issues, what can you do to ensure that the impact of it is minimal? These are some of the things that we need to ensure. So mainly the learning from this is that the product and architecture should be tough. It should be able to withstand all the issues in production. It should really scale. So what all we need to do about this is that we need to ensure that the blast radius when issues happen are minimal, and we should also ensure to prevent issues. So let's take a look at this server's architecture. We have 3 servers deployed. Each are running at 70% utilization, and we have them deployed in 3 zones, zone 1, zone 2, and zone 3. and all three are running stably at a 70% utilization. So can anyone tell me if this is okay, or do you foresee any problems in this? Anyone? Exactly. So when things are going normal, you have the proper distribution of traffic and it runs fine. But consider zone 1 goes down. Now 35% of the traffic is going to be distributed between zone 2 and zone 3, and that hits their utilization percentage. So they cannot scale. So it's like this. Servers can go down, things can go wrong in production. So how does your application and infrastructure react to it? That's the main point here. So let's take a look at some of the problems we can face. The servers can end up having high CPU utilization, high memory utilization. Your database instances can have a similar high utilization, which will lead to your queries running slower. You could have written some bad code that went into production. Not always the proper code gets through. And sometimes you can just face too many requests. Or you can have application with too many objects in memory, which presents problems to scale. So also I want to add that Fresh Service actually has a multi-tenant architecture, where in the same database we have multiple customers' data coming in, and one customer's traffic can affect another customer's request also. So how can we make sure that that does not happen? So in a multi-tenant architecture, you should ensure that any number of tenants that you run with a common set of compute servers, everyone gets the same performance delivered, and one cannot bring your application down. So some of the solutions that we can talk about here are you can employ a buffer set of servers. And if you have asynchronous job processing, you can think about processing them at a slower rate or restricting them. And you can also think about automating those. So let's take a look at some of such solutions. Typically, what do SaaS companies implement in production today to ensure that they put a tap on the number of issues that come and the way to handle issues? So some people employ a buffer set of servers, and some employ a shell architecture. So let's take a look at both the architectures and what could be the problems with both and what we can do to come around them. So this is a buffer architecture where you have a load balancer and you have groups of transactions grouped into various set of servers. You have the traffic going in this way, and people usually put a set of buffer servers where in case of problems they are going to add scale up the buffer servers and point the traffic there. So a couple of problems here is that you always have additional set of servers running which you don't really have use for. And also if the traffic that you've pointed to the buffer servers itself is too much and it can't take it, that's another problem. So some people go one step further and they employ a shell architecture, where the previous architecture that you've seen here, this entire group is actually for one tenant group, and like that you have 3 groups and multiple tenants are grouped to one shell. So you actually have some sort of split between each of the tenants, but still the problem here is you have too many tenants in one group, and one tenant causes a problem. That's again, it's not going to affect the tenants in other groups, but the other tenants in the same group, it's still going to get affected. So this is when we sat and thought back and came up with a hybrid sort of architecture between the both. So what we have here is something called the buffer layer, where every set of tenant group or transaction group that you have a buffer server for that. But you can do 2 things. Either have them scaled down, or in this way make them pointed to your normal application traffic itself. And when you face issues at that point in time, if you can have an automation in place to update solution, say you have a proxy server running behind your application servers, in that place update an ACL to just split the traffic between your buffer servers and application servers and ensure that both of them can scale independently. So this sort of hybrid solution is going to help you face issues and tackle them right in production. So to run through this, say you have a proxy server running, we have HA proxy. This can be your Istio or your load balancer, whatever. And at that place, you need to have the ability to update dynamically. And at normal times, all the traffic goes together to all the servers combined. And you can either have the buffer servers as a part of your application stack or scale it down and scale it up upon need. And during times of issues, point it this way. Split the traffic, and with this you can essentially achieve tenant isolation or transaction isolation, and the poorly performing transactions or tenants get isolated to that level, and it does not affect the other traffic. So how next we can go one step further and achieve automated isolation? Here's an example. So we have our application hosted in AWS, and RDS is the database system we have, and SNS is a notification service that we have. So consider we have multiple database servers. Consider one server goes down or it is having high CPU utilization and the queries in it are performing poor. So what typically happens is that all the transactions coming to that are going to perform very slow, which will cascade to the compute layer. Now the transactions that are supposed to go to other servers which are completely healthy, those also start performing poor. Your customers start facing latency. So how to achieve isolation in this case and how to do it in an automated way. So RDS has events that you can tap into which will send out notifications upon failure. So you receive that into your notification service, which is SNS, and send a webhook to a tool that you can run and have the decision making logic there. There you are now going to understand that, okay, this particular database server is problematic and let it not affect the other transactions. So point the traffic that comes to that database alone to a buffer set of servers and scale them up independently. And if you automate this entire process, when you face a problem, you don't need notification to be received to the SRE team and they need to log in and go do this work. The entire work is automated and seamlessly you can tackle issues. So this kind of a hybrid solution does help a lot with incoming issues. So consider you don't have any issues running. You have normal traffic, but there's a lot of variations in that traffic. Now, what you can do with that to ensure your product scales properly. So, Arumugaraja here is to talk about the next topic. Yeah, tell me. The question is that what if it's a read-only database? So actually we have two types. We have master database, we have read-only database also. So the write request will go to the master database and the read request will go to a separate read replica of this master database. So consider any one has a failure. So you see the entire group together, the master and the read replicas, all the traffic that comes to that, point the compute of that to the buffer set. So I'm talking about scaling up the compute server. So we are talking about isolation here. So even if you scale up, you are not sure about the database, and scaling up the RDS can sometimes have a downtime depending on what setting you are trying to update and so on. So we are saying instead scale up the compute server and isolate that traffic so it doesn't affect the other traffic. Is that clear?
In the previous slide, when you put a buffer server in between, what happens to the sequencing? Say, for example, the particular application needs sequencing, right? So there will be a problem, correct?
So that's where you need sequence to be maintained for a particular tenant, right? So in that case, the decision-making tool should ensure either if you're pointing the database's traffic fully to the buffer set of servers, your tenant's complete traffic is going to go there. So the sequence get maintained within that buffer routing itself. And you should make sure that you don't split the traffic within a tenant. So if it is a problematic transaction, that transaction for that tenant should completely go to the buffer server. So again, the linearity of the transaction is maintained that way. Okay. So it's all about making the right decision. So this decision making toolbox that we see here is actually a microservice in itself that runs and properly decides what it should do based on the traffic that is identified as problematic.
Thank you.
Is that clear? Yeah. Any other questions?
So I'm not clear about the ACL part here. So is it like you have, so I assume ACL means access control list?
Yeah. Basically what that does is you have types of transactions, you have various databases, you have various different types of paths in your request. So it's basically a mapping that says these kind of requests or these database requests or these tenants requests go to this set of servers.
Okay.
So if you notice here, we have various tenant groups, or in this case we have various transaction groups. Okay. So each of this, basically how do you decide which traffic should go where? That is what this ACL means. So there should be a decision making server in between here. You can employ that in your proxy server itself. So both HA proxy, Istio or the load balancers, they have the ability to take in such configuration and do the decision making for you. So in that you can go update another setting where you have checks to ensure that if it is this particular traffic, go here instead, don't go to my main servers, and give problem to that set. It's like that.
Okay. So so basically ACL is being used for routing.
Yes.
And in addition to that, you are also dynamically updating ACL.
Yes.
With whatever the happening, like DB.
So that's the main key here. So it's not like you receive a call and you go debug what's wrong and you do it. The entire process is automated, so you don't end up facing request queuing or a downtime or so on. Your application reacts fast enough to issues.
Okay.
That's the main idea here.
Okay. And then the second or third slide, you mentioned something as BG. What it means?
Yeah. So we have, so your application can have front-end requests, and it can also have a set of asynchronous job processing that need not wait for the customer need not wait for the effect of it to be shown in the web portal itself. Like consider you do an update that sends out an email. So that email need not, the page that is supposed to load need not wait for the email to be delivered. You can load the page and say email will be delivered to you. Okay. And that can be an asynchronous transaction. So like that we have a very powerful set of background features that run in our application as well. So the coming talks we'll be talking about some of the implementation we have in there to take care of issues.
Okay, thank you.
Yeah. Any other questions? Great, thanks everyone.
Thank you, Anush. So, can you guys hear me? Yeah. So, with the Anush task, we can able to see how we are actually handling the problematic transactions or the set, how we are routing the set of specific tenants to separate buffer layer. Now let's see, we have sudden spike in our RPM. Let's say we actually grown from 10K RPM to 150K RPM, and we can't always say we will expect this much of RPM only and let's run servers for that to handle, right? So before going into that, from the first talk, I can understand a lot of people are very familiar with the Kubernetes. I wanted to give some explanation about the terms that I am going to use for the new people who are not familiar with the Kubernetes. So one thing is pod. Pod is like, it is an equivalent to the virtual machine, which actually runs with set of containers. So that actually does the work that you want to do. And the pods are actually deployed using the deployments are replica sets. So this is set of pods. So this actually expect the replicas number, which we, based on that replicas number, it will actually scale the number of pods it needs to run. And the next one is services. The services is actually routing the traffic to the deployment. So there are different type of services available in the Kubernetes, like cluster IP and load balancer. So each of it has its own benefits. And yeah, now let's see here. So this is actually our throughput pattern for particular layer, and this is actually a response time here. So when there is a sudden spike in throughput, earlier before auto scaling, when we did not have auto scaling, when there is a sudden spike, this can be due to spam, or this can be a regular traffic, like there can be multiple businesses relying on us. So there can be some issues in their end. Because of that, there are a lot of alerts are coming to us, or tickets are being created in our set. So we can expect too much of traffic in at any point in time. So when there is a sudden spike in RPM, and we notice there is a sudden spike in response time and leads to the request queuing. The green color here is a request queuing. The requests are piled up in the queue. So because of that, the customer will notice the latency in using our services. So to handle these things, we wanted to do a auto scaling. Based on the traffic, we need to scale our servers without relying on someone to scale this. So let's say you may think that if you are receiving 50K for one particular layer, why can't you run this number of servers which can handle that 50K prior to avoid these kind of request queuing? So for that, so this is our all layer RPM together. So if you see here, we are reaching around 170K RPM during the peak hours. And when you see in the weekend, it is around 30K RPM. So, and in the non-peak hours during the weekdays also, it is like 100K. If we want to run the max servers at always, we need to run the servers to handle that 170K RPM. But when during the weekend, the same servers will be running and it is less utilized and there will be a cost increase. So as an SRE, we have to handle both the load and also reduce the cost. So we wanted to have auto scaling. So since we are in the Kubernetes, that default horizontal pod autoscaler actually helped us a lot. So, and our actual pod uptime is around 60 seconds to 90 seconds. So when we are doing a scale up, it will be available to serve the traffic within 90 seconds in the worst case. So HPA is horizontal pod autoscaler. There are two types of autoscaling you can do. One is vertical and other is horizontal. Vertical is nothing but with the same server, you will be increasing the memory or CPU. Horizontal is you will be increasing the number of servers or pods here. Number of pods to handle the load. So this Kubernetes provider HPA works with the default metrics, which is nothing but CPU and memory, and custom metrics. Custom metrics is you can have your own metrics, and external metrics is the metrics which are available outside your cluster. So here the example here I have shown is the first one is the HPA name and the deployment reference. To this HPA has to scale the replicas in this particular deployment, and these are actually the metrics which it needs to look for scaling. The first one here is actually a RPM, and this is actually RPS here. Every second it has to calculate the RPS and trigger the auto scaling immediately, because if you are waiting for 1 minute duration, there can be a request queuing before that itself. And the second one is actually a request queuing. We actually initially we wanted to scale based on the RPM, but while our discussion we thought that there can be a low RPM, but because of poor performing transaction or because of any issue in our database, there can be a increase in response time and can lead to request queuing. So because to handle the both, we actually combined both RPM and request queuing based auto scaling here. So here the HPA will take a decision based on if any one of these reaches their threshold, it will actually triggers the scale. So here it is the min replicas. This has to be run to handle the minimum load, and it will be running always. So to have a high availability, we are always running with 2 replicas always. And this is actually a max replicas to which it has to scale. So based on our regular RPM pattern plus 20% of buffer, we decided this max replicas. And this is the number of replicas that HPA has decided to run at this point in time. Yeah. So these are all the main components in the auto scaling architecture. So first one is the Prometheus exporter. That is the source which actually export the metrics. We are actually using the open source Prometheus exporter gem. So this will be running along with our application pod as a side container, and it will be exporting the metrics in Prometheus format on particular port that can be configured by us. And there is a service monitor which actually looks for the metrics from the service which is actually serving the traffic of the particular pods. So let's say I have a /metrics as endpoint, means this service monitor will be configured to hit the /metrics endpoint for that particular service. And the next one is Prometheus server, and this actually scrape the metrics from the service monitor based on the label selector. It won't scrap from all the service monitor. Wherever we are, based on the label that we are configuring, it will collect the metrics from the respective service monitors and have it stored in the Prometheus format in this one. And this Prometheus service will be running as a cluster IP service here. So, which won't be accessible outside the cluster. It will be accessible only inside the cluster. So, then the metrics that we are exporting won't be available outside. It will be available only inside the cluster because all our components are inside the cluster and the decision for auto scaling is also happening inside the cluster. So, the next one is custom metrics API server. This is nothing but another deployment which is actually providing APIs to scrap the metrics that are stored in the Prometheus server. So, and the previous slide I have shown the HPA reference, right? So, that HPA will trigger the APIs to the custom metrics API server, which will be collecting the metrics from the Prometheus and respond to the HPA. And based on the configuration that we have, it will decide the auto scaling, whether to scale up or scale down. And this is our RPM for one particular layer. So, it is actually growing for every 5 minutes window. I think it is not clear, sorry for that. And for every 5-minute window, it is actually increasing. And if you see here, these are our HPA desired replicas. Initially, it was running at this point. Whenever there is a scale in RPM, it is actually scaling up. And to avoid, like, there can be a sudden spike and immediately it can go down, right? So instead of scaling up and scaling down immediately, there is one configuration available in HPA itself. Like, you can configure like 300 after 300 seconds, only you can take a decision on scaling down back. So that also you can use to avoid these kind of sudden spike up and down cases. So, so far I have covered only the Kubernetes based auto scaling. So if you are in AWS EC2, you can use ASG auto scaling group and configure auto scaling in that based on the CPU or memory metrics. And before this e-case, we were in OpsWorks. At that time also we have configured auto scaling based on the time and load based. Since we know during the peak hour, this is the time at when the RPM is going peak. At that time, based on the time, before around 10 minutes or 20 minutes, we will be scaling the server to make it available for the load. But with HPA, we are able to handle based on the current load. And not only for the application server, we are doing this. For the background server, also we are doing this. There, the base metrics are like latency in picking the jobs from the queue or the number of jobs actually piled up in the queue. Actually, both are same only. Like if there are more number of jobs are being piled up within the same minute, means also that the latency will be less. But worker needs to be worker that are needed to process those jobs are required more. So at that time also we scale. Let's say the pileup is happening slowly and workers are not able to process in the same rate where the NQ is happening. At that time the latency will increase. So to handle that also we are having auto scaling in the background workers also. With that said, I would request Ritikesh to take it forward.
Hello. Yep. Thanks, Aru. So I'll take it forward from here. So with the HPA that he just spoke about, right, for both the app layers and the background layers, one must think that, yeah, we are able to scale infinitely now and there shouldn't be any billing or compute layer infinitely. Sorry, who was that? Can you raise your hands? Yeah, you're right. So eventually there will be layers in your system that will not be able to scale horizontally beyond a point, right? So there will be choking points outside of compute. So here is a very simplified version. Our background architecture is much complex than this. This is a very simplified version of how we enqueue jobs to the background, and a server sort of distributes the load evenly depending on the type of job that we have. Right? There could be some very heavy jobs, or there could be some that we need to be processed real time, etc. So as I was talking about earlier, if you continue scaling infinitely, there will be a point where your background servers will start choking. And what are the kind of problems that we face, right? So The first kind of problem that we faced was with, as Anush already mentioned, ours is a multi-tenant architecture. So customers are being served by the same application, like it's a single deployment. So in that case, if a single tenant, right, if a single tenant has a problematic integration, or they are sort of writing too much into the database, they might start piling up erroneous jobs, which might increase our dead set count. And then there could be other kind of tenants who are just, they're onboarding right now. So they might be coming from another system and might want to sort of import their data from their existing system into our system. So you might see a large number of jobs that are enqueued, but who are also processing very slowly because a lot of write operations are happening at the same time. So that's the second category with slow jobs. And the third is basically just with HPA, right? When there is a sudden spike in traffic, there might just be too many jobs that your background servers might not be able to handle. Again, the side effects are the same, right? If one tenant causes problem, the entire application will start having problems, and customers might start seeing latencies in their emails or other kind of automation jobs. So I'll briefly talk about two kinds of sort of error handling scenarios that we do. The first one would be where I spoke about too many erroneous jobs that are enqueued, right? So if you notice the last metric on this dashboard, it talks about the dead jobs. So at this point in time, we had close to 30K dead jobs, and the way our background servers pick up jobs from the foreground is we sort of enqueue a message to Redis. We use Redis for the message passing. The app layer basically sends a message via Redis to the background servers, and the background servers listen to those and start processing the job. So the entire job's meta information is sort of stored in Redis. Now with these many dead jobs, our Redis memory will start bloating, and eventually it might run out of memory or a CPU spike, causing failures not just at the app background layer, but also at the app layer, and customers will start seeing 500s. So this is one kind of a problem. And the other kind of problem is when, say, as you can see at the bottom, there was an outage with one of our internal platform services, which eventually had resolved at this point, leading to a sudden surge in huge traffic, causing a heavy load of jobs on our side, which is again the too many jobs problem, right? And we had to process all of them at the same time, causing to database choking points, as you can see in red, as highlighted in red. So, what are the solutions for these problems, right? The first I'll talk about is BG restriction, wherein basically when the app sort of starts enqueuing the job, we have a check place at that point where we sort of check if this account is causing too much problem for us, and if so, we sort of put them in a restricted list. Now for this we are using SQS, which scales infinitely, and we also have an option later to sort of either process these jobs at a later point in time because the customer would have gone back and fixed his integration, or we can just choose to delete them, like, hey, the customer can retry those later. And the best part about this is all of these are automated via our observability alerts. So as Anush would have earlier shown you a microservice which takes care of decision for routing, right? So that similar microservice also does this, which basically will set restriction, and this restriction can be at a queue level or at an account level. The second problem that I spoke about earlier was the jobs processing too slowly, right? And if there are multiple jobs that are processing too slowly, there can be an easy pileup. So if you look at our architecture, there are the server sort of enqueues and picks up jobs from all of these different kinds of queues. But if, say, for example, the bulk server has too many jobs to process, in that case, what will happen is our real-time servers will also start picking up jobs from this to avoid the latencies, which could have side effects wherein the real-time jobs now can get lagging behind, right? So to address this problem, what we did was we introduced another middleware at the enqueuing layer, wherein we sort of look if this queue needs to be, or this particular job needs to be moved to a slow processing layer. right? Again, this is also automated. So when the job is getting enqueued from the app server to the background server, we will have these checks in place. And if it has to be a slow queue, or if this job needs to be processed slowly, we will sort of push all the different kinds of jobs into a single queue, and a small set of servers will process those jobs independently, whereas the other set of servers will continue processing your regular traffic. And this is also in the background powered by SQS. And that's about it. If you guys have any questions, I can start taking those. Yeah. Mike. Seri parala.
You mentioned like there can be bottleneck which can happen when Redis can't handle the queues, right? And for which you're using SQS,
right?
And you mentioned it can be scaled unlimitedly,
right?
So in which case, why can't we use SQS for all the queues?
So one, there's a cost factor to it. Redis offers us lesser latencies, and we sort of host it in-house, so there's no extra cost involved there. It's also much faster. With SQS, you have no control, right? One fine morning you wake up, your bill would have gone like crazy.
Okay.
So that's one of the...
So it's purely cost factor.
Yeah.
Okay. And is it like your applications will be listening on multiple queues and each have their own priorities?
Sorry, can you come again?
So your application will be listening to multiple queues, like it will be listening to Redis or SQS or...
So SQS is more like when we are okay with re-enqueuing or clearing those jobs, it's a manual trigger.
Okay.
So we don't directly process jobs from SQS. That is more like a manual thing that we look at as a post-incident analysis.
Okay.
Primarily, it's Redis.
Okay. Yeah. Thank you.
But for other use cases, we actually do have SQS to Lambda triggers, which will again call our internal app servers for other use cases. Any other questions? Okay, thanks guys.
Thanks everyone.
Perfect. So next up we have Praveen, who will be talking about orchestration. Before that, we have an activity. I want you guys to, someone from you, we have a goodie for that. Name 5, best places in Chennai. How many of you are not from Chennai? Probably this could be helpful for your Sunday if you're staying back. Any, I just want a shout out. Like whoever shouts out first gets the mic. I think that is a. I think 5 places. Yeah, 5 places.
Okay, so when you're out with friends, a good place is Marina Beach, obviously. You have lots of street food, lots of games to play.
Right?
The beach is huge and it's nice. Another place is Phoenix Market City. It's Phoenix Market City.
Okay.
In Velachery. It's huge and you can pass the whole day there. Most of them are malls. We have Express Avenue, EA Mall in Roypeta.
Okay.
Then
I want something like that is like natural or somewhere like it's kind of a vacation spot of sort of thing.
Oh yeah, Semaripunga, the government park in Annasale.
Okay, so I'll consider that as 2. Marina Beach, Semaripunga.
Then we have Vandalur Zoo.
Vellore
Vandalur Zoo.
Vandalur Zoo. Okay.
Yeah. Then there's Gindi National Park.
Okay.
Nearby.
4
and another place. There's this place called Adayar Boat Club where the roads are very nice and if you can go by cycle or bike, it's a nice experience.
Cool. I think that counts to 5. Perfect, man. Your name?
Anirudh.
Okay, I think we'll get, someone can, to Anirudh. Okay, next up, I have a tricky question. I know it's just a one-word answer. So whatever, you guys know, just shout out loud so that we can hear and then based on that, we'll give it off. What is the ticker name of Freshworks? Like the stock market name, like the code. Shout out. No. For Freshworks. For a search. I think that person, he just raised it. Okay, I think, perfect guys. So we'll have more sessions, more activities. Like we'll come up with some random questions, something like easy, hard, and, during the sessions. So just keep an eye on it. And also, just an announcement, like anyone here who haven't registered and then got your cards, the stickers? Anyone? Because that is very important for you to get the lunch. So in case if you didn't register before, do it during the lunch and then, get yourself the sticker. All right? So I'll leave the stage to Praveen. Thank you, guys.
Can you hear me? All good, right? So we are into the third session. So as Varun said, the energy is getting low. So let's do one thing. So we did it on track 2. Let me say DevFest, you all say Chennai, okay? DevFest. 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 Cool. Let's go into the session. So today we are going to see about how to orchestrate microservices. So we just had a session from Freshworks folks, right, on how to scale. How they scale from 10K requests per minute to 150K requests per minute, right? So this is going to be a similar session of that sort, but it would be a light version of it, so that everybody could understand what scaling means, how you can scale, and how you could take certain steps so that it could help you scale your application. So before going into the topic, actually, let's go into a discussion about monoliths. So how many of you here know what a monolith is? Okay, I see some hands going up. Okay. So this is an example for a monolith deployment. Say, imagine an online e-commerce application. Okay. So imagine that you are developing an online e-commerce application, and you would need to cover a lot of scenarios, right? Say you would have a user application, there is a merchant, they would have an application as well, and this is on web and also on mobile apps, right? And you would need to have a backend. So your backend would be handling a lot of different things, right? So you'd be handling authentication, you'd be doing certain merchant operations, you'd be allowing the user to sign up through various means. So everything, imagine that all the code is written on a common repo with the same technology. Say here it is ASP.NET. I have just given an example like ASP.NET. So this is an example for a monolith deployment. So did you get it? Get it right? And this could be very simple. Very simple in hosting, right? You could either self-host it, or you could also use a VM, or you could use whatever technology that is very modern, and you could deploy a monolith solution. So there are advantages, right? All the code is in one place. It is easy and fast to deploy as well. So everything is in a common repo. And end-to-end testing is also easy. Integration testing is also easy. And the data is consistent because it is a single connection to the database. And also, it would be easy to understand for the developers. Whoever is coming in, it is a common technology, right? So in case you are writing everything in ASP.NET, the developers, the entire team would know what the application code is, right? So these are certain advantages. But this does not work for modern applications when you are going to scale. So do you know why? We have a lot of reasons, but yeah, please. Okay. Okay, so I've given a lot of reasons why this would not work, basically. So it's not scalable. As we said, the service would crash. Second thing is, you would be prone to unknown errors. Say there is an error that is coming in an authentication service, and the profile service or order service is breaking. You would never know why this error occurred in the first place, and the RCS would be little bit difficult to perform. And you would need to redeploy for every bit of change, right? Say your authentication code is working perfectly, and say that you are making some changes to the order service. So the code should be again redeployed, and everything would be redeployed right from the authentication service. So this is not good, right? And again, you'd be doing redundant testing. So even if you change a small thing in authentication, you'd need to do the integration testing for everything. Again, security will say a developer working in the authentication services adding some libraries to your application and say that there is a security vulnerability for it. So it would affect other services as well. So your repo would be affected in general. Again, yeah, as said, you would be bloating your application with a lot of libraries where it would not be required at all. Again, you'd be tied to a specific runtime. So we saw an example for a monolith deployment, and I said that it is an ASP.NET application. So say you want to, say a new team is coming up or a new feature is being built for your application, and you think that you need to use Java or you need to use Node.js or whatever runtime that you want to use, but you would not be able to do that very easily because you are tied to one service, one runtime actually. And again, as said, it would be difficult to migrate. So in case a team wants to migrate to a specific paradigm or runtime, it would be difficult to migrate. Again, it is not very easy for DevOps guys also. So the developers would be doing a lot of changes and it would be becoming a nightmare for DevOps. So this is very common pattern we see across many companies. So these are certain subset of disadvantages I wanted to give about monoliths. Okay. So let's take this as an example. So this is an sample order request that is coming for your e-commerce application. So your APIs are going to do certain set of tasks, right? So you'd be updating the inventory in your DB and followed by these many steps. So you could read this and you could, understand what the process is, right? So can you identify the problem in this? The API would take a lot of time to process that request because there are a lot of processes in between. And if you see from step number 2 to step number 7, it is not necessary at all. So you could actually skip those steps and make the API more faster with the help of async programming. And also microservices plays a huge role in that. Let us go through how microservices and your event-based architecture could help you and speed up the this scenario a bit later. But let's go to the microservices part now. It's very simple, guys. So we saw about the monolith architecture, right? So all that you're going to do is you're going to break it into smaller chunks. So we saw that a lot of services, right? So authentication service, order service, profile service, the data service, everything was coupled into a single application, backend application. With respect to, microservices, all that you're going to do is you're going to segregate into separate stuffs. Again, going back to this example, right? So this was the monolith deployment we talked about earlier. And we saw a lot of services and use cases that are covered inside this application. And it was written in ASP.NET. So what do you think microservices can do here? What advantages can it bring here? What improvements can you do on this architecture, on top of this? That's a good answer. Different languages it was. Any other answer? That's right.
Hello. The redeployment can be done without affecting the other flow. So for an example, if you are redeploying one service, that doesn't affect any of the services. So that can be useful.
Exactly. That's an absolutely perfect answer. So we basically saw certain disadvantages with monoliths, right? So it's the entire opposite of it. So everything would be an advantage here. So all that we are going to do is we are going to split it into different microservices here, as we talked earlier, based on your answers also. So see here. So now I'm able to configure things more dynamically and in the best of my interest, right? See, for example, if you have the SSO microservice or authentication microservice, I could write it in Java, I could deploy it in Compute Engine. So I need not rely on everything should be deployed in Compute Engine only. So if you see another microservice, for example, notifications microservice, which sends mobile push notifications, emails, SMS, it could be written on a different runtime, right? So I could use Node.js for it, and I could deploy it in another compute environment like Cloud Functions or Cloud Run or App Engine or whatever. So this is the advantage of microservices. This is exactly what microservices mean. Okay. So we have talked about what monoliths are, what microservices are, what are the disadvantages and advantages of monoliths and microservices also. Now comes the tricky part. So how does the microservices talk with each other? Any idea? APIs, okay. So that's the basic way of systems talking with each other, or the clients talking with the backend also. APIs is the basic unit, right? So there are other types of communication methods as well. Sorry? Okay. So, okay. Absolutely. So these are various protocols that are available through which you can actually power your runtime and your backend systems to talk with each other. And exactly, so we are going to take 3 examples here, 3 prominent examples that are deeply tied with Google Cloud actually. One is, as said, it is through HTTP methods, HTTP or HTTPS. So this is basically what API is. So a microservice can talk with another microservice through API communication, through HTTP communication. Say a request has been processed in orders microservice. Say the e-commerce application has got a request in order. Got an order. It can directly talk with another microservice. Like it could place an order with the merchant directly through APIs. This is one method of communication. There is some problem with this. Cool. The second way would be database triggers, right? So how many of you here have used Firestore? Okay. Basically, if you have used Firebase, you would know, right? So you would have used Firestore easily. So this is one way. So Google Cloud has given us an awesome way to do event-based triggers. So say you're going to update a document, or you're going to update a collection, or whatever it is. You have the ability to trigger a Cloud Function call or trigger other Google Cloud services as well. So what would happen here is, say I'm going to do a database update. Say an order is coming in and I'm writing the order to the database. What happens is you would automatically get a trigger to Cloud Function or any other serverless function. Serverless products as well. So through that you would get the changes, like what was the old data, what was the new data with respect to the database update, and you could process additional logic based on that. That's totally possible. So that's database triggers for you. And the next thing is event-based triggers, and another thing is PubSub. So we talked about SNS, SQS, and all, right, in AWS. So similarly, there is a similar concept called as PubSub in Google Cloud. So what you could do is you could just emit an event saying that from orders microservice, I'm just going to publish an event saying that an order has come in here, and what you could do is you could just publish that event, and any number of microservices can consume that event, or even the PubSub event could itself push that message to multiple microservices or HTTP endpoints. So this is not limited to 2. So for example, I have given two push subscriptions here. This could be any number of subscriptions. You could add n number of subscriptions. Like you can add 1,000 number of subscriptions as well. So this would work flawlessly, and the event would be pushed to certain microservices. Say I've got an order. So what are all the next set of things, right? I need to send email to merchant or user. I need to place an order with the merchant. I need to update many things will be going on in the background. So all that I need to do is just trigger an event saying that order has been created, and everything can be done async. So everything need not be done synchronously. So let's come back to this classic problem actually. So we talked about this, and we thought that these 7 steps were not necessary, right? So why did I say it was not necessary? So this is the new architecture that we can build. So here what I've done is I'm just creating an order, just creating a database, database entry here, and I'm going to publish a PubSub event saying that an order has been created basically. And I'm going to send the response to the user saying that the order has been placed. That's it. So the user need not wait for all the background processing that's being done, right? So the user would need to use the application, and they would feel that the latency should be very low. So they should feel that the application is blazing fast, right? That's the experience, that's the kind of experience you wanted to give to the user. So that's what's being done here. And once the event is published, the event would be pushed to certain microservices here. So here it is pushing to the merchant service, notification service, and the reward service, for example. And each microservice can take its own logic and process it on its own itself. So everything would be done parallelly. So it's not synchronous at all. So now the API speed should be like this. Okay, let's do a small demo actually. If you have your mobile phones, you can scan this QR code or go to this website directly. Give you another 10 or 15 seconds of time. Is it done? So what do you see in the website? It's just a simple form. It would ask you for your name and your email. So this is a very simple demo I wanted to give. And what this is going to do is it's going to send you the agenda through email. So once you enter. So this is a very small classic problem, and it does not involve scale at all, or does not involve any complex problems at all, but I could show you how it's being processed in the background. So if you see, the API response would be fast, right? So it would be very fast because it's not, the API is not going to send your emails, but other microservices are going to pick it up. For example, I have written 2 microservices, simple cloud functions. One is database update trigger, and another one is notifications trigger. So let me show you here. The font is very small. So this is a simple API that is running, and all that it does is it's going to publish an event to PubSub. Once you have given your name and email, it's all that it's going to do is it's going to publish a message to PubSub with name and email as custom attributes. That's it. So I'm not sending any email here, and also I'm not doing any database updates here. Also, for your information, I think the emails are going to spam folder. I don't know why. I think it's due to certain email configuration which I have done incorrectly. So if you're not able to find it in inbox, you could actually find it in spam. Maybe you could use that. And let me go to the PubSub topic here. Okay, the internet is little bit choppy today. So this is the topic name, right? So I have created a topic called as DFMAA 22 demo. And this topic has 2 push subscriptions. So the 2 push subscriptions are like, one is notification service and another one is data service. So notification service, I'm going to use it for sending notifications like emails or SMS or whatever type of notifications I want to send it to the user. And data service is basically to do database updates, basically database updates, that's it. So here, I mean, it will be showing 2 subscriptions here basically. And let me show you the code for those subscriptions as well. So these are very 2 basic functions. Do not count this as a separate microservice. So this is not a microservice, but I'm just giving you a flavor of what it could actually mean. So here I have two functions. The first function is just for notifications. Here what I'm going to do is I'm going to send this email to your inbox. So basically I'm getting the request and I'm going to process it to your inbox. And the second function is basically to do a database update. I'm not storing your emails, don't worry about that. I'm just storing a name, that's it. I mean, for example, I'm using Firestore for it. And if you see, I've got 137 requests in the meantime after I've shown this to you. So 137 of you have tried this and I've got the data here. So all this is done async. So all that the API did was it pushed the PubSub notification, and then these 2 microservices picked it up. One sent the email, one did a database update. So this is a very small problem, but think of very complex applications, right? So say in case of Flipkart or Amazon, they do a lot of things in the background. They do fraud checks or other kind of different things which we have not encountered before. And all this needs to be done in an async way, and microservices are going to help in a better fashion. So yeah, that's it. So this is what I explained actually. So it would, oh sorry. So it's going to just take in the request, do a PubSub trigger, and it would send the API response as okay. And these individual services would pick it up and do further processing async. So that's it, guys. I think you'd be able to take up certain questions because I think we have some time. Any questions? Oh, was it that clear? Okay, I've got a question there, yes.
So, sir, in the cloud functions, we have a cold start, right?
With cloud functions?
Yeah, we have a cold start. So, suppose no one is like hitting the server, it becomes in a cold state, right? So, how we can like warm that, like without increasing, without like paying the money?
So, it's up to your way on how you would design the systems. So, this is just an example, and I'm okay with cold starts actually. So it's going to just affect 2 or 3 persons in this room, and out of the 137 requests, other 130 requests would have been blazingly fast. So in case if you want a low latency, you need to pick the, correct serverless architecture. So in this case, I could use App Engine, which is warm and ready. If I kept the minimum number of VMs as 1, it would be warm and ready. Similarly, if I use Cloud Run, I could define the minimum number of pods so that it would also be warm and ready. So if you want the latency to be very less, then yes, you need to choose a different serverless pattern.
Thank you.
Or you could also use VMs or whatever it is. It all depends on your scale and your application needs. Any other questions? Okay, I think we're good. Yeah.
There is a question.
Where? Yes.
Hi, I'm Shakti Vanila. So you showed a lot of advantages of using a microservices architecture. And I just wanted to know, are there any disadvantages that you faced while implementing a microservices architecture? And how did you try to resolve it?
Got it. So, any service, there could be always the other side of things as well, right? So in this case, the latency could also be an issue. In case of monoliths, everything is tightly packed in a single place, so that you need not do a separate API call to get the data. For example, if I want to do a data fetching from order to merchant, or if I want to communicate between merchant and order, since everything is packaged in a single code, it would be easy for communication there. In case of microservices, that could be a bit of latency there. So this could be a disadvantage. Similarly, your second question was like, what are the challenges I faced when implementing microservices? Things are like I could miss certain things in other microservices. For example, if the team is very small, and if we are managing a lot of microservices, say if you are facing a security vulnerability in a particular microservice, you need to patch it in all the microservices. You could not patch it in a single place. So these are certain things you would need to watch out for. So yeah. Sorry, places in the sense?
What are the places we are able to execute these microservices? For example, you saw this one TypeScript now. Like that, where you execute this thing? Like our cloud functions, like that, any other places is there?
So the example I took was on GCP basically. So GCP offers Cloud Run, App Engine, Cloud Functions, VM, and etc. and etc. So each service supports a particular number of runtimes. For example, if you see Cloud Functions, I think it supports eight runtimes, including Node.js, Java, C#, etc. And if you want to write your own custom runtime, then Cloud Run would help. So it depends. So it depends on your runtime, and you get the options to choose for. So basically, you would be able to do this in different cloud also. So if you are writing a Node.js application, and if you are deploying it in Cloud Functions, if you think that I need to move my microservice to another cloud, or if I need to move to on-premise also, you would be able to do that. Totally possible. Yep. I think let's take this one last question, because I think we'd be running out of time.
So I have two questions. The first one is, you said that microservices run in parallel, right? So what happens due to some data issue, one microservice is not perform the DB update, but still the notification microservice would send the notifications, right? How do we do the error handling at that point?
Got it. So that's the beauty of microservices actually. Say if you are using a synchronous service for your API, and if your email trigger fails, and this is a very small, edge case, right? If the email sending is failing, it should not prevent the order to be created.
No, it's the other way around. Let's say the DB update has failed.
That's what. So before triggering an event to PubSub, or before doing anything, you need to establish what are all the basic set of things that needs to mandatorily go through. For example, the DB update should mandatorily go through, because it's the core thing that you would need to track.
Correct.
So only after doing the DB update, you would need to actually publish the message, or do triggers based on that.
Okay, so the microservices will be called sequentially at that point of time.
Not really, right? So after the database is updated, you do a PubSub event, and the microservices can consume it, and it can run on parallel.
Okay.
So Praveen, I can add up.
Yeah.
So basically what you can do is categorize your services, right? Like put all the notifications to run in parallel. So that will happen only after the DB update is done, or whatever validation is done, right? So the notification could be one push, like your push notification, email notification, SMS, or whatever. That will happen in parallel. But it will all happen after your core or your primary database update is done. So that's how you make things that can be parallel. So in that case, even if notification fails, it's fine for email to go, and it's fine for SMS to go, something like that. So that solves that.
All right. My second question was, we talked about microservices. So there is a new tool from Google Cloud that does the integration. So we can create adapters, and we can do all these API calls and perform the DB update through that integration. So what is the advantages over this microservice, and do we go for microservice or integration services?
Simple. It's just another managed service, right? So in case you think defining other microservices, writing your microservices on your own, and managing it is going to be cumbersome and difficult, you'd be going for a managed service. That's it. So it's based on how the developers in the particular team think and how they want to utilize their time.
Okay. Thank you.
Okay. I mean, let's take the questions offline. I think we are running out of time actually. So, Arun, if you want to come up to the stage here.
Thanks, Praveen. So, I think that went pretty well. A lot of questions. So, next up, what shall we do? Like question or something? Activity? Claps again? Okay, one. Oh, that's very good for that. All right. So I have one more small activity. Like this is something that kind of technical. So I have like one technical and one non-technical. Which one should I go first? Technical. Okay. All right. Perfect. So I want someone who use Google Cloud or any Google developer related products like Dialogflow or whatever, and tell me about the product that you like, that you use, and why do you like that? Someone like, can you have mics? Yeah. So we can take two people. So one and the other.
I'm using Firebase, Firestore, and then real-time database things. This is compared to other AWS. This is very easy to configurable and then very easy to use. This one.
Okay. So you want to share like what is it, and then to the people so that they get to know about it.
Yeah. In Firestore, we able to segregate based on the document and college like that is there.
Right.
Other database we going means JSON based like that only is there.
Right.
This is very useful for segregating and then even triggering that purpose we able to use.
Right. So basically you're using Firestore as a middleware where you can put all the data and then use it as
like database and then triggering purpose we'll using this.
Perfect. So yeah. So Firestore is basically a part of Firebase tool, like the package, which is more like a NoSQL database. Thank you, sir. Yourself, Mike. Yeah.
So I would like to highlight BigQuery. So that's basically like for big data. I like to use it for IoT applications, so streaming data and the like. I also like IoT Hub is also an application from GCP which I use, and AI Compute.
So what do you like more about big data BigQuery compared to the other competitors?
I like the interface. It's much easier to use than other competitors. So
okay, cool.
Yeah.
Perfect. So now let's go to the non-technical question. Yeah, I think there is one more person, but I don't know if we have goodies for that. But anyways, we'll find it out.
Hello. So I use FCM, Firebase Cloud Messaging, for sending out notifications from my for my Flutter app. I use APIs to send out from servers. I send out notifications.
Right.
Not only push notifications. I send using FCM. I send out data for background processing of the data in my app for events and stuff.
Right.
So yeah, I like it. It's very feature rich.
Yeah, actually, when I talk about FCM, I'm a big fan of the Swiggy and Zomato messages. How many of you like that? So they send these cute messages whenever we are hungry, and then I don't know how they find it out, but yeah, they find it out. So perfect. Yeah. FCM is one good tool. I think that is the only way to send out notifications to Android, I guess, currently. So FCM, if you're building an app to push some data to your mobile client, yeah, FCM is the good tool. Okay. Now, So now I have a question. I don't know. This will actually find how how you watch the Praveen's presentation. There were two GIFs, right? So I want anyone from the crowd to tell what is the dialogue that was there in the first GIF. So shout it out. Yeah, that person in the back. Yeah, that is the So let's welcome Arun. Where is he? I can't find him. Oh, it's here. So Arun is basically going to walk us through about XR on the cloud. So like, how do you stream data to XR data to over the cloud? Like if you don't have an expensive device, how do you stream the data to your AR or VR headsets? So I'll leave the stage to Arun. So how many of you tried Metaverse before? Metaverse. No, not about NFT part, but metaverse. So yeah, probably you want to tell me about how was your experience and what do you feel like the future looks like with metaverse in place.
Yeah, test. Yeah, this is Markandan Maharajan actually. So metaverse, actually we are working for metaverse. Actually we are doing augmented reality and virtual reality.
Okay, so if anyone wants to know about metaverse or work on metaverse, I think he's a guy. So yeah.
Yes, please. So that could be in future. Metaverse will be in the future. So already we have created for us classroom for our students. We have implemented for multiple colleges in Mangalore and south side. So that will be a different field where you want to be there into real-time scenario. So so many things I want to express, not in this time. Maybe you can touch with me, so I will get connected.
That will be perfect. Yes. Perfect. Thank you so much. I think we'll start with the next session. Nice picture, man.
Yeah. Hi guys. So like myself is Arun Ganesh. Actually, like I do work for the company known as Stellantis. And you might be wondering what is Stellantis first of all. Like I'll say that. So the Stellantis is like an automobile company where we manufacture cars. Like you might have heard about the Jeep, Citroen, Alfa Romeo. These are the brands which comes under us. So in these manufacturing companies, what this extended reality we work upon is like, we work upon like a mixed reality technology and like a kind of a virtual reality technology like merging together. So that outcome is known as extended reality. So here I'm going to talk about the real-time problem which was faced by the world's third largest automobile sector company. So this is the project of our company and like the solution provided from my side and my project this is. So what all the topics today we are going to discuss about is like what's extended reality to the peoples, the newbies who don't know what is like XR and like what is like MR or AR and difference between AR and MR, what are the capabilities of it, a real-time problem statement of the automobile sector which we have already faced in the market, and the solution for it, as well as the wonderful solution it is, which is not yet found from Google or any other Microsoft leading technologies, but we have done it from the automobile sector. And the real-time advantages and how can we use this streaming technology apart from Google services, and difference. So Google also has done a similar kind of thing, but it doesn't support majority of the devices. So how we are different from it, functionalities and features and its outcomes. So let's start. What is extended reality? So I saw like few people like here like have worked with VR, MR and like AR. So any clue or anything, what is extended reality? I couldn't hear actually. All of it, yeah, you're right. So it is a comprising of all the realities into a single entity that is known as extended reality, and like mixed reality is also known as an extended reality. Actually, yes, as you were right. Actually, we are like merging the real-time world with the virtual world. That is the thing. Here we are doing it up. So that makes an extended reality over it. So extended reality is also used in various platforms like medical sector. In Singapore, if you take, Singapore government has making the extended reality into their medical fields for the operation purposes, and automobile sectors as well as the Stellantis is leading in it. And like other products in militaries. Like 2 to 3 months back, you might have heard about the like US government working with the HoloLens devices. HoloLens 2 devices are mixed reality product to get into the army forces. So that has been the latest tech which is providing a more accuracy for the militants in the North American regions. So what is the difference between AR and MR? So both is like a same kind of realities. So you could see a virtual object. Virtual object is nothing but a daily life. You use AR filters in Instagram, Snapchat. So these are the AR things. So what is MR then? So that also you'll be seeing a virtual object in the real world. What is the main difference in it? So let's say like in AR, you are going to like interact with an object using a display. But in mixed reality, it is totally different that you'll be using your real hands. So you don't need to wear any external devices like hardware gloves or anything in it. You could just interact with your hands, which has a LiDAR cam support in it, which detects your hands and like it gives a hand mesh over it kind of things. So that is the main difference. And like in this, like you'll be, you won't even like have a real-time interaction in the AR, but in like mixed, you get a more real-time interactivities. So this is the main problem. Before getting into the problem, so what as a consumer we have faced in this issue in the automobile sector is like, let's say like I'm a Millennium customer who wants to buy an Alfa Romeo car. I walk into a showroom, I see a car, and I want to purchase it. But I don't like the color of the car. I am stating that I need to see a different kind of car or a model of a car. But like a brand says that we don't have a car. You could see it in the browsers. Will we accept it? They will ask us to make a payment of like something around 50 lakhs before seeing the car. So that is not a part which we could rely on them. So in that place, we use this extended reality tech to get on top of it, giving us a solution. Yeah, Stellantis this is my, like our company project. Stellantis is the 6th largest automobile company in the world, which has 100 plus showrooms. So in this, what is the major problem we faced was, there is an event known as CES, which is happening annually in the North American region. In that, we will be showcasing our technological stuff and like upcoming car models. So let's say like Alfa Romeo is going to release a car known as Tonal. So that is not yet released in the market. So then how you guys could see it out? We won't expose the car in the real world. So how can we use it? So using the virtual reality devices and mixed reality devices. But let's say like a mixed reality device of HoloLens 2 is going to cost you around like $30,000 or like approximate, using all the remote assist, all the capabilities will be coming up. Else virtual reality devices. But that is a issue when it comes to the real-time cost, because like a HoloLens device, maximum we will be having 5 devices, which like 100 crowd people comes up, they can't give you a HoloLens device for each and every people. So how can we resolve it? So this is the problem too, which we faced in the real-time brand known as Jeep. So you might have heard about the Jeep brand actually. So Jeep has a Jeep Compass, many vehicles like Jeep Wrangler, Rubicon kind of things. This was a real-time thing where a Jeep brand has made a real campaign in the malls and like in the expo events. For the campaign, they costed 60% of their market value. Let's say like it was something around like $1.8 million they spent it out. And it was a pure loss for that campaign actually. So based on these two problems, we came up with a solution by providing in a streaming XR. Streaming XR is already done by Google actually. But to be clear that streaming XR, which Google provided, is only supported in AR devices like kind of iPhones and like Android devices. To overcome this, we used streaming XR using Cloud Edge. So what is, here we play with the cloud actually, edge cloud computing concept. So what is edge computing first of all? Any idea about edge computing? Yeah, partial answer, partially correct. Any other thing? Okay, that is also partial correct. I needed a proper terminology. Can you, yes please? Yes, he's right actually. So you could get a swag at the end of the session. So like what is that is like, as he said, so that is like an intermediate thing which we are doing it up. So edge computing is a distributed concept where we use it up. So we are using the same thing in the cloud format with the streaming XR. So what it actually does is like, let's say like you have one virtual reality device. He has one mixed reality device and I have just a AR cam. So all the 3 devices supports 3 different environments, and which I can't use a virtual reality, I can't see a virtual reality in a phone. Or like he can't see a virtual reality device person can't see a mixed reality experience. But using a streaming XR, we could get the experience of any kind of environments. Let's say like nowadays there is a device known as Quest Pro, which is released right now in the market, which supports a mixed reality environments. So using the same thing, we could achieve it actually. So here we are streaming any kind of virtual reality contents to any kind of devices. So there is no restrictions for any users to experience the environments. Yeah, so this is the thing. So as I said like previously, we could stream any kind of reality platforms to any devices, any HMDs. So and we have a spectator view that let's say like a few people will be like having a monitor, so they could see the streaming kind of things in the monitor itself, as you could see like how that display works. So that is done for the Ford company actually. And like we are using right now we are using Microsoft MRTK services for streaming the entire process, and like we are using a WebRTC background as a communication, real-time communication medium. So WebRTC is nothing but a transmission medium which is being used in real-time Google Meets. So you will be using a Google Meets. So entire back-end transmission is running under the WebRTC transmission medium. So we are using the same thing in it. So what is the real-time advantage out of it? What the company gets out of it? So let's say like I am taking a car and like showing it in a showroom, so or like a mall or expo. The demo car will be costing like something around like 70,000. It's approximate value. Like a Ram TRX is like something around 70,000. So instead of that, I'm taking just a car for $70,000. Instead of that, why can't we take this entire tech? Like it's like taking an entire showroom in our hands. So the entire tech has like any kinds of cars. We could experience any kinds of cars or any brands of vehicles in it. So we could save us $66,000. So this tech, which has minimized the real-time cost in the company and which has seen a very big profit also. So how it works actually. So here's the main core thing. So what we are actually dealing with is like, you might have used any game developers here actually. What engine do you use? Unity. Okay, great. Unreal. Okay, great. So we are like, what we are actually doing is that we are just placing the engines, like the Unity or the Unreal engines, on top of a cloud server, which creates a real-time bundles or like builds and pushes to the specific devices. So these are the like kind of AR, VR, MR devices, which is going to show you the end results or the streaming contents. So using this, we are mapping the real-time data to the virtual world and getting all the data from the cloud servers. So this is a core concept where we play a lot. So how we are purely different from Google Streaming XR? So you could just search Google Streaming XR. Still, that is actually in beta version only actually. You could search it up. What makes the difference? So the Google Streaming XR works purely in a web-based framework actually. So we are like not working in the web-based frameworks. We are working on the core logics for building the entire standalone applications. So that is the main thing. And like we support like multiple kinds of platforms and as well as the devices. So here we could also like include on top of it like the functionalities and features what we have achieved. The multi-user support, this is the major feature. So let's say like I'm in like North American region and like one person is in European region. I wear a HoloLens device and you guys, like anyone from European region, wear one HoloLens device. And when I open the car door, the person sitting in the same, with the device over there, he could also see the same car and the car door will be opened. A kind of real-time interaction could also be produced using this multi-user support. So this took like actually like a framework which is provided from the Google. So as I said, a WebRTC concept. We induced this with our real-time world, like real-time project, and it helped in achieving it. So most of the game developers will be wondering like how the FPS matters. So FPS is like frame rate per second. So how that matters? Because like streaming a very high poly content, eventually the FPS will go low actually. So the FPS comes in role like 60 to 80, which is a phenomenal experience, will give you extended reality supports in this. A global interaction. As I said, we could explore the car from wherever we are, like from any kinds of like environments we are. So that is the main thing, that is a key factor which plays in it. So the outcomes. The major outcomes are like strengthening of the like a marketing and increasing your project values, and like let's say like I could experience any 3D kinds of models, not only the cars, we could experience any kind of 3D models in any kind of reality platforms without any restriction of devices. And it can be used as like a part of, we could use a single feature in different fields also, not only in automobile sector, it can be used in different sectors actually. Yeah, any questions actually?
Hi, this is Siddharth. Basically, I'm an automobile engineer. So what's my doubt is it's actually full and full virtual only. But if a customer is an automobile enthusiast, how he or she will feel the car? Like if she want to see the interior, like build quality of and leather or an some kind of things like that, how they will feel in a virtual. So they will not be satisfied in this kind of technology, no.
So to be like you are saying that the customer is going to see only purely virtual reality concepts,
Yeah.
right? So here only we take up the mixed reality. So mixed reality, like you'll be placing a real car in a real world actually. So that time the car will be more realistic in manner. Like it will be like equivalent, like placing a real like virtual car next to the real car means there'll be no difference in the mixed reality platform actually. So using the mixed reality experience, we could give a real time as maximum, like not 100% real time we can't give, like as you said, like we could give at least like 80% is matching with the real time things. So the mixed reality comes in that play.
Okay, thank you.
Any questions? Yeah. So audio output, we have a spatial 3D audio which like comes up with the preferred devices. The Microsoft HoloLens has its own spatial audio, so we need to like make a corresponding node for creation of it. Let's say like you create, yeah. So let's say like in transmitting the audio using any kinds of mediums, so you could achieve it.
Actually, I'm from automobile background,
Mm.
and when you are showcasing that device, no, there is no sense of touching or something.
Yeah.
It will not be happened there. Is there is anything?
So actually, like
come to that in the mixture.
So to answer your question, actually there is a vibration which happens. So I think if you get the experience of a HoloLens device, you don't have a glove actually, okay? So you touch the door means you'll get the real-time vibration by making you hallucinated. The device which you wear, the HoloLens device which you wear, will give a hallucination feel to you and make you feel that you're touching a door.
Actually, the touching will be happen with Intel sensors or something around.
No sensors are there. So it is detected by the camera which is present on top of your headset, like the HMD device. So I could show you up. So we have a, actually this is a device which we use for the mixed reality experience, and we have on top of it a LiDAR support camera. So it's a powerful camera which detects your entire thing. So your hand, so using that, it recognizes that is your hand and it is going to give you a experience or a feel to you by hallucinating it.
Okay.
And like I could show you the prototype which I did it from my project. Yeah.
Arun, yeah, I have a question. Like,
yeah, sure.
What do you think, apart from gaming, will be an application for XR? Like, apart from gaming.
Apart from gaming, can you repeat it?
Yeah, apart from gaming, what would be other solutions that XR can provide? Like industrial or education is one, but something like that we could have never thought of.
So the real time is that the upcoming thing, still not yet released in the markets, is the heads. Like you guys know about the heads-up display. So right now it is there in the cars, but it's going to be a digital heads-up display where you could get the real-time road assist view. So let's say like we are going to keep a camera. These are coming up in the RAM brand actually. This is going to come in the RAM brand. So we are going to keep up a camera in front of the steering boards. So which is going to find and tell whether any obstacle is going to come up, and it's going to give a digitalized display, a heads-up display, in where you could get all the notifications on top of it. Yeah.
Perfect.
Yeah. Yes.
So suppose we want to introduce a certain level of abstraction in the model, the virtual model, mixed reality model. Say like we don't want someone to open the hood of a car to potentially, any trade secrets should not be leaked, something like that. So how can we introduce that level of abstraction? How can we say, sorry, you cannot open this segment of the car, you cannot look under the car, something like that?
So we can't restrict the viewpoints of the thing. Let's say like what she asked was like, if the car is there and if I'm wearing the device and going and seeing around the car, and like how could we restrict it? So like we can't restrict the view, like we can't restrict the users not to view this part of the car, but instead of that we can restrict the users not to touch open the hood of the car. We can restrict that. However, like we could play with some animations over it. So while we are like opening the door and doing some interaction, we are like interacting with some animations over there. So on top of it, so we could restrict based on the users list which we provide, we could restrict the users. So previously we need to have a list. Who are the users can be restricted. So based on that only we could do it up. Yes. Yeah.
So you talked about multi-user interface, right?
Yes.
So won't that be very chaotic if there's multiple people in different places trying to do similar things?
So
how
it's
can
like
you handle that?
So you might have played PUBG, right?
Kinda.
Free Fire, any kind of games.
Yeah.
So Among Us, most of the games which I tell are being played in a multiplayer rooms. So where we create a room, we restrict the users. Like there could be only 10 users. So it's upon the developer's perspective, like restricting users on there. So same kind of thing. Think in that way, same kind. So we are creating a room. So inside that room, we are like first come first serve basis only. So 10 people come. So based on that, let's say like you come with your friends, 4 of your friends, and you come inside it, and the room is locked. That's it. Only the 4 of you can get the experience of that vehicle. So like that, we create multiple rooms. Based on that, multiple room inside like set of peoples can be experiencing that multi-user support. Yes. Yes. Yeah.
So in such a situation, like, do we also consume data from, let's say, some machinery? I'm thinking on manufacturing type of an environment. Do we also consume information from other PLC type of systems? And also on the slide, we had some content about, other workflow solutions, MES and all of those areas. So we have some API in also sharing some information. What
Yes.
type of an interface will that be?
So I can't disclose that actually. You're asking the core thing which we did. So that is the.
Generic.
So to give an overview, I can give overview only. So what we dealt with is that we have some information from the manufactured part, which you said. So we get some information from that, like a VIN number we'll be getting the VIN number details based on that, and based on that details and as well as the devices which we have already pre-coded the values in it. So we'll be linking up those details, both details, and passing to the cloud servers, which will make a process over it. Actually, this is a pretty big, overviewed architecture diagram, but we have a lot of breakdown through it, which cannot be disclosed.
Hi.
Yeah.
So you told you'd be supporting multiple devices, right? Starting from mobiles.
Yeah.
So your solution can also run on mobiles.
Yes.
I have a small doubt. So basically in Android mobiles, we have an issue, right? So if you're trying to represent a color, based on the manufacturer, the color might vary.
Yes.
So if you're expecting someone to see a car model using that kind of a display, how will you handle the...
Yes. Actually, few years back, I can't disclose the company name again. A company has gone through the same issue, which they did a digitalized 3D model and showed up in their showrooms. And the car model was seen as red, but the car delivered to the customer was orange. So a company, I can't disclose, it happened only in India actually, this issue happened in India, and after that project was closed actually. So his thing was the same thing. We are using our OpenCV technology over here. So that is a different tech. So what it does is it's going to give you the accurate color which you see it up. So there won't be any color distortion or color change over it.
So the OpenCV concept which we play solves the problem here.
So is it like some kind of a configuration that you do prior to
It's not a
using your app?
configuration, it's a different part. OpenCV comes like we use our libraries which we have created it. OpenCV libraries, you could see it up like we use OpenVision. So where to detect the models, like real-time models we detect using OpenVision thing. So same thing, OpenCV colors is there, which we have created by our own. So that makes sure that the color doesn't get changed.
And one more thing, you told your solution also uses LiDAR, right?
Yes.
For
So any other queries, guys, from you regarding the extended reality or like kind of automobile industries? Yeah. Yes, we are using it just right now for the R&D purposes. Getting data is collected from the users in the European markets. So this comes into the brand of Alfa Romeo. This project comes in the Alfa Romeo brand. So we are just making R&D works. And yet to be released with a Jeep. Right now Jeep has released a Grand Cherokee car in India. So we are planning it out to roll out with the Grand Cherokee. Yes.
We have gained a very good knowledge on this subject, but I wanted to know, like, how did you start and what influenced you to do this? Whether you did any degree on this or you did on your own, skilled yourself. So how do you guide people?
Yeah, so to answer this, like actually my first company was like with this same kind of augmented reality project company only, but I didn't even have any knowledge how this application of augmented reality works. Like Varun might have said that in 2014 in the DevFest they had played with this AR, but at that time I had no clue. I started my journey doing some research works, like kind of like digging up articles in YouTube and like develop myself. And like I am right now, I'm doing a doctorate in this extended reality itself. So based on that, I developed a lots of skills and like seeing out more research articles that helps in this kind of field. That only helps actually.
Okay, so where are you doing doctorate? Like which university?
So I'm right now like doing my research works under like Bharatiyar University, Coimbatore. So it's not that much big actually. Like kind of digging. Like there are lots of articles and like theses proposed from different universities, like Boston University. Will Orchard is a very good scholar. He has did a lots of research work in this extended reality field. So I went over all of his theses for building up this project actually, because I am the main lead for this project which I showcased to you. So that helped me to create up this. So because we can't find a lots of articles like YouTube videos or like any kind of Udemy courses will not give you a hand for these kind of expertized fields. You need to learn by your own, like exploring many kind of paperworks that helps you.
Um,
Yes.
So I have a question. So
Yeah.
you said the haptic feedback which sends stimulus to the brain, right? Like when you open a car, you get the feel of opening the car,
Yes.
vibrations. So how safe is that? Like if you send some kind of stimulus to the brain, like is there any kind of research going on it? How safe is it?
Of course, yeah, of course, we will get it up because, like, first of all, when we used our phones, they said that radiations will be passing out through the bodies. But nowadays, we are addicted to it. The same kind of thing, which right now it's coming up. But the company's perspective comes up. Everyone needs profit in their business. So yeah, but it will affect for sure because, like, being a developer, I can't wear a headset like HMD device more than like 1 hour. So it will give you a severe headache, which you can't imagine. So those all comes in the play.
So it will be optimized in the future.
So in future, like, I think like it could be optimized in a way that you all could get a good experience without any medical issues in it.
First of all, thanks for your presentation. It's wonderful, actually. My question is, how the occultation will place for that? Occultation. So, for example, if I'm going for that place marker, that AR or VR content, AR content, if you are going for the extended reality, so I'm going to place some content in the stage means. For example, in the stage, that stand is there, that speaker is there. For example, in my viewing perspective from here, I'm viewing. So the content while I'm placing there, how the occultation, the front end objects will be there. I mean, the projector speakers will be here, right? So how we can differentiate? How can we achieve that occultation?
So for this, what we are doing is here, like, is a dev perspective. I am saying that I'll create a multiple game objects, like multiple box colliders on it. So occlusion curling, you might have heard about it. So that role comes in play. So occlusion, using the occlusion curling, we can achieve this. And we could, when I interact with the car, let's say like I'm making my hands, means it should not go beyond the car. So in a way that we keep the box colliders and mesh on top of it, reducing this kind of issues. So that when I keep my hand in the virtual car, so my hand will go only on the like kind of the door. It won't pass. I can't see my hand rest. It goes inside it. A kind of way we created. So after this, I could, like, after the session, I could explain you in detail how this works.
Sure. Okay.
What? OpenGL is kind of a graphical thing you're stating. That is a different way of approach. So this is a kind of dev perspective approach which we could deal with it. Okay, finished. Okay, guys. Actually, like, I think I'm done with the session, and I can't show the video. Actually, like, it's like protected actually, so I can't show the demo video to be shown to you guys. So, if you have any other queries, we could just connect after this session ends. Thank you, guys.
So, thanks, Arun. So next up, we'll move on to the next session. Probably we'll postpone the activity to the next after the next session. So we have Hamad, who will be walking us through the ML part of, like, how do you manage your data? Like, you have a lot of data and then you want to show or do some sort of analytics and do sort of sense out of it, right? So he'll be majorly covering about that part, and I'll leave the floors to him. Okay, I think we'll have some time. So meanwhile, I'll want to do a small activity where, it'll help us in the core of the event. Like, I want few people, say like, 5 people, randomly out of the crowd, and raise up and then say, why do you came here and what are you looking for? So that if anyone in the crowd is actually aligned towards that, probably you can also catch up during the networking and the lunch sessions. So someone. We can start from myself as well. Like, I basically come for events to network with people, to see like if there is something that is new out there, and then I could try it out. Majorly venturing into web development now. So if you guys are around that, happy to talk. Currently working on Next.js. So if any folks use Next.js, probably we can talk. Someone from there. Can we have the mic? So the first person probably. Yeah, you just need to tell, what are you looking from the conference, and then, basically people can connect with you later as well.
Yeah. Okay. So this is Meena Manogaran. So I came here today first to network people, and also I came, during the last DevFest 2019, which happened in Hilton, which gave me some confidence, and also, how to be be an extrovert from an introvert, right? And also how to connect with various people and gain some knowledge from them. Right. And also I am a ML developer. Okay. So like this topics also inspired me, and the other thing is also the extended reality which was given by Arun. So these are some topics which I wanted to gain knowledge on and connect with people around. Yeah.
Someone from there.
Hello everyone.
So just what do you do and what are you looking for?
Hello everyone, I'm Abhijit. I'm a second year student right now. I'm here to network with people. This is my first DevFest, and I'm here to network over Kubernetes and cloud native technologies.
Yeah. I think someone from here. Yeah, I was able to hear what I was
Hi everyone, my name is Krishnamurthy. Basically, I'm working for a MNC, and where I'm responsible to handle kind of millions of file transfers every day. It is more like different, endpoints what I have. I have to get files from those endpoints to a centralized server, and again vice versa. Like from the centralized server, I have to send across like 10,000 of files almost every minute. So we already have a solution, but why I'm here is like to know the more of the latest tech, what is available in the market, and to understand lot of sessions are more useful for me, like the first one, like how do we scale our applications, and the presentation given by the Freshwork folks, like how do we handle large amount of load, and how do we give a response back to the clients, all small things, I'm taking up from each and every sessions. So I hope the rest of the sessions also will be more useful for me, kind of ML sessions and everything. So, yeah. Basically, we are looking for to re-architect our existing system so that it will be like can easily scale up and it won't fail so much. Okay, so that's the idea for me to being here. Thank you.
Perfect. Anyone else?
Yeah. Hello, I'm Vindhya. So basically, I'm from Bangalore. So recently, I moved to Chennai. So I came here to network with people. And here I'm working at Appian as a software engineer. And
what name is it?
Appian Corporation. It's a low-code product company.
Okay, I think I have a friend who works on Appian.
Yeah, so currently we are hiring and expanding our team in Chennai. So if anyone wants to join, I can refer them.
So you work directly on Appian or you work as a vendor?
Yeah. I'm working with product development at Appian. So we are expanding our team in Chennai.
Right.
So if anyone wants to join,
perfect. And probably you should tell what Appian does, and
Yeah, Appian it's a low-code software. So using that, you can build software like front end, back end, everything without writing code. So it helps us to do the product development very quickly. Yeah, and also lot of Appian developers are there. Pega is also our competitor. So we can do that Appian certification also. If you want to be a low-code developer, there no need to write code. Using drag and drop feature, we can develop the software. So if anyone wants to join Appian, let me know.
Perfect. I think there was someone.
Okay. I'm Lakshman, working as
that will be the last person. So I'm leaving the stage, and then we can start the session right away. You can do.
I'm Lakshman from as a technical lead from the Pro. I came here first how the DevFest event actually works on, and second thing is for networking, and the third one is adding the GCP technical cloud expertise to my resume. And sharing what I actually know, and if anyone have any doubts on Angular and architecting stuff, you can reach out to me. I can help you out.
Thank you so much. I think, Hamad, we can start it.
Good afternoon, everyone. Show some energy, right? We have. Good afternoon, guys. Okay. Now you guys have to top that up. So, good afternoon. Great. So I'm Jainal Ahmed. I am an AI consultant at Google Cloud. Can we switch to the decks, please? This is not. हाँ वही कर रहा हूँ उधर गया उसमें गया उसमें उधर 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 हाँ उधर है उधर ये है ना हाँ इसको करके सेटिंग चेंज कर Okay, let me continue till he starts. So, I'm an AI consultant in Google Cloud. Today, what I'll be talking about is around. Before that, how many of us here are machine learning engineers, data scientists, people who have worked on building models? Okay, quite a few show fans. So, I'll be taking things into a bit further where we'll look at the graphical relationship between the data. So we all have heard graph theory and other things, right? We have read about them. So how that applies to data today, how the data is evolving, and how we can then leverage graph machine learning techniques, graph databases to build these more intuitive ML models that preserves that relationship between the data, right? That graphical representation of the data, the networks that we create, right? Let's say, for example, how maybe Facebook recommends you the people that you should go about following, or Twitter does it, or maybe how platforms like let's say Zomato, Swiggy recommends you the products that you should buy, right? That the graphical things that runs on the back end. We'll look about those. No, this is not okay. Click करो. Okay, yeah. So the digital transformation, or how the industry is evolving, right? How the tech, when we talk about taking those tech, quite a few people have talked about they build these products, right? When we talk about taking these out to the customers or the people who are actually going to use it, this is how it is changing, right? We are doing a lot of data-driven discovery. For example, we are doing, let's say, work on crime detection, or even identifying these patterns on the data based on we recommend what is going to be the future. We are also trying to do a lot of hyper personalization, right? A personalization, what we used to do previously was more around, let's say, what's your gender, where do you stay, or things around that, right? Now we are going to on a more detailed level, let's say, what you ate on the breakfast, based on that, so we will recommend what you should eat on the lunch, right? So then going into that level of personalization, right? Then a lot of industry, a lot of companies are also trying to do a lot of enhanced decision making, right? They want to look at the data in a bit more detail. They want to capture as many data points about you, and then trying to process it so that they can make these quick business decisions, so that obviously that they can make money, but also on the other hand, make our lives easier, make those products more inclusive, more usable to us, right? And at all of these, right? And all of these we look at, and also the application of ML, right? Data is connected at the center. It is data coming in from various places, and this data inherits various models. There's a network of people, right, where you are trying to connect or predict, let's say, your customers, suppliers, partners, your employees. Based on that, you want to look at them. You want to recommend some things, some steps to them, so that they can enhance, right? The transaction networks, right? You want to make sure that your supply chain is righted, where your product is manufactured, how it is supplied to you, how you are selling it, how it is reaching your customer, how they are leveraging it. Also the relationship between them, right? Let's say this guy, bought this product and he returned some other product, but the other guy bought the same product, right? So you can, based on this, we can recommend some product. Let's say a person like you who stays at this locality of this age bought this product, maybe you'll also be interested to it, right? So this is how people are trying to do recommendations now. And then the knowledge networks, right? Everyone is trying to build these knowledge graphs, knowledge networks. Based on that, they want to have the domain-specific content, a domain-specific understanding of every interaction you do, may it be on a healthcare industry or in an automobile or any other industry, right? So the data comes in many shapes and sizes, right? It's not that, what the data we have been looking at previously. It's not just the tabular data with one-on-one relationship or image data or text data. The data can be hierarchical. It could be hidden and based on certain cyclic manners, or there could be very deep hierarchies, right? The data that you are looking at is actually dependent on something, and that actually is dependent on some other data, right? And there is this legacy databases, right, where you have different your old data which is residing in different silos. You want to combine them and then come up with a new understanding of a data, and based on that you want to do analytics on top of that, right? So the issue that we or the industry is facing is around the relationship DB that we have been using, right? They don't handle relationship well, right? We cannot represent everything on a tabular fashion, right? We cannot model or store the data, that relationship without complexity. We'll either have to maybe have n number of tables which then captures everything, track everything via this external IDs, primary or secondary keys, and based on that. But it will be very complex for us to then start processing it, right? It enhances, it decreases our performance just because of the number of relationships we have to store, the databases that we have to maintain. And again, right now, if we have n number of tables, right, just to get one data point, you have to write a very large nested query, right? You cannot actually, the complexity of that query increases, and if you cannot gather more information out of that n number of tables, that the whole DB schema that you have already. Generating a lot new kind of data, right? Earlier, it was just a tabular data which people used to use. Then we started generating image data, we started generating text data, speech data. These days, let's say we are generating data around the whole XR ecosystem, right? So now, how do you store them? You cannot store them into your traditional relationship databases, RDBMS, right? Again, right, the NoSQL, some people say, a solution to that can be NoSQL. But NoSQL, again, cannot handle relationships, right? It doesn't have a data structure to model, to store those relationships between the data. It's just an store where you just dump your data as an objects, and whenever you want, you can retrieve, right? NoSQL is just that, right? Then in that, you cannot have that relationship stored. You cannot then also construct query on top of that, right? Because of the relationship you want to query the data for on top of NoSQL, right? There's no join logic between objects which exists there. And again, no ACID support for the transactions that you will want to perform on that database, right? So this is how the ecosystem looks like, right? You have your key value pair, this is your Redis, Membase, and other things which stores the key value data. Then if you want to now have a columnar family, you can have Cassandra and other things that you will have started using it, right? Then for NoSQL or storing those documents, storing those objects, you start leveraging MongoDB, CouchDB, and also other solutions, right? Which is where the solution that we have been looking for, right? Let's say, the issues that we have been facing with relational NoSQL, which is where Neo4j comes in, right? Neo4j is a simple graph databases. So you can actually store this. Let's say you can write this query, right? Match person A whose enemy is person B, whose enemy is person C, right? So you can actually write this kind of complex relationship-based queries on top of that, and then you can actually have these inbuilt formulas, algorithms which are built on top of that, so that you can, let's say, just based on the data you have, the relationship that you have stored between different pages, different items, you can actually run this construct called PageRank, and it will rank all of these items for you, for that user in your whole inventory, right? Then a lot of the ML folks, right, we leverage embeddings a lot, right? Let's say for image matching, for embeddings or maybe vectors, right? We leverage them a lot to train model, find similarities, and a lot of that, right? So it also helps you to generate the embedding out of the graph that you have created, right? So based on that graph, you can actually now, so based on that graph, you can actually now embed the relationship between the data, right? Not just what the data is, but how two data points are related. You can actually embed them and then leverage them on your models to train it further or to learn that construct of how two persons are related. It's just that let's say if we try to build a node of, let's say a graph of all of the people out here, right? Consider each of you as a node in the database or in a graph. And an edge between you exists if you guys are friends or if you know each other, right? If there's a relationship between them, right? And then if we try to embed them into a vector, that might represent what GDG Chennai is, right? What it represents, right? What who this person is, right? Based on how their neighbor are, right? Let's say if there are connection between there's X person and then his relationship, the people that he is connected to are maybe let's say backend engineers, right? Or maybe they work in a similar company. So based on this relationship, we can predict what that person might be, right? What could be that attribute of that person. Now, once you have defined, let's say, one node and the edge, now that edge can contain any property, right? It can be stored as a named value pairs, it can be indexed so that you can run those queries on top of them, and you can also have a very fine-grained control of the security of the data, right? At a very user level or based on the RBAC, right? Role-based access control, you can actually implement them to have a very fine-grained security of the database, who can access it, how it can be used, where it can be used, and other things. Like. So for example, in this example, right, this guy Dan, there are his data, there's Anne, then, right? Dan is married to Anne, and then they both own, like Anne owns a car, but Dan drives it, right? So you can have the relationship, these kind of relationship is stored. And then see, each of these nodes have their own data, right? What they represent, what is their properties. So where there's, Neo4j fits in the whole Google Cloud ecosystem, right? So there are a lot of solutions, where which are caters to each of the use cases that we work, or each of the solutions that we build start working at. So for example, if you want to store documents, serve them on a serverless scalable manner, then you have Neo4j, right? So Neo4j is kind of in Google's solution or an answer to these graph problems. So Neo4j is again a partner, again a company, and again an ISV, right? Independent software vendor who comes in and gives their platform to us to build this ML like graph solutions. It could be ML, it could be or anything else. Right? So see, this is how an architecture looks like. If you a very simple architecture of using Neo4j to build your ML models, so your graphical ML models. So it starts with your BigQuery, your cloud storage where your data is stored. You use Dataflow to run those ETL pipelines that runs the data, that collates them together, and then generates these Neo4j graph DBs, right? And then from there, you can actually use the Neo4j graph data science platform to actually then generate those embeddings, build those models, run those, let's say, node classification models, relationship classification models. And then if you want to go even further for that, you can actually leverage Vertex AI on top of there to build more complex models, more complex solutions. Then now, let's say you have a solution, right? You have a model which runs on GraphDB, which has predicted, right? So which is where the Kafka streams comes in. It will take that output. It will then start connect, and then you can use to connect with your any external applications from where they can consume this data. Yeah. So this was demo what I had planned, but it did not go through. So I don't have a demo for you ready today. But there are these, so I'll just run you through that. I'll give you the notebooks, I'll give you everything so that you can play it around. I think that would be more better than me explaining you 100 lines of code here, right? So we'll have these tables, right? The customer tables are basically a fraud detection solution. So you have the transaction of that user, their profiles, their overdraft limits, their balances. So you collate everything together to build this graphical representation of the whole data, right? So you have these different tables, different nodes, and the relation between them. Let's say this person has this much balance, has this many credit cards, and this many. And then you leverage Vertex AI to actually train that model, make those predictions, and then use them with any application. Like I said, I don't have a demo, so I'm sorry I failed you. But yeah, you can scan this. Yeah, there is a Git repo which will point to read it more in more details than what I have explained. You can go through with that. Done? I guess all of you have QR code scanners, right? So we'll use that in the next slide for some more interesting things. Done? Done? Okay. So I have 13 minutes left for me, right? And I don't have a demo, so I cannot give them this 13 minutes back. I'll have to use it somehow, right? I'll have to give you more than what you. It's still fine, show of hands. So I was intending to run a quiz on that with all of you, and obviously there will be some swags. It will be not now. I'll with the help of the organizers, I'll collect your details and ship it to you. The top 3 people will get some swags, send it to your addresses. But yes, there are some. So let's open. Yeah. Open Kahoot.8, put this game pin and will be on. If you want to scan, there's a scanner. I'll wait 1 minute, so I have 12 minutes left. I'll wait 1 minute for you to sign up. And also put your real names. There was one place where people were using random abbreviations and then everyone is saying, I am that guy. Because now you cannot verify, right? This will be very basic questions.
Who is Amusing Dolphin?
Sorry?
Amusing Dolphin. Sorry, Amit, you were saying something.
Yeah, we have 80 people, 94 now. Last 10 seconds to join.
We have Elon Musk as well.
Okay, let's start then. Everyone joined in, right? Kahoot.it, put the game pin, you'll be on. If you don't have, you don't even have to scan. 150 people.
Mark Zuckerberg is also in.
Huh?
Mark also is in. I think they're joining from remote, if I'm not wrong.
See, if he wins, I'll not give him anything.
Yeah, we have Harry Potter also. See? HP.
HP.
Naruto.
It's me. So see, if you are not putting your real name, you'll not get anything even if you win.
We can't.
Because you are not verifiable.
So if the people who without the real name wins, I get the swags. So
or else they have their Twitter ID with a blue tag, then I'll give. But yeah, we'll start. I think we are at 175 now. I'll not lock it, so you can still enter. Get ready, it's fastest finger first, even if you know the answer, but if someone puts before, then you will not win. We ready to start? Ready to start? Okay. Vertex AI Workbench supports CPU only, GPU enabled, TPU enabled instances. True or false? You can also run the mics to people who just want to answer after they have. But yeah, we have. So we have 25% people giving the right answer. Okay, let's see who is on the leaderboard.
I wonder, Elon is not into
Shruti.
GCP.
Okay. Then we have Shreyansh, who is just behind her. So, next question. Simple, how well do you know this GCP icon? It's on my t-shirt also. And it was on the deck also. Is Vertex AI, but do you know what Vertex AI was previously called? It's one of the options here. Mics, anyone wants to take that? Anyone?
Cloud Vision API.
No. Or anyone knows what is Vertex API? Vertex AI. Okay, so Vertex AI was earlier called AI platform, and it's basically your end-to-end ML ops platform, right? You can get your data, store them there, your features. You can use AI platform to run your models, train your models in a serverless fashion. So you don't have to. Data scientists, right? You had faced issues with your infrastructure, right? That you have not got the right infrastructure at the right time when you need it. So this is a solution for that. You just need to focus on what you do, write your code. Vertex AI will take care of the infrastructure at the backend. Will give you as many compute you need. Once you are done with it, it will release them, so there's no additional costs. And then you can also expose all your models as an endpoint, have them scalable, have them in a serverless manner. Okay, so there's one new leader now. And there's someone, Abhijit Ganesh, who climbed up 18 places. So look out for him. Mostly people who climb up this fast wins at the end. Okay, next question. Again, another GCP icon. What is this? Hint, it looks like an eye. This is Cloud Vision API. Okay, Shreyans is still leading, but 4th and 5th places have new people coming in. Another icon. What is this? It looks like a signal, right? Sine wave or some kind of a wave. Okay, Shreyans is still leading, but there's Induja right behind him or her. Another icon. What is this? Backend folks. SRE folks. Yeah. So all your traffic comes to your load balancer, and then it decides which nodes to send in, which machine to send in, so that all of you get the latency you were promised. Again, what do you think? Shreyans will be still on lead? Okay. Yeah. So even if you know the answer, but if you're not the fastest, you might not get as many points. So you need to be MLE to use Google Cloud's ML APIs. True or false? People, true or false? Correct.
So I guess a lot of people will start using it right today.
Yeah. Okay. Shreyans is nowhere to be seen. Are you here, by the way?
Push. Sad man.
Okay.
You still have hopes.
This is your time to redeem. Vertex AI provides managed Jupyter notebooks. True or false? True? Can be false. True. So Vertex AI Workbench is your managed Jupyter. Data scientist folks again. Just go there, you have your same environment, your native place. You can just work out from there. Work from Workbench. There's someone right behind Induja. I think
it's all women, girl power.
Yeah.
All in the list. That's interesting.
There are 2 more questions to redeem. I think 3 more questions to redeem yourself. So, Shreyans.
Still have hopes? You have like 3 more questions?
What if tool is used to visually prove the behavior of ML models? So, this is from MN explainability or responsible AI. It can just take a wild guess if you don't know. Marvel comics, but it works like same. It tells you what will happen if your data changes. True. So what if tool is same, it's an exploratory tool, so you can mimic different data changes, different environment changes to see how your model reacts to it. And if you then see any anomaly on top of that, then you can take any action there. Okay. Okay. Which of the following is not an AutoML product? Okay, that was heartbreaking, I think, for some folks. But yeah, let's see. Okay, there's some new leader, and Induja and Shreyans, you guys having a hard time now. There's only one question left. Another icon to close it off. What is this? There's someone here. That's a hint. There was someone here who was talking about it. Correct. It's BigQuery. Let's see what our final.
Now comes the big query.
Huh?
Now comes the big query of who win.
Yeah.
Shruti,
Induja and. Okay.
Revati. So
we just
if you
take
guys
the
can
details
rise
and-
up so that we can collect the details.
We just bring them here, click a photo with them so that
Yeah.
we know they are these guys.
Yes.
Come here, Revati, Induja, and Shruti.
I think this is going to go on the WTM channels as well. You should probably go to the dash.
Come on here. A round of applause for all 3.
You should probably match the context. It'll be easier.
Maybe just
Yeah.
kneel down so that your name comes on top.
Or you should just jump.
Yeah. Okay, thank you guys. I hope it was something that you've learned. And thank you for the organizers for having me here. Thank you all. And feel free to reach out to me or any questions. I think our time's up, so I'll take it offline. And even if we cannot interact now today, feel free to reach out to me on LinkedIn, anywhere. I'll be happy to help you.
Thanks, Ahmed. I think you will be bombarded with the details about the swags, I guess, from now.
Yeah, so you have to collect the details and give it to me.
Yeah, definitely, I'll do that. How are you guys? Hungry? We just have one session. I hope, with that, we'll be going to lunch. So as I said, for lunch, before lunch, just make sure that you get the tags. You register yourself and get the tags. And also one important note is that currently, we are provided with one plate per person. So just maintain that alone. That is very, request from us, because else we'll run out of plates and then we might not able to cover everyone. So that is the only point. And probably we'll do the same activity again. So we'll get to know more people. Anyone want to go next? Like a just short note. I think there is some person. Just someone can get the mic. Anyone has a mic?
Hello. Hi everyone. I'm Dinesh. Kudos to the organizers.
Thank you.
I should say I'm a lockdown born techie, right? I got bored in the lockdown. I have a laptop and internet connection, so I tried to learn some tech, and 1 year passed. I'm a ML developer in organization. So I don't want to spend a penny to learn these stuffs. So I mostly learn these stuff through open source and all other communities, YouTube, all these things. Basically from the internet. Whichever is free, I learn from that. So one day I want to search of a community to talk to someone, to learn this stuff from them also. And that day itself, I got placed in the company.
Okay.
So one person came in LinkedIn and, hey, can we set an interview and we can see what you are up to or something like that. So that triggers me something like that. We should contribute the same community which got me into that place, right? So that's the reason I looking for some in-person events in Chennai and wherever I need to go somewhere. So I very eager to attend the DevFest when I heard there is something called the DevFest and it's going to happen in Chennai. So that's the reason I am here. And a big shout out to the person who got me placed in the company, who is here.
Okay, that's interesting. I think that's the power of community, right? Like you get to know people, and then you have the ability to learn things that you get access to a lot of things. Yeah. I think that is something that as I covered in the initial point, like learning as well as networking. So I think that is these are the two important factors that you should also trying out today. Like we never know who will be your who will you meet here, right? Yeah. That's all like a lot of interesting stuff. All right, I think I'll leave the stage to Vasudevan.
One more thing, and not only him, whoever believes the freshers could also contribute their team and work, they also get recognized, right? So right. There is one meme, right? Do you have any experience? No, I don't have it. Well, you can earn it here, something like that. Right. So those guys should be like recognized, and they should be.
Yes, very true. I think the people who give opportunities to people want them very badly, right? More than that. Yeah. Definitely. We'll talk more on that probably after the after all the sessions. And now I think we'll get into the session so that we are not late for the lunch. Yeah. Thank you guys.
Am I audible? Yeah. Good afternoon. So it's very tough for a session before lunch. I totally understand it. So good afternoon again. This is Vasudev. So I traveled all the way from Hyderabad to actually deliver this session. So I would require your 30 minutes to actually learn about Vertex AI, whatever I was discussing. So we will go in depth of it, and I'll also run through a demo how exactly we productionize the models and deploy it. So any ML developers or whoever works with Python or data science, yeah. So it would be kind of mainly useful for you, day in and day out. And for every others, it would be a starting point for in order to start. So actually, hello Chennai. So I use Google Translate, to be honest, for Tamil and Malayalam. So I'm sorry if there are any mistakes, but I know Hindi, Telugu, and English, and a bit of Tamil. So I have a close relation with Chennai. So I completed my graduation back in, 6 years back from Chennai at Satyabama. So it's very
heartwarming to come back here. So any folks from Satyabama? Oh, that's great. We'll meet after the talk. So coming back, so we would just here to discuss about how exactly we manage. So right now, many people would write any machine learning models on Jupyter Notebook, or let's say in any Python files, and then try to deploy it in any services, be it any cloud or be it any private cloud. So in this today's talk, how do we go beyond that? How exactly we can deploy so that it is available for multiple users across the internet, and how do we secure it, and how exactly we can monitor the models. So that's what the target for today. And I work at Accenture AI as an ML engineer, and also a bit involved in the open source as well. So mentor at GSOC. If you don't know the GSOC is a Google Summer of Code. I actually mentor for TensorFlow and Fossology. And then I'm an active contributor, speaker. So that comes as a byproduct for whatever the work I do. So just a disclaimer, so whatever I present here is solely from my perspective, not the Accenture's. So this is pure community event. So whoever works on ML or follows the articles and the updates, so this is something which is actually retrieved by the text, millions of text lines from a DALL-E. So anyone know about DALL-E? Yeah, it's from the Open AI, and this is a rendered image, a person walking on a green desert. So how exactly these models have been trained? There are kind of billions of records, and on top of billions of records, this image, the text has been trained, and from them, actually, the images have been generated, right? So we were advancing very fast. So did anyone actually build any productionized models, and do you want to share your story? Anyone? Like lively working and supporting the business. Okay. So it actually not easy in the way how we look at it. So let's say I built a model, let's say regression or any computer vision CNN model. Yeah, the model is built. How do I deploy it and provide a business value? So if I say a statement, whenever I build something, unless it gives a business value, will it be useful or not? How many people would you agree with it? Right? So many of you. So after a point, we need to show the business value, at least at an organization level, if we are working in an organization, or let's say if we are working for any research or any research problem, then that is fine. But for the organization's perspective or any problem statement perspective, we need to show how exactly whatever we develop is leveraging that. So how do we prepare for it? So let's say we have certain problem statement to build a model, and we have the core skills and strength to build the models. And how do we deploy them, and how do we actually get the at most optimized business value out of it? So that's what we would see here. So that is the reason we are sitting in this session, and I'm trying to explain whatever I learned from over the years. So how do we think in general? So what would be the general tendency of the ML architects or ML problem engineers? So here, the team thinks we can generally hire the data scientists and build the models, and then we would be deploying the models in production. And after that, we can deliver the business value. So this is the general straightforward tendency to actually look at how do we solve the business problem. But this is what happens most of the times. So we try to build everything, and when we want to translate whatever we have built to actually, let's say we have a predictive maintenance problem statement. Like I have a shop floor. Let's say we have been talking about automobile industry in this day, on this day. So let's say we have a car manufacturing, like we have Ford Motors. So I worked at Ford Motors before, so we have a plant here. So let's say I need to, there is a module press where a module press would be pressing the Ford, let's say, EcoSport doors. So if that particular machine fails, so what is the business impact? And in order to actually address that, there is a solution called predictive maintenance. So if my model fails to detect, or whatever I developed, it fails to detect when it would be failing next time, so it's of no use. Like I spend millions of money but at the end of the day, let's say it doesn't actually show for 100% of the times. Let's say if it at least need to say around 80% of the times so that we can invest millions of millions into it. So like this, there are many problems, and again, the solutions which we develop for using machine learning, deep learning are the ones which can solve those problems, but how efficiently we do that is something which matters. So let's say we are in an organization or a team and we haven't implemented any ML till this point. So I just want you to think from that perspective. So let's say if we don't have a ML model right now, so one of the teammates says, I want to develop an ML model. And so at that point in time, so we will be only having one model per team. So let's say after a few days, the model which has been built by the other team shows the success and business impact. So post that, what we would do, we would actually, other teams are focusing on building the models to solve their problems. Now, in a single organization across the departments, let's say we have 10 models each. So if we don't streamline that, then each team and each developer would deploy in their own way. So that's where a tangible, it would be a very hectic process to manage each deployment pattern. So let's say we have 100 models across the departments and each team deploys in their own way. So now this is the point wherein a concept of ML platform comes in. So let's say we have 100 models and we have 100 or at least 10 different way of deploying models. So I would deploy on a Kubernetes cluster, or someone else deploys on App Engine, and someone else deploys on their own laptop and do a batch processing and send the results. So there are many ways. So how do I manage it? So whenever we deploy something or whenever we want to take something to the production, right, we also need to think about capacity planning, monitoring, deployment, and incident response. So it's a pure play software reliability engineering. We would apply those concepts here as well. So when we say the KPIs, there would be some metrics. What is the CPU usage? What is the latency of model inference? So let's say I call a particular computer vision model, what is the latency time at which it replies back to me with a response? And there would be the data skewness. And so these all concepts come under model monitoring. We will also see some of them. So let's say now our goal is to build an ML platform where it would be serving all the developers in the organization who wants to deploy a model, right? So I am a developer and I want to deploy a model. So let's say till yesterday I have nothing. I would be going on my own way. Now from tomorrow I'm actually having a platform to follow certain steps and deploy it. So that's how that's what we are trying to discuss in this particular session. How exactly, what are the basis on which we build an ML platform? So there are 4 things in order to design a reliable ML model. So firstly, making failure obvious. So these are the ideal or general steps at a high level, wherein I have a data storage. So I have a data storage on which I would save my data. Let's say it would be data lake or data warehouse, and we are not getting into that details. And we have certain feature engineering and the feature store here, and then we will be having core machine learning models, and then we would have the results and the inferences out of it. So this is a general basic machine learning model. So how exactly, let's say if my entire platform has only these steps and it works disjointly. So let's say my data pull from, let's say, BigQuery is not is not integrated with feature store. So I'm doing each and every job separately. So we can't actually point out where the failure is. So in order to do that, we would actually configure the application level logs, infra level logs, and the inference level logs and model logs. So let's say when new models are coming in, and there would be inferences, and there would be models serving, let's say, batch or online model. So in all these cases, we need to have a approach to, we generally term it as observability. We need to have a provision to actually look at it, how they are working and what are the internals of it. And let's say so for that matter, whenever we deploy each step separately, we need a manager to actually check on everything. Like, let's say we are a team of 4 people, I mean, in the people terms, and every developer is working on something. So unless it's self-managed team, we would need a project manager to manage all the project, right? So in the same way, when we have different steps, like data cleaning and feature engineering and ML experimentation and then deployment. So in this case, we would need an orchestrator. So orchestrator is nothing but it would take care of each and every task, whether it is running seamlessly or not. So we'll also see which orchestration engine we would use in our case and how it is helping versus when we don't have it, how it is impacting. Right? So let's say the other case is whenever the inferences are happening, let's say I have an online prediction model and per second there are 10,000 requests and inferences which are happening, right? So in that cases, after 100K requests, I see a data skewness or I see a model decay. Like over the time, the results are not so great. So now the platform should provide the particular developer or data science modeler to a provision to actually check whether or for which input data there is a glitch, and he needs to trace out what is the input parameters which user is sending and at what point the model is showing the different results. So we need to have a provision for it. So as we are discussing in the designing of an ML platform, so we are actually noticing all these concepts. And the second thing is validate production changes. So in the core software, what do? We have 3 different environments, right? Staging, test, and production in general. And we have development, feature, branch, all that, right? So in the same way, when we do it for ML, we need to check each and every experimentation. So ML works as experimentation. So let's say I'm building 10 models and there are 10 different data scientists. So each person builds a different model and I want to integrate it and deploy them together. Right? So in those cases, I'll do separate ML experimentations. So after experimentation, I would push that model to a development branch, and on top of development branch, I need to write test cases. So in software, the general test cases are Python. Let's say if I'm going with Python or Java, so language-based test cases would be there. But in this particular context, we need to have a model-level test cases, hardware-level test cases, and also we need to have a latency test case. So what is the input and how much latency it's being, whenever the inference happens, how much latency it is showing up. So we need to have multiple test cases. So I deploy on a Linux machine and the other person deploys on a Windows machine. So we also need to check what is the latency among different hardware or operating system which user is being using. So we would discuss that. Let's say we have feature processing, binaries, training pipeline, serving binaries. So before that, I want to say that whatever the steps which we are in here would be as a containers, be it a Docker container or any other container. So every step is configured as a Docker container, right? So now, let's say the data engineering team says that they want to change the data schema because the modeling team says they want a different schema of data. Now let's say we are having a production and end-to-end running streamlined system running. So if the data engineering teams come in and says they have a new binary wherein they have changed the schema or data types of the data which they provide. So in such case, how do we handle it? Or there is a new training pipeline where the ML engineer says, I want to update my model or change or tune parameters. So these are the practical scenarios which happen. And we have serving binaries. Let's say I want to scale or I want to change the inference or I want to change the threshold on which the model metrics comes in. So these are some situations. So how exactly these changes would be adopted and streamlined when I deploy the models, right? So for this, we have a configuration. So every container and every code which we deploy should be parameterized. So let's say I have the training pipeline. So let's say if I have a parameterized model code, I can supply hyperparameter. Let's say we have a neural network. For that, I parameterize the learning rate and also number of layers and dropout. So I parameterize them so that I could not actually touch the code again and redeploy that container. So by just changing the config file, I can manage it. Of course, this would not be possible when we want to change the core logic. However, these configurations and parameterization would play a higher role whenever we are kind of experimenting the ML models and trying to deploy them. And we have validating and config changes. So in the same way, let's say the second step of the model has development environments version, and the third step has this end-to-end pipeline actually holds the same branches or same version of the outputs. So what happens is on day one, these things would not be very, we would not see very significant sort of these. But let's say over the 6 months or 1 year period when we have thousands of versions of models and we want to trace out on which day which model has been deployed and which configuration has been used. So these things come into play and this actually solves that problems. And then we have binary rollouts. So whenever a model is deployed, we need to be assured that we have a monitoring in place. And when I say monitoring here, there would be an approval. So whether a person is an approver or not, in the Git we do that, right? So in the same way, we should have a ML approver, wherein whenever the binaries are changing, he or she need to actually take care of it and approve that build or not. So whenever there are changes in the data, changes in the schema, so these are the certain cases wherein the model would change and the inferences would change and the raw data would be updated. And we also need to see how the data is being updated. So let's say I have a problem statement where I need to run the models every Monday, weekly, right? So every week a new model will be executed and that models would be first tested against the automated test cases. And the most pain point in end-to-end ML deployment and platform is human in the middle, right? So whenever I want to deploy something, there should be a manual, if the business wants it, there should be a manual interaction or interaction point wherein I need to select whether a person needs to actually check that model before moving it to the production, right? So that also needs to be taken care. And whenever the data changes, the retraining happens. So whenever the retrain happens, a new model binary would be generated. And whenever the binary is generated, we need to move across the different environments. Whenever we move through the different environments, we need to check whether the particular model is being used across all the, new binaries has been used across all the steps of the pipeline. So these are the certain cases where we need to take care of. And then the data integrity requirements. So till now what we have seen is make failure obvious. That means let's assume whenever failure happens, we need to have an observability mechanism to just see out or provide a provision to whoever the right stakeholders are to let them know what exactly happened and validate production changes. So whenever something changes, I need to be aware and there would be a monitoring mechanism to actually check or not. And then we have data integrity requirements. So let's say when we are building an end-to-end platform which would be used by thousands of people or number of people who are part of the organization, right? So there would be multiple data engineering teams. There would be multiple stakeholders who provide the data. There would be third-party data. There would be vendors' data, partners' data. And let's say we have ERP like SAP in for Oracle. We have those data as well. How efficiently we manage who is the owner of that data and who provides the particular data for the modeling team and what data should flow for every retraining from the data engineering team. So all these aspects comes in when we think of building an ML platform, right? So let's say, there is a scenario which happened in my case. So we built a model and we wanted an updated data. Now data engineering team doesn't respond to that and he delays. Then the model retraining delays and everything flows on. So we need to be clarified on, at the start of the project itself, who owns which part of the data, right? So that is one of the important things. So if something happens, we need to have a clear point of contacts and also we need to maintain a data catalog or we need to have a data governance principles who can access which particular part of data. So this, in Google Cloud, we have data catalog service and that actually helps us to resolve these kind of issues. And then we have handle pipeline backlogs. So let's say I have a model running and there is a sudden drop in the model efficiency by using the metrics. I came to know that. right, for example. So now I need to prioritize the workloads and which should provide a single point recovery. So I need to able to provide a provision to pick one part of the entire pipeline and allow the users to deploy that particular model itself. So that is something which is the pipeline backlogs, right? So till now we have discussed how or what are the considerations which we need to have before building an ML platform, right? So right now what we are seeing is whatever we have discussed till now, how we can translate to Google Cloud and build it. So these are some of the services which we can use, and whatever the problem we have, let's say computer vision or a forecasting or a pure regression or any kind of problem we have, how can we efficiently solve by using these services? So that is our end goal, right? So we have certain theoretical approaches which are proven approaches, and when we come to implementation practically, let's say here we are discussing on Google Cloud, but the same thing works with AWS and Azure or any other major clouds. So how do we translate the methodology to a practical implementation? So that's where the next 10 or 12 minutes of the session is. Whatever we see here are part of, some parts of these are covered in the quiz earlier. So we have a Vertex platform, and we have a pipelines for orchestration, as we discussed. Whenever we want to build a platform, what we need to have, and we have an infrastructure and notebooks for experimentation and Wiser optimization data sets. So we would see most of them. In the interest of time, I would move a bit faster, but so we have feature engineering. So whatever the 4 steps which we have discussed earlier. So here we can see this is the data, and this is the feature engineering, and these are the model experimentation code, and this is the inference after the output. So that was at a high level, but here we have model serving, tuning, edge deployment, monitoring, and management. So we would also follow through each one of them. So here comes the Vertex pipeline as an orchestration engine. So we have, anyone worked on this? Any similar tool like Vertex, Kubeflow, MLflow, or Airflow? Okay, so how do we use it, and what is the major role of it? So in the layman terms. So let's say I have a data cleaning code, I have a feature engineering code. So let's say in the data cleaning code, I would treat missing values. So in the basic missing value treatment is I would average it. Let's say if it is working or not, for the first time, I'll average all the values and fill the missing values, right? The second is feature engineering. I'll do a correlation matrix and correlation analysis, whether how each feature is working with respect to each other, and select the top features. So let's say that is my feature engineering. And then I would train a XGBoost or any regressor. So I would use sklearn or any other library and train the model, right? Let's say I have it. And then I would do a model evaluation. So let's say we don't have Vertex pipeline or any other pipeline orchestration mechanism. I would chain this entire code as a functions in Python itself. Like I have a data cleaning code, feature engineering code, and the other codes which follow. So when we have a pipeline orchestration, what happens is I can actually chain the pipeline. So I can actually chain the pipeline like this. So the first step is, so however this code still contains that Python native code only, I can chain each steps. Like I have a Python data cleaning code, and then feature engineering code, and then model code. Let's say if I want to run multiple models in parallel, I can have a parallel pipeline execution, and then I want to have a comparison between the metrics. So let's say I have a set of data, I want to check which, I run 10 models, like let's say forecasting, I run 9-point average, 3-point average, and all the ARIMA models, and I arrive at a solution by comparing all the models' performance. Right? I can also do that based upon the conditions specific component in the Kubeflow, and then arrive at a result and directly deploy it. So that is how we use orchestration. So it's, generally it is termed as a one-click deployable system. So let's say we have everything ready. I need to just chain all these models into these pipeline components, and then right away deploy it. So we'll also see an example pipeline. So how do we use it? We have a pipeline like KFP, which is Kubeflow pipeline. I mean, right now we are using version 2. Version 1 is kind of deprecated. So under that we have components, compiler, and pipeline. So we use these three in order to convert our Python code into components and then pipeline. Right? So what exactly is a component? So let's say we have a data cleaning. So let's say we are using pandas. We use a pandas function like to check how many records are actually having a missing values, and I do a df dot replace or df dot of the entire column to 0. So that Python code would be actually here. So that Python code I'll be writing here, and just an annotation which is a component, right? So in this same way, I have my Python function and wrapping it inside a component, right? And then each component would be in the similar fashion. So then what would I do? So I would wrap all the components into a pipeline. So I have a concat component, for example, in this case. Then I would wrap that concat component. So these A and B are the parameters. So for every model run, I would be actually passing the A and B as a parameters. And this is how we are chaining each and every component. And as you see, this has a pipeline word here, which is an annotation which works as a pipeline build, right? So now we have pipeline. It's nothing but a chain of tasks. And now we compile it, right? So what exactly compile does? So again, Vertex pipeline and Kubeflow runs on top of GKE, I mean, with this Kubernetes engine. So can anyone say how Kubernetes works? I mean, do we write so what is the configuration which we write for Kubernetes? Anyone? Yeah, YAML and manifest files. So this compilation generates two files, which is a YAML manifest file, which would be applied on top of, I mean, Vertex pipeline is again a managed service. So it generates a YAML file and it applies on top of it itself. And we can take that YAML file and put it on any Kubeflow. It would run with minimal changes of configuration. Right. So a time for demo. So I have 6 more minutes. So can you able to see, or shall I zoom in? Okay. So as we have discussed, so here we have a prepare data task. So when I click on this prepare data task, so now let's say we have prepared data task. So every task has some outputs. So let's say in this case we have CSV files or Parquet files or any other files for that matter. So all that static or flat files would be saved in this bucket name. Right? So these are the artifact storage, the bucket name. And I have two outputs, which is target variable update output and data subcategory output. So we would be having two outputs. I mean, this is our case, but we can have n number of outputs. And then we run this particular code, which is actually our XGB and clustering code. So we can further optimize this, but this is just for a demo purpose. And once we execute that code, we have attribute importance. So all that attribute importance and the data set and the flat files which generates would actually saves in the GCS bucket under this particular storage. Right? So this is a sample pipeline. So we have prepared data which actually wrapped up inside a Python code and written as a component. So this is a component. Prepared data is a component. And then we have run attribute importance. So we have a Python code which works as a clustering code or any particular machine learning code. So in this case, it's a clustering and it is wrapped as a container. As a component and then pipelined. So when I want to weave the lineage, so lineage is nothing but what are the touch points of model right from start to end. So please bear with me. My network is a bit slow. Yeah. So here the lineage is nothing but what are the outputs and inputs for each step. So let's say I have step 1 and I have step 2 and what are the intermediate outputs and intermediate and the last output of each and every task. We would actually see them in the model lineage. Right? So this is something in order to orchestrate it, and how do we deploy it? Right? So this is how the general practices which Google Cloud suggests. So Can you able to see it? Yeah. So we have cloud storage. I mean, let's say we have a Colab. Colab is nothing but a Jupyter notebook. Most of you know that. Let's say we have Colab or Jupyter notebook or Vertex Workbench or AWS SageMaker Workbench. Any which ways. Like I write my Python code, so there is some medium to write my Python code, right? And then I have a data set. I push it to cloud storage. So most of you know we have a cloud function with trigger of cloud storage file creation. And we use that cloud function. And in that cloud function, we have a business logic to execute the Vertex pipeline. And the Vertex pipeline holds end-to-end steps right from reading the data from BigQuery or any other database to execute all the steps which are required from end-to-end machine learning. And the last step, so here, as I said, the conditionals, right? So here, these are the conditions. Let's say if the model is already trained on that copy of data, we would not run the entire pipeline again. So we would just stop it here. So let's say if it is not executed, we can again train the entire model, right? So let's say finally, we have new model and the old model. So we call it as Challenger Champion Framework. So we have a champion model, which is deployed in production. We have a challenger model, which is the currently trained one. We compare the challenger and champion model. And let's say if the challenger has higher efficiency based upon the metrics, we actually replace that in production. Let's say we have the champion model with the best metrics, we would keep as is. So this is the challenger champion framework, which is happening in these steps, this step. So this is how we deploy it. And I would just show you the code. So this is the trigger code. I mean, here we are using a online prediction, but whatever I have shown in the image was a flat file prediction. So this is the code which we are actually trying to run the particular pipeline. So here, we have a trigger pipeline function. So I would send the parameters. So in our example case, it was parameter A and B. And here we have AI platform. So as you know, based upon the quiz, Vertex was earlier known as AI platform. So that is the reason we are still having AI platform as the SDK name. And in that AI platform, we have a pipeline job. So pipeline spec URI. So this is nothing but the YAML file it generates on compilation, right? So we have that template path here, and I would run this. So a job.submit actually runs the model. So runs the end-to-end pipeline, right? So whenever a pipeline is run, it actually gives us few files like this. I mean few executions. So we can have multiple executions. So all these are executions for each trigger. And for each pipeline execution, it costs $0.03. And irrespective of using the other resources. For end-to-end pipeline run, without using any resources, it costs 0.03. So I would just take 3 or 4 more minutes. So these are, this is a simple pipeline, and this is the pipeline which we generally used in our last case. And we can have GPU and machine type. So this was the first quiz question which Ahmed was asked. So we can have GPU and any other machine types as well. Like we can configure it to be NVIDIA Tesla 4, P4, T4, right? Component types. So this is one more discussion point wherein we can have Python code as is. Or let's say if I want to run from computer vision code. So ideally computer vision codes need some libraries like NVIDIA libraries or CUDA libraries or TensorFlow GPU libraries. So across the environment, it's very hard to maintain those libraries. Right? If I code in Windows, it would be a different approach, and if I do it in Linux, it would be a different approach, because whenever we run computer vision code, it actually interacts with the core OS kernel to execute the models. To train the models, right? So for that matter, we in such cases, in such complex cases, we go with a container-based component. So and the other approach why we would go to container-based is, so let's say as we discussed in the ML platform, our vision is to build an ML platform. So whenever we have a data cleaning task, so let's say we want to use the same data cleaning task across 10 or 20 different teams, right? So Docker container or any other container gives us a reusability factor. If I write a Python code, I need to share the entire Git repository with the other team, and he needs to download it and then reuse it. However, if I share just a Docker image URI, I can any other team with the same logic to be executed. So can be reusing it. So in the organizations, what happens is, matured ML organizations, what they do is, they actually create utilities. Utilities such as linear regression utility, or let's say missing value utility. So what it actually takes is, it would right away take parameters and then run it and gives the output. So these small things may not need any other requirements in order to execute. So we have certain artifacts which we have discussed earlier, and model lineage, parameters, parameterized pipeline, base image. So whenever we use the end-to-end from ingestion to deployment, we have AI platform managed datasets and AutoML. AutoML like ML APIs which are readily available, or AutoML, so provide data, it itself trains and models evaluation and deployment. So Vertex platform covers all this, and these are the certain touch points. And what tool is right for you? When we don't have the training data, we go with ML APIs. And when we have data but we can't code ourselves, we go with AutoML. And it purely depends upon the use case. And it's nothing to do with what would a development team know. Right? And thank you. These are my social media handles. And if you have any questions or if you want to interact with me offline, I'll be available till 4:30, so you can interact with me. So any questions right now? And thanks for patiently listening to me during the lunch time.
And basically, we are focusing on the solution architect around AWS and Google Cloud. So yeah, many people have already reached out to us in the outside and applied. But yeah, you can also just come out when you actually want to apply when once you get to finish this event, or even you can also come in between if you are just want to reach out to us. So yeah, let me talk about the Evolve Tech. So what do we actually do? What is our culture? So I'm a final year student. So I co-founded this company, and my another co-founder is talking in another track actually. What we actually did is we just created a culture which is not here in this corporate. So what we actually do is we are fully bootstrapped, started from zero, and what we do is we do all the thing in remote. From the scratch, we have built everything from the remote based out of work. So right now we have people around 30 plus who's around the globe. So who are the core members of the Evolve Tech. And also there are many people who's like partnered with the company, and they are also working with us. Yeah, if you want to know more about our culture, you can just reach out to the outside. Yeah, I guess the time is over. Maybe we can talk briefly about our company outside. Thank you.
So perfect. So next up we have Abhishek. How many of you know Abhishek? So the guy who emailed you about the invites, I guess. So he's going to talk about distributed systems, distributed database, majorly the relational database. I think he's busy. Abhishek? Okay. So just like our event being distributed between two halls, he wants to see, he wants to show how the data can be distributed.
Thank you.
And he likes jokes, so expect a lot of jokes.
Yeah, I'm not going to do any dart jokes today. No mocha jokes as well. Okay, before I start, how many are super sleepy? Super sleepy. Okay. I'm going to give some goodies here. Still super sleepy?
Okay. Make us more sleepy?
Yeah. So, don't worry. I know we had a pretty nice lunch, but I just need a kind of very small attention of yours throughout the session. And this talk is not going to be like a very thorough or not very deep dive into distributed or any particular technology stack. So I'm gonna, and we know what is relational database as well, right? Okay, table and rows. Good. So you saved 2 minutes of mine. That's awesome. So that means the more you know, the better it would be for me and you, so that we'll have a very small session and you won't feel sleepy. Postgres? How many of you have used Postgres? Wow, that's a huge. What other databases have you used apart from Postgres? MySQL, Oracle. Who uses Oracle? Oh my God, Oracle. Okay, that's like dads of the database, but fine. So today what I am going to cover throughout the talk will be keeping PostgreSQL as a benchmark, because if you see the database trending, database ranking and the trends of relational databases, right? Postgres is actually quite a famous. Why? Because it's an open standard, and even if you see whenever a new database is coming or any innovation or cutting edge technology you are seeing in databases, Postgres is being used as a standard, right? Because it gives you flexibility to build a lot of extensions, a really good support from the community, right? And a huge library support from all the different programming and developer community supports, right? And if you want to know more, definitely you should check out DB Engine, right? And that is why I'm going to keep Postgres here as a base benchmark. Now, when you use single databases, right? What happens? When I start a project, what I do? I'll say, fine, this is my front end, this is my back end. I'm using single database, let's say a Postgres instance, and I build a what? Most of the applications are CRUD applications, right? You do CRUD applications, right? And then you build it, fine, okay, my app is working all fine and good. But what happens when you see the performance issues. When do you see performance issues? Like, yeah, concurrent writes, that's a really good example. And read could be a performance bottleneck as well, but I mean, that could be easily solved. We'll see how. So, and again, when it comes, everybody is saying that, okay, I want to build an application which is geo-distributed application, which means that the application that you have built is accessible across different geographical locations, right? Let's say you are using Amazon in India or US or Central Europe somewhere. Or not only just that, in India also you are using it from different locations, right? There is not a single instance of database that is being used behind the scene, right? It's not one Postgres or one RDS instance, right? They use multiple instances. That's like, you can say that scalability factor, right? So let's look into very common issues that we face when we build an application, right? Let's say we have our first version of application. Again, this talk is not going to give you a very, if you already know what distributed databases are, good. You may skip my talk. And this is just going to give you an overview of what exactly distributed SQL databases are, why do you need them, and what are the challenges that it solves for you, right? This is what we are going to see. So let's say I have one user who is a financial advisor from New York, and I have deployed my application instance and the database instance somewhere in the US region. Considering that we all are on cloud platforms or whatever you say, right? Kubernetes, all bunch of stuff. We deployed it, right? It's going all good. Now, what happens suddenly? Let's say earthquake happens on the region where your data center of this particular cloud provider, I'm not saying your on-premise server. Because we rely too much on cloud providers, we say that they run 24/7, right? But they don't, right? Technically, I mean, what if a cyclone comes in and the entire data center goes off? So let's say this happens, right? What is the solution to this? How will you avoid it? This is one problem, I would say. Then you'll say, hey, Abhishek, it's very easy. What I'll do is, in the US region, I'll create multiple instances of my databases, right? Database, and same multiple instances of application. So let's say if in single region, somewhere here, if failure happens, I can use this too, right? Very obvious. Considering that currently we have users from the same location. That was the first issue that we could solve using creating multiple read replicas or something like that, right? Now, second issue is, let's say now your app is growing. Now you are expanding to different locations, right? Geographical locations, I'm saying. Now you have a user from somewhere Europe. The app is working all good, but still there is a few latency, right? And then again, we have someone from India, and then latency is in fact more, right? Here I'm not talking about application layer. Application layer, you have a lot of solution to do things. You will say, okay, I'll use load balancer depending on the user location request. I'll reroute to the nearest application, right? A container, and then I can technically do that. But with databases, it's not that easy. So the only solution, I mean, these are like two common solutions I'm taking here right now. They could be multiple. These are like a core problem statements. So first is, why do you need to scale it, right? When you say that you have a single, we explained, I mean, to have a high availability, or I would say fault tolerance, to avoid that we'll have multiple database instances, right? That is one part of scalability that you need. So of course, we need to increase application performance, because let's say if you have an application which is being accessed through different locations, right? And we want same user experience. And second is that business needs, when I say business needs, let's take an example of Big Billion Day of Flipkart, right? Do you think during the entire 1 week period, they use the same set of servers that they use entire year? No, right? Because they know that this entire week, a lot of offers is going to happen, and we will add more servers behind the scene so that it can handle multiple requests. That kind of one business need, right? Now, when you say, okay, fine, I'm talking about scaling, what exactly scaling means? Anyone knows what exactly scaling means? For this, I'm not going goody, but you can still answer. Yeah? Yeah, correct. So that is one part of scaling. Also, you have to decrease the number of nodes when it is not required, right? Because you want to save cost. You don't want to waste a lot of money, right? So in nutshell, the ability of your system to expand and I would say, again, reduce depending on if the request is increasing or decreasing. So your resource should, or the system should be able to adapt the same thing to increase the performance and on. So that's what, as he explained, right? That is in layman term. And again, as I give you an example of big billion day, that is again business need, but if you want to hit, this is a very extreme, skewed example, like which not all the application that you are going to build going to have millions of it, right, at the start. So yeah, so now the question comes, okay, fine, Abhishek, we know that we want to scale, scalability is the problem. Now the benchmark, I said, Postgres, and we are going to talk about mostly on the relational database, right? So when you say, okay, I want to scale anything, there are two types, correct? One is vertical scaling, second is horizontal scaling. Vertical scaling, you kind of add resources on top of same machine. Let's say you increase the CPU, memory, blah, 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 right? And horizontal scaling means that you'll distribute your load into the multiple instances, right? And as compared to vertical scaling, horizontal scaling is hard. Why? Can anyone say, any idea why it's hard to scale horizontally? Yeah, correct. That's like very apt point, data consistency. Because in vertical scaling, what is happening is you still have a single, like, of course, you'll say that single node failure is still, there's a possibility of having a single node failure. But it can still handle a lot of requests on the single machine. But when you say, okay, I want to do horizontal scaling, that means that when a single request is coming, you have to reroute through multiple instances, but you also have to make sure that whatever data, whatever the latest write has happened to your application should be accessible across all those instances, right? So that is one of the consistency problem, but there are a lot of issues. And when you say that I want to scale databases, it's mostly about horizontal scaling. Why? Because when you say, okay, I want to scale database, there are two types. What do you do it? In initial example, we saw that we created a multiple replica of database, right? So that is what you create multiple replicas. That's called as replication. And when you say sharding, that's like creating a partition. Let's say you have a single database logically, but you create multiple chunks inside that, let's say multiple instances, but they will logically represent a single database. So when I say that Amazon has one single database, it doesn't have one single database, just hypothetically I'm saying. Don't say that Abhishek said Amazon uses single database. No. So when you say that Amazon uses a single database, it could be behind the scene like a one partition could be related to South India region, North India region, right? Or probably East, right? So it could be multiple shards. So depending on wherever is your request, the request goes to particular shard and then it gives you a request. So it's like a single set, but divided into multiple chunks. Right? That's what the sharding is in simple terms. Now, can anyone tell me why horizontal scaling in SQL databases are hard? Okay, what else? What is the difference between NoSQL and SQL? What is the basic criteria of that? Yeah, that is one, correct? Relational, right? When you say SQL, it's relational, right? And when you say a database is relational, you have to maintain the transactions, right? So if a transaction has happened, let's say you are transferring a amount from one bank account to another, there should be a proper policy to make changes, revert, and all those things, right? Right. So now when you say I have started a transaction in a single database, it's very easy. I can follow those ACIS properties very easily, right? You have written an algorithm behind the scene which takes care of it. Now just assume or imagine that the transaction is happening across 3 to 4 different shards, instances. If one of the shard fails, how will you maintain the ACID property, right? What will you do? Now will you go behind the scene and write your own algorithm? So that's why scaling used to be a problem in the relational databases, but not anymore when it comes to distributed databases. I will see into it what exactly this is. And then one of the reasons why scaling horizontally a database, especially relational, is because the sharding, there are different mechanisms to do a shard. When I'm saying shard, how will you divide the entire data into multiple chunks, right? There should be some strategy that you will follow, right? Let's say, given an example of Amazon, right side, you will say that, okay, I have users, so I'll divide it depending on, for South India, let's say I have database deployed in particular region of South, which has only users of South India database, right? And same for other regions, right? Now, this is one strategy, but how would you divide in the sense, it's kind of based on range, or how will you create hashes? So there are different mechanisms that you do sharding on. So the famous one is, let's say, range-based or hash-based. But implementing those things are, again, very cumbersome. So you will not go, I mean, see, now you were solving a business problem. Now you're solving a tech problem, right? You want to focus here, right? So the manual sharding, have you all heard of CTSDB here? So basically, I mean, that's, if you go and read about CTSDB, the implementation that they have done as a distribution, it's a very formal and then default or typical implementation of a sharding, you can say. You go home, read about the white paper of CTSDB, you will know how exactly it works. But that is one form. But however, the sharding depends on your user requirements, like how exactly you want to do. Because depending on sharding also, mechanism also, your performance, degradation, upgradation, all those things are there, right? And that's why you should use distributed SQL databases rather than traditional SQL databases. So I'm just going to, this is what I'm going to talk about in today's topic. We already talked about databases, what are the problems with traditional relational databases. And we'll see what exactly distributed databases, and we'll see what are the different distributed databases in SQL, NoSQL zones are, and we'll also look into a Yuga by DB, which I'm going to talk about, which is an like open source database. I'm not going to do demo because I just have 10 more minutes left. So hello everyone, my name is Abhishek. I currently work as a developer advocate at Yuga by DB, which is an open source Postgres SQL compatible database for cloud native and all those stuff. I'm a Python developer. Any Python fanboys or? Good. And again, I am a community first person. I run few communities across Chennai and India. So one of the organizers for GDG Chennai. And I'm not a 10x engineer as well. And if you want to connect with me over social media, you can follow this handle. So we saw an example. Now let's take an overview of how exactly it looks like. So when you say, okay, I have deployed an application, this is how the typical architecture looks like, right? When you deploy any application. So you have a load balancer, or let's say global load balancer, considering that you have built a geo-distributed apps, right? And you have a multiple instances of application layer, but not the database. And depending on the request that is coming from, the load balancer will reroute the request to a particular thing, right? So as initially we discussed, as Sir mentioned rightly, that distributed data is nothing but a database which is stored across different physical locations into multiple instances, you can say, right? But they represent a single logical instance. Same goes for distributed SQL. The only catch here is that you should be, whatever problem we discussed, right, with the scaling of traditional relational database, it should be able to solve that. So replication across different databases, and again, the sharding, all those things. So when you say, how do I define a SQL database architecture, this is what a typical distributed SQL database architecture looks like. You have, let's say, 3 nodes in this case, but each node will be divided into 2 categories or 2 layers. One is API or the query layer, where exactly your query engine will be there, whatever query execution planning will happen. And then the data storage layer, which defines the strategy of how do you do replication and sharding, right? And this nodes basically, again, represent a single SQL database, and the communication happens between these 3 nodes. There are different implementations to do this. If you want to talk more in detail, I'm available after the talk outside. We can talk more into it. But the idea and then the agenda behind this talk is not to go very deep into it, just to give you a notion what exactly distributed SQL database is. So when you say that, okay, I know or I have come across a distributed SQL databases, these are the characteristics at least a single distributed SQL database should have. Should have an SQL API to query, right? And second is, as we discussed, automatic distribution of data across different nodes. Because when you say, okay, you want to do replication and sharding, it should happen automatically, right? Of course, you should have an option to tweak the parameters. That's a different thing, but typically this is how it should look like. And then replication, depending on what level of consistency you want. And then again, distributed query execution. That doesn't mean that you have, let's say, 3 instances of your databases. But whenever write request is coming, it only happens on one node. No, that is not distributed SQL database. The query execution should also happen on the multiple nodes. And then again, it's distributed ACID transaction. And to give some example of distributed database, Google Cloud Spanner is one of that, and Yugabyte DB is also one of that, and these two are SQL databases. And when you say NoSQL, again, we know very famous Cassandra, MongoDB are there, right? So now you know how exactly your distributed SQL database looks like. And this is the typical architecture. In this case, I'm going to talk about Yugabyte DB, which is 100% open source Postgres compatible database. And this is a typical architecture where we are using entire query layer of Postgres. And the reason is we saw why in the second slide itself for the DB ranking engine. And the actually entire distributed storage is inspired by Google Spanner. Just one note here, if you really want to understand the internals of how this distributed storage works behind the scene, Google Spanner has a really amazing white paper. Go Google and then you'll get it. I love that paper, so probably it will give you more idea why and when not to use, a typical replication or sharding strategy if you want to implement by your own. But yeah, never mind, that's out of the scope. And if you see here from the Postgres layer itself, of course, the blue box is the Postgres entire layer or query engine. But the orange underlines, that are the optimizations that we have done in Yugabyte DB. And yeah, so basically, why do you need a SQL distributed database is because you want resilience toward failure. Like I gave an example of high availability, right? That is one. You need your database to scale horizontally. And again, if you are building a geo-distributed application, there should be ability to deploy your multiple instances on different locations. And of course, the typical SQL and RDBMS features, right? And this could be optional. That is just, it need not have to be like. So basically, before using, when I did not know about any, in fact, before joining Yugabyte, right? I did not know that there is something called SQL, distributed SQL database exists, right? And that was literally kind of my reaction. Because when you use, one second, yeah, I have 6 more minutes. I'm not going to do demo. So that was the talk about I wanted to give an introduction about distributed SQL databases. And if you want to learn more about database internals and building high scalable applications, these are the really 3 amazing books. And you can also, if you want to know more about distributed SQL in general, you can go to Yugabyte DB University, which is a free sort of your self-driven course that you can do. And yeah, this is my handle if you have any query. So I still have 5 minutes. I think I'll use 2 minutes for question answer so that I can reuse this time for next speaker. So yeah, and you can use my slides. If you want to access all other slides, you can go to slides.com and Abhishek Mishra. So thank you so much. I'm open for questions. I would like to take only 2 questions, considering the time. Yeah. No questions? Okay, looks like everyone understood the concept of distributed SQL database. How many of you are going to use it? No one? But yeah, the underlying fundamental is that you never start your application directly with a distributed SQL database, right? You definitely, it depends on use cases to use case. You don't, yeah. Yeah, so so the replication basically, right?
Yeah, for example, if you use distributed, like thousands of...
Yeah. So you saw the storage layer, right? So we use something called raft algorithm, which is a conscious algorithm where you decide, let's say you have a 3 nodes, right? And typically in a raft manner, what happens is that there will be one leader initially, right? But it also depends on what kind of deployment you do. Let's say I'm doing a very generic 3-node deployment, which is like, let's say 1 cluster. So in this particular manner, all 3 will act as a leaders. So whenever any request comes in, all 3 will serve. But let's say if one of the node fails, but initially there will be 1 leader, and these 2 will be synchronously following that. And that's how the replication and the happens using the raft. Yeah, all the replicas, all the shards. But again, if you want to use Yuga by DB, I'm talking in general, in fact in the Google Cloud Spanner also, you can tweak the configuration, what kind of replication you want. If you say that, okay, you deploy one cluster in, let's say, India region, but you have a user in US, but you want to just improve the performance of the read. So you can just create one read replica there, and you can choose the replication factor and how the replication should happen, whether it's synchronous or asynchronous. So this ability, these databases give, whether Yuga by DB or any new or modern databases. So you can choose that behind the scene. But when you say typical implementation, most of this uses Raft algorithm, which itself defines how the replication would happen, and that is by default synchronous. So when you talk about security, it's not on storage level, to be honest, because whenever you deploy any application, it's all the implementation that you have done on network level. So when you say security, your database will not work on preventing a DDoS attack. That's the problem in your network, that you are letting any strangers request coming to your network. Yeah, but when you say, what if I perform a SQL injection, right, on a distributed database? Of course, it's a distributed that logically represents a one database. So if you say drop table, of course, it's going to drop table from entire database. So there is no save for that. Yeah. Yeah, last question, yes.
So when you do sync across different database, is there any trade-off on the latency?
Yeah, it depends on, again, when you say latency, it's all the network calls that you do. Right? So if you have done the deployment, let's say if I talk about GCP, right, and if you have done the deployment within the same region, so the latency between region will matter here, and on top of it, I think probably 10 milliseconds of replication factor you can add, you can say. No, that's what this distributed databases are. They'll take care of it. But it depends how you are going to create a replicas. That's what I explained here as well. Sorry? The replication. Yeah. So you can actually define on your data, on your cluster deployment level itself, which node or which particular cluster will serve the read request and write request. But typically, in this method, the read and write are equally distributed towards all the nodes. So that's what I mentioned. Like, let's say you have deployed 3 nodes, and if one of the nodes also fails, and let's say you have done a write request, so this write request should equally distribute in other 2 nodes. It should not fail. Sure. I think other questions I can take offline. I don't want to waste a lot of time. So thank you so much, everyone.
Thanks, Abhishek. Yeah. So thank you so much, Abhishek. And I think distributed databases, maybe we might have it might become a norm, considering this all our applications are currently like geo distributed. Like we build for a specific region, we build for the globe. So I think considering that soon, distributed databases could be the base requirement. So I think that was insightful for those cases. So next up we have Satvik. We'll be talking about TensorFlow. So any TensorFlow developers here? Cool. So TensorFlow is a framework built by Google majorly for the AI, ML and artificial intelligence. So more on that, I'll leave the floor to him.
Check. Hello. Yeah. Hi guys. My name is Anam Satvik. I am, as mentioned before, I am here on the TensorFlow quota because with a Google event needs to have at least one TensorFlow speaker. So, yes. Okay, let's start this. Wait, no, went too back, yeah. So yeah, this is my face. I keep changing my hairstyle every once in 6 months, so please do not get scared. And yeah, this is died again. Guys, please. That's my only content. Okay, we'll just wait. Yes, so meanwhile, so what is a recommendation? A recommendation can be defined as something, a suggestion or a proposal for what you can call to be a right course of action. A very good example that I can give you is in college, if you fail a subject, you have a bunch of backlogs, your professor will recommend you to start attending remedial classes and clear your backlogs. If a friend says he's bored, you would recommend him to go watch a film. So for the sake of the next 9 minutes that I have, I will be using the example of recommending a film to a friend or a group of friends. And yeah, okay. So now let's start with simple recommendations. Let's say somebody comes up to me and asks me, recommend me a film. I'm too lazy. I will immediately go up to IMDb, top rated film. I think it's Shawshank Redemption at the point. So I will simply take Shawshank Redemption, tell him, here's your film, go watch it. I know nothing about the user. I know nothing about the film. I just know this has the highest rating. That's all I'm getting. Simple recommendation. Now moving a little bit more. I go to the user, ask him his previous and past recommendation, films that he's watched. Well, very anticlimactic. So let's say, for example, he's seen a lot of Marvel and DC films. I understand that, okay, all of these films come under the genre of superhero films. So I am going to recommend him superhero films. Shaktiman, Mogamudi, Ravan, Krish, Hero, and so on and so forth. This predominantly covers content-based recommendations where I look at his past content, the content he's consumed before, and give him recommendations based on the features of the past content. Now, taking it a step even further would be called collaborative filtering. For this, I definitely need the slides. Because here we'll consider a group of users together and their collective likes, dislikes with respect to a bunch of films. Content-based, yeah. And we will, I forgot Minnal Murali, sorry guys. Good film, please go watch it. Yes, so now with collaborative filtering, let's have a look. We have users 1, 2, 3, 4. I hope you guys have really good memory. I myself don't know what the films over there. So let's say user 1, use your imagination people, come on, we can do this. User 1 is over here, 2, 3 and 4. Here we have Mangata, Bahubali, we have Master, yes, thank you very much. And then we also have Brahmastra, yes, thank you. So now let's say that user 1 likes, let's say user 1 has seen Mangata and Brahmastra, he likes the two. User 2 has seen Mangata, obviously everyone likes Mangata, that's a known fact here. And he's seen Bahubali, but he's disliked it for some reason. User 3 has only seen Brahmastra and user 4 has only seen Mangata. Yes, user 3 has also seen Master, guys. So now, with respect to collaborative filtering, we will look at both user features and item features. And here we have explicit features and implicit features. Explicit features such as user 2 has disliked Bahubali, and implicit features such as user 1, 2, and 4, all of them liking Mangata. So that means there is some common thread between these three users, which we will implicitly derive. So here we'll use an algorithm called matrix factorization. I do not have the time to get into that, but you all can Google it the same way I did. So effectively, we can, when it comes to recommending movies for user 1, we can look at the fact that he's liked Mangata and he's liked Brahmastra. So he likes Tamil, he likes epics, the entire. So we can go ahead and recommend something like Bahubali. Because we know for a fact that, okay, fine, Bahubali is also an epic. Because we have the content information and we have the user information as well. But whereas for user 2, he does not. User 2, he disliked Bahubali. So even though user 1 liked Mangata and Brahmastra, user 2 will dislike Brahmastra because that is an epic. And we know that he disliked Bahubali as well. So this is the gist of how collaborative filtering works. And moving on to where we bring in the deep learning or the ML AI aspect of this is where until now we've only been talking about features in the terms of binary or sets where like, dislike, user 1 is male, female, languages. But to collate all of these and use them in a deep learning model, Okay, yeah, this is just very embarrassing, sorry. Yeah, so now to use all these features together would be where we have something to extract this data, the latent features that we will not be able to understand. For example, can anyone tell me? Anyone just give me a film, please, at this point. I forgot the films there. Any film? Beast. Okay, let's take Beast, for example. Okay. So now, with respect to Beast, have you seen Beast? You've seen Beast, yes. So what do you like about Beast? You like Vijay? Okay, thank you very much. Another film from this side. Any film, guys, please, come on. Huh? Love Today, okay. What do you like about that film? Story, okay, they like the story. So now we have the explicit features that they've given, that he likes the hero and he likes the story. But there is no way for us to collate all of them together and train a model on top of it that can serve recommendations dynamically at large scales. So there we use something as simple as a sequential model where we can use the embeddings and other features. So this is where to build a hybrid deep learning model, we use TensorFlow recommenders. An out-of-the-box framework that TensorFlow themselves have graciously blessed upon this earth for us to use to build production-level models. And it's the same thing I've used at my own company. I should really stop pressing. Okay. Yeah, it's okay. So yeah. So do I go for the code? No, I'm kind of confused. Okay, so TensorFlow recommenders is built on top of Keras. And for those of you who don't know, TensorFlow itself is a very complicated language, but Keras is a higher level abstraction that makes it much easier for you to use its underlying features. Although there is a small learning curve that you will have to understand on how models work, it still does at the end of the day help you to build pretty complex models and use various other functionalities that exist. Okay, the diagram is there. How do I draw diagrams now? Do I have a marker at least? I'll start drawing. Huh? Okay, I'll start drawing, guys. Okay, so imagine the twin towers. So the TensorFlow recommenders entire system is split into 3 parts: the retrieval, the ranking, and the post-ranking. So for the retrieval model, yes. Thank you, guys. Yes. So for the retrieval. Okay, I hope all of you remember that model. You saw twin towers, right? That's all I need for now. So assume the twin towers that you saw there. And as I mentioned in the matrix, in the collaborative filtering, we have the user data and the item data. So now one model that will take in the user IDs and all the user features, and one model that will take in all the item IDs and all the item features. And we take the two of them, send them through sequential models, have an output vector, and then we do a dot product of the two vectors that we get from the two models. So this is called a two-tower model because twin towers was taken by somebody else already apparently. And then now one second. Yeah, the dot product of the two vectors that you see is basically a representation of the matrix factorization that we saw previously in collaborative filtering. And okay, then. So in the implementation stage of the retrieval model, TensorFlow graciously gives us their own task where we can use the retrieval task, and for this situation, for a movie-based recommendation, we can use something like a top factorized K metric to train our model. Hopefully, no, just go to the slide below there, 14. You handle it from there, please. Thank you. Yes, thank you. So it's as simple as defining the 4 lines of code that you saw over there, guys. Basically, it is one dense model with a bunch of sequential models, and it doesn't matter whatever you want to define in the model as long as it outputs one embedding vector. And the embedding dimension has to be same for the two models so that the dot product is a little more optimized. And because we have individual models for both the users and the items, these models can be as complex as you like. You can add text features, image features, anything you want, as long as the output is one embedding vector. That's all. And then, next slide, please. Yeah. So what you saw in that split second and is blinking right now for some reason is where we've defined the user model and the item model and the task. The task being the top factorized K that I had mentioned before. And all we do is we send the two of them into the retrieval task. It will do the dot product and try to optimize for the scene features, the scene items and the scene users, so that the dot product or the affinity score for seen items with users is the highest. And if that output is good, then it means we have a good model. And to get our recommendations out of the retrieval layer, we will just add something as simple as a brute force layer so that we can index the entire embedding space and we can get out movies as and when we like. So one major thing about the 3 stages that I missed because I did not have my slides was that the idea of having it as 3 different stages is in a real world production scenario, we have about let's say 100 million items or 100 million movies today that I can recommend to each and every one of you. But it doesn't make sense for me to traverse each and every single one for any reason. So the idea is the retrieval stage reduces your item space from 100 million to a few 100,000. And then our next stage, the ranking stage, from 100,000 to 1,000. And then finally our post-ranking where we just give 10 to the user. Because even that 10 we give to our friend, he won't watch. He'll be like, Macha, sorry, I slept off, I did not watch anything. I saw Tendril and I slept again. So giving recommendations itself, we will have to optimize it as much as we can for the real world situation. And now moving on to the ranking model. Next slide. Yes, for the ranking model, the embeddings for the user and the item model will remain the same. But here we have a different outcome that we're looking for where we try to predict a particular measurement of likeliness for the given item. In this case of a movie, we will take user ratings. Sir, for the movie Beast, what will your rating be? Okay, 8 out of 10 apparently guys, 8 out of 10. So the job of this model will be to predict that score. So once we have our output from the retrieval layer, we'll send in the user and the item to predict the score. So this is nothing but a regression model where we just try to find the predictions using a bunch of dense layers. And then for this, our metrics and loss functions will be something as next slide. Yeah, you just take this back. The metrics would be something as a mean squared error, or the root of a mean squared error for our metrics and loss, just to predict. And the output of this will be the rating. And once we get the ratings, we can just sort them in a single order and show it to the users as in how we want. So yeah, that is the gist of vanishing slides. The TensorFlow recommenders, guys. Next slide, please. Next slide. Anna. No, don't do this. Just it's fine. Like, yeah. So basically, to build something a little I believe in. So to build smart systems, I believe we need to understand smart systems, and the only way we can find smarter systems than what we have deployed right now in various production scales around the globe is looking at each one of us. Us humans are probably the smartest systems that exist in the world as of today. So the next time you give a recommendation to someone, like on a day-to-day basis, people will come and ask you, hey, what film can I watch? Hey, what restaurant can I go to? Hey, what food can I order? It's become such a subconscious process that we don't even pay heed to how the process happens in our heads. So take a second or take a few minutes the next time somebody comes and asks you, look at the item space you're looking at, look at the candidate space you're looking at, like with respect to the user who's asked you this question. And just give it a second thought as to how you come up with a recommendation so that tomorrow when you are faced with the same question as to how you can increase the user engagement in your product, how do you recommend something for your users, you can use, or something new might strike you that I will probably be giving a presentation about in the next 10 years. And to help you out in this task, I have a friend called Sharath who is currently there taking video of me like a useless fellow. Please put his face. I want to see his face at least. Last slide. Anyone? Okay, Sharath, just get up, da. Get up. It's okay, get up. I want to take your photo. Yeah. So during the networking phase, I highly recommend all of you go strike a conversation with him. Ask him what he likes, ask him what he dislikes. And ask him for a recommendation or give him a recommendation. Because he's going to have a pretty boring weekend after this. So please do recommend items, actions, things he can do to make his weekend a lot more interesting. So that at least we can try to use what you guys just saw in the last 9 minutes, hopefully. And I did not know I went way over time. Yeah, sorry guys. Thank you. That's been my time. My name is Anand Sathwik. Have a great day. Bye-bye.
Yeah, that was a really good presentation, Sathwik, even though the presentation wasn't there. But that was a really good one. Like, he made it really, interesting, even though with the blinking slides. So next up we have Karthikeyan. So he's going to talk about a really interesting tech. I remember, talking about this very long back. How many of you know WebRTC? How many of you use Zoom, like Google Meet sort of thing? So that runs on WebRTC. So he's going to talk about WebRTC. Maybe at the end of the session, you might build something on your own for, video chats. So over to you, Karthikeyan. Thank you.
Hey guys, I'm Karthikeyan. I'm a developer advocate at 100ms, and this is actually like the first time I'm speaking in front of a developer audience, and this is actually the first time I'm even attending a developer conference. So yeah, I'm going to talk about video calls demystified, a peek into WebRTC. So I'm pretty sure you've used some of these apps, and I'm pretty sure you're familiar with the one in the middle. If you take video conferencing out of these apps, you have to just throw it away. Like half of these apps, they're totally all they do is just video conferencing, right? Google Meet, Skype, Zoom. So from this pandemic, what happened was everyone had to work remotely, and we had to meeting to dating, everything went online, right? So we had to move over to video conferencing. So let's talk about that. According to a survey from CCNP and Newswire, video conferencing market is projected to hit $13.82 billion by 2023, which is just 2 months away. Okay? So that's how significant this market is right now. So let's talk about WebRTC. WebRTC is actually framework, open specification, which powers real-time capabilities. You can add anything video, audio, anything to your app with WebRTC. So it actually started out as a browser API. So once upon a time, you would you will be able to add WebRTC was just a JS API that you could call from browsers. But after a time, everyone started writing their own implementation of WebRTC that it's available on almost every platform now. Let it be Android, iOS, anything. And even Golang, Rust, Rust is actually they have this WebRTC implementation in beta stage, I guess. So let's talk about how it works. Okay, so the first step is signaling. So signaling is the only thing WebRTC needs to make the connection successful. Once you do signaling, WebRTC can handle everything. We'll talk about this on the the next slides. So first, signaling is it's used to set up, control, and terminate a WebRTC call. So what we do in signaling is we basically transfer some data that WebRTC needs to actually establish a connection. So there are two important kind of data. One is how do we communicate? Sorry, what do we communicate? What is in the sense video? The specification of the video 720 pixels, 1080 pixels, and the codec. And then if it's an audio, the codec. You'll just communicate that. And how do we communicate? The actual your IP address, the network path you're trying to communicate. And WebRTC doesn't actually specify how you should signal it. You should just make sure these the people who are to join the call should have these data. So like the most obvious choice is WebSocket. So like in production, most of the people, they use WebSocket to signal. Okay, let's see an example. So this is a typical one-to-one video call. Let's say this is a WhatsApp call. This guy, let's say he's calling this girl. So he's making a call. Whatever happens in the middle, it actually happens from the signaling server. So first he sends an offer SDP. The offer SDP contains these details I said, right? Like he'll say, I'm going to send a video. This is going to be like 720 pixels, something like that, this VP8 codec. And then, she'll be like accepting it. Once she accepts, she'll send an answer SDP. Okay, I'll be sending this audio with this codec and blah, 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 and that. Then once they are they agree what they're going to send each other, either one of them can send the ICE candidates. ICE candidates are essentially used to find the best optimal path so that they both can connect. So actually ICE candidate will be like the first, one ICE candidate will be sent along with the offer and answer SDP. So after that, the first initial connection will happen, and after that, you'll just send ICE candidates again and again and again. You check the connectivity, you'll find which is the most optimal path, and then a connection is established. Once the connection is established, you won't actually need a signaling server in theory, but we'll definitely need it. I'll come to that. So, yeah. So I said the most optimal path, right? So it's not that simple. So in WebRTC, there's actually, you can think of it like there are three ways to connect to people. The first one is a direct connection. So let's say like peer A and peer B, both are in the same local network. It's easy to just connect them directly. But when they're like on different networks, when they're behind different routers, they actually can't see their own private IPs. Let's say like you just go open your laptop, connect it to a Wi-Fi, and you see you just see what your IP address is. You'll see something like 192 dot something, and then you Google what's my IP. You'll get a different IP address, right? So you just try it after this, maybe if you have time. So what happens is when you're behind a router, there's this thing called NAT, network address traversal. So sorry, translation. So what it does is it basically maps a private IP, like a public IP, to a set of private IPs within its local network. So when you're connected to a router, what you actually know is your own private IP, which is basically useless outside the router. So you can't actually connect with anyone outside your router when you don't know what's your address like outside of it, right? So that's where stun comes in. When this direct connection is not possible, you'll call stun, and it's a simple server. What it basically does is you ask for give me my IP address, and it will give you your IP address. So once you have this IP address, you can try a direct connection again. So this is the second way to connect. But let's say there are some type of NATs that don't allow you to connect. There's this type called symmetric NAT. So you can't actually connect even when you use a stun server. And also there are some firewalls that actually block direct peer-to-peer connections. So when that's the case, you'll have to go to turn server. So the ICE candidates, what they do is they find, even when it's a direct connection, they'll find like 4 to 5 routes of direct connection. They'll try out all that, find the optimal path. And with, when the direct connection is not possible, it'll try with a stun server. When that's not possible, it'll try with the turn server. So this is actually how two people can actually connect. So yeah, so that's it. If you talking about one-to-one calls, that's the basic stuff that you have to know. But when we're going beyond two people, when it's not just a video call, it's a video conference, we'll have to scale, right? So there are 3 common patterns when it comes to video conferences, the architectures. Okay, so the first one is mesh architecture. So what we do typically is we connect everyone with everyone else. Let's say there are 4 peers, right? So this guy is connected to all these 3 peers. He sends out video to these 3 peers, and he receives video from all the 3. This happens with all the peers, and this is the mesh architecture. So what's good about this architecture is it's cheap. You don't have to have a central media server in between. It's cheap, simple to do it. But when the number goes above 4, the actual device can't handle it. When you're using a phone and it's a mesh architecture, and there are more than 5 people on the call, you will be sending 5 videos. You will be sending out 5 videos outbound and 5 videos inbound, right? So when you're doing that, maybe your phone could explode. Yeah, something like that. So the next one is mixing architecture. So this is actually pretty old. It's not used nowadays. So this was the one that replaced mesh architecture I don't know, like a decade back or something. So there's this media server called MCU. So what it does is you just send one video, like all the people, they're not connected to each other. Instead, they're connected to a media server, central media server called MCU. They send their videos to the media server, and what this does is it receives those, let's just talk video. Let's say this media server, it receives all those packets. It processes the video. It will make, it has a template in which it will fit in all those videos and then send them out to all other people as a single packet. So that it look like you're sending one video, receiving one video. This also looks good because, the load on the device is minimized. But the thing is, there's a cost factor. This server, it has a lot of work to do. It has to process a lot of video continuously. So it has a very big cost factor. And also, it also comes with a lot of latency, which is not ideal for a video conferencing solution. So what replaced this was this architecture, the one with SFU. So this is called routing architecture. What it does is, actually this is what's currently used in most of the WebRTC based solutions. What it does is, you send one video, it'll just, that SFU, that media server, what it'll do is, it'll forward your video to all the 3 peers. See, the red one, it's sending to the SFU, sending that red 3, not that. And then the same happens with all those 4. And in the end, what you do is, you send one video, you receive n-1 video. So, and also you can do a lot of optimizations with this. Let's say you want to, what Zoom does is, let's say there are 100 people on the call. When there are when you're only seeing 10 people on the screen, you don't have to receive the other 90 people's video, right? So you can just tell the SFU to just specifically send those 10 people's video, and it can easily do that without any more added complications or anything else. So this is about, these are the 3 architectures that are currently used. So if you guys got any questions. Okay, thank you guys.
Actually, Karthik, I have a question. Karthik, I have a question. So how expensive is it to run the, video conference sort of infrastructure? Because I back in COVID days, I used to, when everyone was building, Zoom sort of thing, I was trying it out. I built something called Kuti Sover. So where bunch of people can come online and then. So as you said, whenever there were the 5th person enters the room, it crashes. So that's when I read about, and then I found the sun and turn servers and all this stuff. But how really expensive? If someone wants to build a video chat or have a video chat capability in their apps, I have seen people build fitness apps and stuff like that, where they want to collaboratively do it. How expensive would it be, or is there any solution that they can use to build it quickly?
Yeah, so actually, if you're building a video conferencing solution from scratch, you'd have to have a whole team dedicated to it. So there's that expense, and then you should have a turn server in place. Even with those mesh SFU routing and all these 3 architectures, they have these standard turn servers in place. Because when you can't connect to the media server, you have to use that. So other than that, if your call has more than 4 people, of course you have to go to SFU. And then there's that. And also, other than all these basic cost, you'd have to optimize the video endlessly. There's this project called Peon in Golang. So I read one of the blogs that this guy wrote, someone who's like contributing to Peon. So he said it's actually easy to start building an SFU. Like the more, the video optimizations all happen in the SFU, right? Like the processing the video, like you're sending it out. And what happens is after a point, the more and more work you do, you can't really stop, you can't stop optimizing. You have to like keep optimizing it again and again. So there's this endless, game of optimization that you have to do it. And actually there are like SDKs available. So the one, the 100 ms that I'm working for, they have this live video SDK that you can easily integrate. You don't have to worry about whatever I spoke today if you just check out 100 ms. So what we offer is we offer SDK that 100 ms internally, they handle all these complications. So you just go and download the SDK, whatever may be the platform. Maybe like it's a web, just do npm install, and then you have these specific API functions. Just call .join, and you can join a call.
Basically, you handle the SFU source. And then we have just used to use the clients alone. We build the clients alone.
Yeah. So we have the platform. You just have to use it. That's it. Like you don't have to worry about maintaining the servers, optimizing anything else.
And what about the encryption sort of thing, like the DRMs and stuff like that? Do WebRTC offers those things as well? Like if I want to do a protected session, right? Like between you and me, I don't want anyone in the middle, or you to be downloading it, or I should not copy it, or basically a DRM sort of thing. Do they have some such supports as well in WebRTC?
So actually, WebRTC is secure by default. So actually, it depends on who do you add to your session. So it depends. If there's a problem in signaling, you can practically add anyone into the call. Right? There was this issue with Zoom. Anyone could just join the call. Yeah. So that was the problem with the signaling. So they were just able to find the meeting number and join in. Right? So if you're adding something like 100 ms to your app, it's if you don't if you don't make any mistake, there won't be any security issue. Yeah. Thank you guys.
Perfect. Thank you so much, Karthik. And next up we have a talk on something called Web3. How many of you use Web3? Bought NFTs? Or I think these are the quickest questions. So probably I'll leave the stage to him. And okay. So basically, I'm not a big fan of Web3. So I think the questions will be directed towards me.
Hello guys. Yeah. So yeah, myself Ramachandran. You guys can call me Ram. Yeah. Thank you. All the SRM peeps and friends. Thank you. Okay. So I'm from SRM IST. I'm a student. I'm doing my third year. I am a co-founder of DevDAO as well. So it's a community. How many people here know about Web3, blockchain, anything related to Web3 and blockchain? I know Varun Anna is there. Varun Anna is more like a Web3 hater, so I'll have a talk with you. So, okay, thank you. Okay, cool. So, more on Web3. So who and all are doing web development in Web3? Like, are you there inside? Are you doing something? Are you building on Web3? Hi Kailash, yeah. Anyone else? Yeah, what are you building? Like, what are you planning to do? Or any ideas? Just ideas. Do you have any ideas on building? And if so, what are they? Silence, auto silence. Okay. Cool. I will get to the interactive session more then. Okay. Blockchain, specifically saying Web3. Web3 is a new web generation that promises more decentralization and more security over using the technology called blockchain. So blockchain is where we use hash codes, where you do not have to have these security issues due to centralization. More now, we have centralized data sets, like wherever you go, all your data is more centralized, where it's in a particular amount of servers, and if that goes down, everything is gone. So basically, in blockchain, what we do is, it's more decentralized. All your data is kept in different parts of nodes, so that it's not staying up in one particular centralized location. Moving on. Why blockchain? How blockchain is working? Right now, it has a great traction around the world. Seeing that it has this tremendous increase, tremendous innovation and value creation, companies are coming up, major companies are taking up this blockchain technology and putting forward a team to build on it. Why and how much market value does it have? Right now, about a market size about 4.8 billion, but it is estimated to go around 69 billion for a market price on 2030. So how is this sudden growth, and why is this such tremendous support? How many of you here know NFTs, know crypto? Have you invested? Yeah, crypto. Hey, hello. What you guys have you invested in? Like, and what crypto? Huh? 50% of your portfolio is down. True, FTX is going down. I'm sorry about that. Even Solana is going down. Going on to the problems. So the problems faced, as he said, 50% of his portfolio is going down. That is where major problems come, like some security issue, some of the other issue keeps coming up. And that might be a reason, sometimes this hacking thing is very popular in Web3 world. You get easily hacked, easily you'll get, lots of fraud goes on. That's why we have this Web3 hater called Varun Raj. Our GD of, what? No? Okay, cool. He's like, no, don't talk about me. Right. So he's our Web3 hater, no? He's been saying, one question he asks me every day, he's like, what is the use case of blockchain? Just crypto? I'm like, there are use cases, but it's not a use case, but they are building towards this. Now, right now, you don't say quantum mechanics, you can imply everywhere, no? Quantum mechanics, do you imply everywhere? We are finding, no? Huh? Farm to store tracking, as in, sir?
For example, to tell about the authenticity of the product, nowadays we are worried, right, where this product is being manufactured. Something like coffee bean to a table. Okay, in the packet it will be written like fresh and directly from mountains, right? Basically, it may not be from there. So blockchain helps us to track this product, whether it is really the origin is the particular place and how many distributors it goes around, and finally when it reaches a store, is it the same accurate product? So it helps to track farm to store type of.
That's an amazing use case. Where is Varun on? Please have that as your answer, one of your use cases. So yeah, as he said, it's those simple things where you can use from the basics, to track where and all it has been, as he said, farm to house, what that been, where is it starting from, and where is it going. What are the basic problems we face in Web3? What are the main problems we face in blockchain? So what we see here is scalability, security, and sustainability. How does Google GCP help you there? So more on the solutions, like what does it provide? What does GCP provide? So more on solutions. So the first one, as you say, is instant scalability with demand, protect digital assets and end-to-end, and go to market faster. Let me get on the specifics. Why do people choose GCP? Because of these solutions as well. So first solution tool called Google Cloud Spanner, where Cloud Spanner basically, does this for you. You do not have to think about it and just think on building your business. Next up, we have protect digital assets end-to-end. And again, 3 reasons for that. Submit and authorize digital assets and transactions. So basically by using, you take care of your digital assets. And in blockchain, it is a very important topic saying that you need to protect, you need to have a security. So on that fact, what will we do? How will we authorize digital assets and transactions? Or the fact is where you use Google Cloud Keys. We have this key management systems where it will help you protect and save more. Going on to the next reason is keep signatures and data encrypted while in use. So while you're using, you can use encrypted VMs as well as key management systems, which will help you save your keys, key data, whatever security you need for the key will be there. Third is where you go for reduced attack surface, where you'll be using optimized OS specifically for your container, where it will reduce your footprint, carbon footprint, as well as it will also increase your security, where you do not have any space for attack. Going ahead, go to market faster by simplifying node deployment. We'll get to that. Simplifying node deployment, why I'm saying we'll get to that is because we have a separate team of people working for that. GCP has separate team of people working for node deployment because they are trying to present something where you'll do one-click deployment where you do not have to go and build for a long time. It's going to be just one click and you'll be deploying your node. Second reason is build faster with industry-leading containers. Yes. So our containers, when you're building, you need to manage them, deploy them, and take care of them. You'll be changing them. So by using Google Cloud's tools, it's going to be much faster and cleaner. Cleaner, operate in the clean. So if you know about blockchain, one of the major disadvantages are where it creates huge carbon footprint. If you go to Ethereum or any other chains, you'll be like, it creates one of the main disadvantages is carbon footprint. So to reduce that as well, to bring more, reduce the amount of carbon footprint in blockchain technology, GCP is moving forward, creating solutions to that as well. Why, as I said, node deployment. So Google Cloud launched new dedicated digital assets team where they'll be helping you with mainly these 3 points. So providing dedicated node hosting called remote procedural call nodes for deployers, allowing users to deploy blockchain validators on Google Cloud via a single click. It is a major point because they have a blockchain node machine where you do not have to sit and do procedures one by one. It's going to be like click on, your node is deployed. That's how simple it's going to be. That's what GCP is trying to do, and that is what GCP is trying to provide. Participating in node validation and on-chain governance with select partners. Okay, that was one of the reasons why I took this talk. Okay, so recently Google Cloud put out a tweet saying that it's being a validator on Solana. So how many of you guys saw that? Saying it's being a validator on Solana? I am seeing one person constantly saying yes. Okay, I see Web3 peeps are less sure, but yeah, soon you'll be knowing more about blockchain because it's growing exponentially and it has a market too. Third is helping developers and users host their nodes on the cleanest cloud. As I said, GCP is more towards providing more cleaner and safer place where instead of having a carbon footprint, reduce it to the minimal amount. And with that, I'll be saying thank you, and thank you guys. If you have any questions, you can meet me, I guess. With that, my time is up. Yeah, Varun. Varun, I'm scared to take questions from Varun. So this person has been with me for past, 6 months now. I've been friends with him. I've known, he's a part of GDG, so GDG Chennai events, you can see me. So basically, he's been asking questions. No, it's good. It's good to have questions. You get more tendency to search, learn more. But still, no, he's a kind of person like, no, I don't like Web3. I will not even try it. I have tried it for 2 years, no more.
It's not that I don't like Web3. I wish Web3 was much better.
As in? Make it be more specific, no?
Okay, this was copied from Kamal Hassan, so anyways. No, I just wish Web3 was much better.
As in?
Much better generally.
Wonderful. Yes, sir. So now they are actually supporting various other ledger companies like there's Hedera, there's various other companies which they are supporting, and they're building on top, as in on top of Google Cloud itself they are building. So right now they are focusing on ledgers as well. The digital assets team is mainly for the ledger companies like Hedera and all, because they think Google Cloud can provide more security, and that is one of the main purposes they use Google Cloud. Because now identity aware proxy, Google Cloud Spanner, or these tools attract the blockchain companies because they think these tools reduce about 30% of their expenditure in running databases alone. So Google Cloud Spanner and identity proxy alone help them reduce 30% expenditure. So they are like, yes, probably this is one point where we'll have to think more on what we are using, and that's why they are jumping onto GCP.
Hey, hi.
Yeah?
I'm very much interested in knowing about Web3. So if I want to do any project now, what should I get started with?
Project, it's based on what you want to do, like what kind of projects you want to do.
So anything kind of NFTs?
So NFTs, okay. Coming to NFTs, okay. So right now, not the right time for going to NFTs, but still, if you do like to go to NFTs, right now you go on based on a project. So you have a project and then build NFTs on top of it, right? Like to give NFTs. So once you have enough, enough support for your company, or enough support for your project, then I would say go for the. No, I have my DAO. We founded a DAO along with few of my students. We were like, we should do tokens, we should do NFTs. But we were like, let's take some time, let's build on projects, because that is more important at this point of time, rather than directly jumping on tokens and NFTs.
One more question.
Yeah.
When will be the market back?
Huh?
When will be the market back?
I don't have an answer for that, but I hopefully we come out of the bear market.
Thank you.
Thank you, ma'am.
Thank you so much, Ram.
Thank you, guys.
So I think we are almost, in the end of the conference. But we'll have a short break. After that, we have some, activities and some small talks. So we'll break for next probably 30 minutes. So the tea and coffee is served outside, similarly to the morning. And we'll be back here. All right. Thank you, guys.
So, hi guys. Sorry that you had to hear one last pep talk. So, this is the last pep talk we're going to hear.
Why is Daddy at the time massage? Daddy at the time massage. Why is Daddy very fake mustache? Daddy very fake mustache. Now why is Daddy at the time massage? Daddy at the time massage. Why is Daddy very fake mustache? Daddy very fake mustache. Why is Daddy at the time massage? Daddy at the time massage. Why is Daddy very fake mustache? Daddy very fake mustache. Bring the beat back. ये वाटके करंट मुगल वासन ताकि पाले पुल्ले कोटी स्कूल फीस नन नमन न रवलेश कमाइल पर चरसी गोद में पतला कासी కొంచెం కూడా పతలిగే వరనారంటన్న ఏ ఉండి ఎలా వటచి ఏ నాలన్న ఎట్టన్న కరణ ఉడన వాంగి ఏ వరనారంటన్న ఉండి ఎలా వటచి నాలన్న ఎట్టన్న కరణ ఉడన వాంగి అండ గుండ అడ్డకు వెచ్చు అది కొంచెం ఎడుకు పతల ஞானப்பயமே நீ செவ்வாதோ ஞானப்பயமே நீ செவ்வாதோ ஞானப்பயமே Call me in the morning, I'll be on my way. Call me when you want, call me when you need. Call me in the morning, I'll be on my way. Comedy, come. So this one is a rap that he wrote about us. So let's go for it. முதலில் எல்லாருக்கும் வணக்கம் fabulous fantasy தமிழ் தாய் வணக்கம் எங்கள் பேரு எக்ஸசி 20 வயசு பசங்க தான் நாங்க கல்வி தோத்து காதல் தோத்து இருக்கிறது எங்க அசிங்கம் அவமானம் கேவலம் பார்த்தாச்சு தண்ட சோறு வெயில் மாட்டி தோட்டாலி கெட்டாச்சு நம்பிக்கை போயாச்சு கனவுகள் பாழாச்சு இரவு நீட கேட்ட சின்ன ஆசைகள் வீணாச்சு கடைசியில் கை கொடுத்தது ஒன்னே ஒன்று இந்த ராப்பு நாடே அளவும் ஒன்னே ஒன்று இசையை தேர்ந்தெடுத்தது எங்கள் கண் பொத்திட்டுடா ஃபாஸ்ட் ஃப்ளோ பொத்தின்னு மச்சா ஸ்டிங்கு ட்ரம்ஸ் கீச வச்சு கிழிக்கிறது எங்க ஸ்டைலு ராப்பு கனவில் குத்த நடிச்சு காய வைக்கல நாங்கரி மொத்தத்தில் நாங்க ஃபெயிலு பிரச்சனை வேணாம் புதிஞ்சு கடைசியில் அடிப்போண்டா லெஃப்ட் ரைட் ஆலிஸ் GDG ஈவெண்ட்டில் பெர்ஃபார்மன்ஸ் பாரு நீ ஸ்கூல் எல்லாம் முடிஞ்சிருச்சு காலேஜுக்கு வாணி காலேஜ் ஸ்கூல்ல கால் எடுத்து வச்சா சவுண்டு தெரிக்கும் பேசு சத்தம் கேட்கும் போது காது காது காதுக்குள்ள முதல்ல எல்லாருக்கும் வணக்கம் நாங்க சைட் டோர் திறப்போம் தரந்த பட்டைய கிழிச்சு நாங்க தண்ட பாலத்துல படிப்போம் போட்டி காஞ்சி காத்து கடக்கும் மாட்டி வீட்டுல கோக்கிலா இந்த வீட்டு சத்தம் கேட்டு காத்து ரெண்டுக்குள்ள காப்பி எந்த போட்டியா பெட்ட மெர்ல உண்டு பாஸ் ஆக தெரிக்க உண்டு வீட்டை பிரெட் ஆகி பேச கொஞ்சம் பெரட்டி விடு GDG பர்ஃபார்மன்ஸ்ல 10 நிமிஷம் சொன்னீங்க வீட்டு கொடுக்கறது சித்தாஜரின் புள்ளிங்கோன்னா உங்க எஸ்ட் போடு தமிழ்நாட்டு ஸ்டைல் வச்சுக்கிற நாங்க எக்ஸ் வெயிட் எங்க அப்பா பிசி பயிர் புல்லு டென்சிட்டி நாங்க காப்பு எடுக்கும் நேரத்துல நல்லா யோசினி ஏன்னா GDG வந்தாச்சு மச்சான் சூர மாட்டி தபாலி
So, we are Ecstasy Beatbox crew from SSN College of Engineering. We are doing our third year in SSN. So, this is Siddharth Shankar on my right. This is Jaren Reshmon. And myself, Sanjit Ganesh. Hope you'll like the performance.
Thank you so much.
Great job.
அவங்கள கேளுங்க கொஞ்சம். இல்லை ஸ்க்ரீன் ஷேரிங் மெயில் ஷேர் பண்ணிடுறோம். நீங்கள் வேறு லேப்டாப் ஓகே.
ஷேர் பண்ணிடுறேன், ஸ்லைட் ஷேர் பண்ணிடுறேன்.
Hello, check. Hello. Yeah, guys. So now we'll have a quiz. There are two quizzes going to be. One is connections. How many of you know connections? Can I have the attention? Okay. So it's going to be tech connections. Will be managed by the team. And then the quiz. I think first we are doing with the quiz. So there'll be a link to join. So just note it. I think there'll be a minute timer when you can join and then place the quiz. Similar to how, right? We're just setting it up. All good? All good?
Who? If you didn't get internet, get from your friend's hotspot. Who has good internet?
Guys, there is a small change due to connectivity issues. So we'll ask you questions directly. Okay. So I know. So the rules have changed. Okay, whoever answers most question will get a prize. Okay. Uh, and you guys only should raise your hands, not shout. Okay. If you shout the answers, we won't do any justice. Okay. It's hard for you as well as me. So please raise your hand, and whoever answers more questions will be awarded. Okay. Wow. So we'll start asking you questions directly. Okay, I have a first question. This is the first question, okay? Only you should raise hands. This is a pretty easy question. Which company found React? Okay, how do I find who raised the hands first? Okay. Okay, it's actually easy. I'll just tell the answer. It's Meta or Facebook. Okay, so we'll go to the next one. Okay. This is going to be kind of hard. What is Neo4j.s? Okay, I'm considering you, but you didn't raise your hand, but fine. Okay, I'll consider this time. Yeah?
Graph database. Graph database.
Yeah, it's the right answer. Okay. How often should you change your password according to NIST? Four months. No, that's the wrong answer. 90 days. No, that's the wrong answer. Wrong. Okay, that is the right answer. 1 year. Okay. Next one. One. Okay, this is a kind of good questions. Google-based product technology. So, which is Google's machine learning tool? I didn't ask the answer. You just need to raise your hands. Okay, we'll go again. Which is Google's machine learning tool? No. Okay, the answer is actually wrong. We'll just do again. Raise your hands first. Come on. Okay, who should I choose? Answer louder. Yeah. Someone told teachable machine. Okay, that is the answer actually. Yeah. Good. Okay, what is Astro Island? Does anyone know?
Static web application.
Is it right? Hari? Static web application. Yeah, okay, cool. Then,
Who's the author of Developers Road Ahead?
okay, this is kind of be hard. Who is the author of Developers Road Ahead? Okay, I give it to her like 2 points. Okay, 2 points you and 2 points that guy.
So I would request that, ma'am, please stand up. And blue guy. So one on was one battle. Last question, who answers, get clock. Okay? Which is not a inbuilt data structure in Flutter? Can I give options? Can I give options? So option 1 set, option 2 map, option 3 queue map, option 4 linked hash set.
Q map. Q map.
So she is correct. See, on the spot we are giving GCP clock. by our organizer. Make some noise. Yeah.
Okay, guys, this is not it. So we have another game. So I'll hand it over to Hema Akka for the next game.
Every time someone answers, call them to the stage, and then final answer.
Hello guys, good evening. How was your day at DevFest? Can I expect some more sound, please? Okay, so as the follow, so okay, listen, please. Like let us, divide the entire group into 4. Okay, so this will be the first half. Okay, left half and the right half. So this can be the team A, or you can give some fancy team names you want. Something. So this will be the team A. So decide on a name first. So that end will be team B, team C, and that end will be team D. Huh.
Guys, one kind request. My friend Elon Musk wants to know what's happening here. So take up whatever pics you are taking, just put it on Twitter and tag all our GDG accounts and GDC, Google Cloud and WTM on all sister communities.
Okay, can you have some team names, or let's go with ABCD? Yours is Alpha Beta. Here. Metaverse. Okay, Metaverse, that end. We can't hear you. Can you be louder? Huh?
Wakanda.
You say Wakanda here. Wakanda forever. Okay, all right. That end.
Pitaka Pidru Gopal.
What was it? Okay, so this is going to be Metaverse. That is Wakanda forever. Alpha Beta. That one?
Something Gopal.
Okay, let's go with that. Okay, for the next coming up clues, anyone, you have to stand up or you can even jump. Raise 2 of your hands because it's very difficult for us to hear who said it first. So, from which group who does that first, we'll take their answer only as the final one. All right? Tech questions, like it'll be pretty much easier. So, do it as fast as possible. Okay? Five, 4, 3. Right, okay, he got it. Huh? The person who answers, no, you can come front. You can come front. So this is basically artificial intelligence. Okay, does this picture do justice to the term? Yes? Okay, thank God. Okay, now we can go to the next one. This is very easy. See. Everybody did it. You have to stand up or jump from your place. Raise both of your hands. So that person did it first. You can come front. Okay, you can go. Next option. Okay, I can give you a hint. You have to think in other language as well, but it's a common known one only. The last picture alone. Close.
Much more closer.
It's kind of closer. Like everybody is close, very close. You know what happens in the first picture if you find out that's the first word? I mean, this is one first word. Right. You can come front. So it's a social gathering, right? So it's social, me and Dia. Right. Going to the next one. This is very easy. Okay, this is very easy. No, we'll leave this off. Okay. It's very easy, so we'll leave this off. Okay, next one. Okay, so to give a hint, the first word it's there in the first picture itself. Because I couldn't find a better picture for that, so... Okay, they told it right. Sorry? Okay guys, now we have seen a lot of tech terms. So next up we have 10 questions that will be non-technical. Can be series, movies, or something that is trending. Okay, to our knowledge we have taken terms, so you can guess that, okay? Hey, Kani? Huh? That is not Lord of Rings, okay? That's another picture. It's a movie. It's a very old movie. But if you find the last two words, you can get the... it's the name of the person. Yeah. It's Alexander Graham Bell. Okay, so the next question, it's thrown only to that group and the other group, okay? So, first two teams, please don't answer. We expect answers from those two teams as well. Okay, next one. This is also a movie.
Pirates of the Caribbean.
Okay, that guy, huh? Yeah, okay, come friend. Okay, next one. I can give clue, this is a programming language.
Fortran.
Green t-shirt, okay. Silent. Guys, we expect answer from those two teams as well. So, please do participate. Next one. This is actually a movie. I'm not sure if people might... Yeah, okay, done.
So guys, we are planning to take it as two phases. First phase is for team 1 and team 2. It is already over. Now is second phase from team C and team C. So first team and second team, please be calm. So now it's turn for Team C and Team D. Guys, please support us. Make answers louder. And jump. Jump.
Guys, we expect participation from all. Okay, so that is the main. Okay, we have got a nice tip from our organizer. If these people answer, we have to minus points. So negative points for these two teams, okay? Okay, next one.
Death Note.
You have the next clue up here. No. I think it's a company's name. It was founded by Jeff Bezos.
Blue Origin.
Blue Origin, the red t-shirt. Yeah, you're right. Next one. White shirt.
Eiffel Tower.
Yeah, it's Eiffel Tower. Next one. I mean, if you are one of the 90s kids or you know the answer, to give hints, it's like, I think it's a cartoon character. That black t-shirt. Hey, that. Next clue. Please do stand up or jump or raise two of your hands, only then we'll know. No, it's also a wrong answer, so. I can give a clue, but it'll be very easy.
Dennis Ritchie.
Yeah, right. It's Dennis Ritchie. This is also very similar. If you know the first person, it'll be very easy. Answer is right, but who told it first?
Tim Cook. Tim Cook. Tim Cook.
Okay, that one. Please don't. See, these two teams, if you say, obviously points will be minus. Though the answer is right, we expect it to come from the other
Peaky
two
Blinder.
teams. Okay, right. Next.
Peaky Blinder, I did.
Okay,
I don't know if someone else said from there.
Okay, so next is the last picture. So we have people who told the answers, no, it's for you only. To get the final swag, we will portray. Okay, if you want, you can come over to the stage as well. Please come over to the stage. We have one final clue. Who says that you will be getting the swag? Come over to the stage. Stand in one side, okay. Either left or right, so you can see the clue. You have only one clue, so please don't answer. Please don't answer. Just raise your hands. If it's right, we'll give the swag. If you answer, you're out of the game. Okay. Okay, everybody should see as well. Oh yeah, the black girl. Sure, you can come. All right, can we go for the last clue? Just raise the hands, please don't answer. Audience, please don't prompt. Clue. This is the last level, no? So no clue. If you find it very difficult, maybe I can give you a clue. Audience, please don't answer. Though I heard the right answer, please don't. Please don't prompt. If they don't know, maybe. Right. Okay, he gets it because the answer is micro max.
So for these guys, please wait. There is one more gift for these guys. I will ask one question. Answer that. Who follows GDG? Who follows GDG properly can get this answer. So he is a personality who is the starting organizer of GDG, and now he is even a founder of one startup.
Thank you guys. I hope you liked all the events. Yes? Yes? Okay, next step, I think we have the keynote to be delivered.
Some t-shirts. So they need a mic. So it's completely matter of luck and some of our biases as well. But okay, so we're going to do it in phases. I'm going to throw in the shorter distance. Probably he's going to throw in the middle, and Soma is going to throw in the last. Okay? Okay. For better experience, I'll just close my eyes or I'll just throw from the back. Soma is doing that. Yeah. Okay. Sorry, that was not my aim though. All right. Okay. Nice. So we're making it concert sort of a vibe. What was that, man? Okay, you will directly start? Okay.
Cool. Awesome. A moment of silence. No, I said silence. Whenever I asked you to scream, you guys don't scream. When I say silence, you scream. Okay, cool. I thought of asking you to scream later, but okay. Cool. So, day one is about to end, sadly, but day two will happen tomorrow. So, I thought... Okay, cool. So, I thought I'll just pitch in and, deliver the closing note. So let me try to do it formally because I've been thinking to do this for a long time. So let's try. As we have approached the end of the session, I'd like to thank all of you for being here, patiently listening through all of the talks. I appreciate everybody for being here despite the weather condition that is in Chennai right now. I know people have traveled from multiple cities outside Chennai to be here. Although knowing that it's raining, but you made it here. We are so grateful to you guys. We thought we'd not get this much crowd, but you made it. Appreciate you guys, and I want all of you to do a huge shout out for yourself. I don't know if this is huge, but for me this is huge. Including both the days, we had 3,000 plus registrations, out of which we were able to send invite for 700 plus people. And I think we have got a pretty good audience today, don't we? All of this DevFest would not have happened if not for the GDG Chennai organizing team, the DevFest organizing team. So I'd like to have the team on the stage, please. All the volunteers and organizers for DevFest Chennai on the stage. All volunteers for DevFest Chennai, please assemble. Avengers, assemble!
Mention the website.
Batman is here.
Cool. This is not it. There are few more still working in the background, but to the entire organizing committee of DevFest Chennai, GDG Chennai, you guys did a splendid work. This was amazing. Two months is what we had, and we pulled off this. These people pulled it off, right? So, thanks to everybody. Let's hope that this continues forever, right? That's day two as well, of course. So before continuing on, we'll take a small picture together, shall we? Abhishek. All the speakers available here, you can also join us, please. We'll take selfies, no? We'll take selfies. We'll do. Take a selfie.
I'll take.
Yeah.
Who's taking selfie?
Let's face the audience. Let's, kind of do it. Everybody scream DevFest! I want to hear you guys. DevFest! DevFest! That's it. I need the deck மட்டும் எனக்கு கொஞ்சம் ரைட்டா கேப் கொஞ்சம் டெக்குக்கு I want the deck ask him to move.
தெரிஞ்சா ஒரு செல்ஃபி வீடியோ எல்லாரும் கத்துற மாதிரி ரீல்ஸ் பண்ணுவாங்க
செல்ஃபில என் மண்டை மட்டும் தான தெரியுது
சீக்கிரம் கண்டினியூ பண்ணி முடிச்சோம்
ஓகே I think I'm not done yet, so I'm going to take a picture for myself. So sorry, guys, but I'm going to do this. Everybody scream, DevFest Chennai!
Nice.
Cool. Enough of the screamings. Before that, we have to thank a couple of people, right? Shall we? DevFest Chennai, not just the organizers and the volunteers, it also is possible because of the amazing community partners and sponsors. So GDG Cloud Chennai, TensorFlow User Group Chennai, WTM Chennai, GDSC SRM and GDSC Hindustan helped us. So thank you guys. I'd also like to take this moment to thank our sponsors, Evoltech, who has sponsored us, one of the event sponsors, and they're also hiring. We have spoken about it. And I'd like to also thank Moreficient, who was another event sponsor. I'd also like to thank Yugabyte for sponsoring some of the swags for us. And finally, I'd also like to personally thank Karthikeyan for giving away some of the books developers wrote ahead. And obviously, thanks to Google developers, right? Thanks for supporting us for DevFest Chennai. So, what next? Before that, what next? We'll see you tomorrow at day 2. Some of you have registered for day 2, so we'll see you guys there, right? So tomorrow, day 2 is happening at Infosys, Shuling and Allur. So we'll see you there. We have a couple of workshops happening. So those who have registered, we'll meet you there. And we'll have a couple of announcements that will follow. Before closing off, all the pictures that you've taken, all the videos, all the beautiful memories, please share them on social media. Use the hashtags DevFest Chennai, GDG India DevFest 22. Tag us GDG Chennai, WTM Chennai, GDG Cloud Chennai, TFUG Chennai, Google DevSin. So, coming to the close, we have
Hope you all had an exciting day of learning about Google technologies from experts and were able to reconnect with the developer community in person after 2 years. It is you, the developer community, that makes the DevFest season magic. It is your involvement that ensures more and more developers to be able to find a way to meet, connect, and learn from each other.
I'm short of words expressing how glad I am seeing all of you at in-person DevFest this year and all those who are watching us live on YouTube. The organizers and the community contributors have put in a lot of efforts in hosting the in-person DevFest this year. Let's continue the momentum to next year and keep it going.
We have been able to reach a more diverse audience this DevFest with innovative and inclusive tracks. We are on our way to break barriers and glass ceilings together. Let's continue this momentum on to the next year as well. Lastly, join me in congratulating the GDG and WTM organizers and everybody who contributed in putting together this wonderful DevFest event in your city.
என்னப்பா வாங்க போம்மா என்னடா போச்சு விட்டாங்களா என்னப்பா போம்மா என்னடா போம்மா என்னப்பா வாங்க போம்மா என்னப்பா வாங்க போம்மா என்னடா போச்சு விட்டாங்களா என்னப்பா போம்மா என்னடா போம்மா
Pooma. All right, guys. See you tomorrow for day 2. Before that, the swags are being distributed outside. Please don't rush. It's being given at the both exits behind, not at the front one. So if you think you don't want swags, you can use the front entrance. But if not, you can use the back entrance. Queue, please. We'll have swags for everybody. So.
of all, okay. Hi, good evening, everyone. Okay. First of all, I am Sounder. So, Sounder, I am a founder of OnLive Studios. So, what is OnLive Studios? I just crisply I will say. So, it's a live streaming company. We do live streaming. So, we cover events like sports events and weddings and virtual meetings. Of course, the same thing which is going on live. And whoever missed the previous sessions, I mean morning sessions or afternoon sessions, you can go to OnLive Studios at YouTube and you can watch it. So this is all about OnLive Studios. And we have three founders, co-founders also, Varun as well as Tajuddin. And hope today everyone has enjoyed, and thank you for being with us and keep support us. Thank you.